All right, everyone, good morning. Welcome to the second day of BazelCon. Very happy to see everyone here bright and early again. Just wanted to remind everyone of our community guidelines. Please let anybody with a green lanyard know if you see any issues you're concerned about, and we'll address them as soon as we can. Also a reminder for office hours, should be a sign-up sheet for office hours at the front desk. Hopefully you've already signed up if you're interested, but if you haven't signed up and you are interested, please do, to make sure we have space. And don't just put an X there, put your name so we can count. All right, so let's get started. First off is Alex Eagle. So Alex, come on down.
Thank you. Good morning, everyone. It's really an honor to be given the time slot of day 2 keynote, which is definitely not something that I am qualified to present to you. So I know I'm jumping ahead of the talk a little bit, but I want to let you know that, not only that, but I had very bad sleep last night because the talk you're about to hear is very unusual, not something I've given before, probably not something you've heard before. There's going to be a lot of honesty and revealing myself to you. Also didn't sleep well the 2 nights before that, so I don't really know what I'm going to say exactly. It's going to be almost as much of a surprise to me as it is to you. Hopefully a pleasant surprise, but I can't really promise anything. Yeah, let's get started. I should say I've been wanting to give this talk for a very long time. This book is old. It's from sort of different days in America. I kind of liked it. It was on my shelf for a long time, and it's non-grammatical, which is why my talk is called "I'm an Imposter, and So Can You." It's really just that I wish I was as funny as Stephen Colbert, which I'm definitely not. But it's something to aspire to. I've been wanting to give this talk since I was on the Angular team, and I sort of started giving conference talks, and I felt like being the person standing here with the microphone is a big responsibility. And you want to sort of convey some sort of expertise, because surely there's some reason that the organizers chose to accept this talk, so I must have something useful to say. And I've never really seriously pitched the idea of giving this talk, but I was inspired by Igor Menard, the tech lead on the Angular team, who gave a conference talk at the Angular conference. This is a very big conference, 1,500 people or something in the room. And he gave a talk that was really non-technical. It was more emotional and about being a developer, which I thought was great because he could give a ton of great technical content. But that's somebody that I think I was really inspired to hear that from. Okay, so we're going to spend a long time on this section, which is unusual for a talk. About the speaker. Okay, so here's my bio slide. Let me see what it says here. Okay, founder and CEO at Aspect. That was my product talk yesterday. We're not going to get into that. It says I was ex-Google for a while. Software engineer is what SWE stands for. As a tech lead on systems adjacent to Bazel. I've sort of been working on Bazel since 2008. But notably not on the Bazel team itself. I was never actually granted a position on the Bazel team. So we're already into sort of questioning. Sorry, it's not time to question this yet. Right now I'm confident. Okay, so my bio's great. Okay, so that's the first bullet. Okay, second bullet, I was the tech lead for the Angular CLI. This was we had, I think, probably 1.2 million users at some point. Pretty big responsibility. There was a time when Angular was by far the most popular web framework. Maybe there's something to talk about there. Right, and then I founded Aspect to bring Bazel's promised benefits to all developers, which sounds very grand and ambitious. Okay, but this is not true. I was actually hired as a software engineer in test at Google in 2008. And depending on who you ask, software engineer in test is a different job ladder than software engineer. Job ladders are very important at promo time. You have to claim that the things you've done are the things that you were expected to do. And the question was always, are software engineers in test expected to be able to do all the things software engineers do? So software engineers can build these massive services and deploy them to Borg and have they can build Google Photos, and you just type in a search term and it finds that in your photos. This was before everybody expected that machine learning had gotten us to the point where, of course, the computer can just find the photo based on the text you enter. It's never clear if the interview process for software engineer and test was held to the same bar as it is for SWE. So maybe I was hired at Google under the pretense that all I could do was testing and not actually do software engineering. So I'm going to have to start adding some red sections to my bio here. Like, this is very, very questionable. Not only was I hired as a software engineer in test, but I did eventually switch over to the software engineer job ladder, but without re-interviewing, because there was some manager at Google who felt that the process should be made more easy for people to change job ladders, because legitimately sometimes people feel like they want to do something different with their career. And so they temporarily did away with this requirement that you re-interview in order to become a software engineer, just later to reinstate it. So I snuck through this little window and was able to put software engineer on my resume, because it's not a lie. But do I really feel like I was a software engineer at Google? I don't know. Okay, it's going to get worse. So yeah, I was the tech lead for this Angular CLI project, and the CLI was a build tool, and we all know a few things about build tools. But I had no idea how to write an Angular application. I really didn't know how to write a front-end application at all. I remember the day I got my first day at Google was the morning I got in the car, and on the radio they were announcing this Google Chrome browser. And I was really excited because I thought, so Google is going to solve the problem of me having to do everything in a browser, which I don't really enjoy. I would rather have desktop applications. I'm sure Chrome is going to have a way to switch my banking site and my code review tool and all of these things to be sort of feel like desktop applications. Because I was really uncomfortable with things running in the browser. So I became the tech lead for a framework that 1.2 million people were using to write apps in the browser, which I didn't feel was a good idea. And then I would give conference talks. I had one in particular to this large conference, and I could not write any of the code that the attendees could write, and I could barely read what they wrote. And as sort of a build systems person, I was always looking for compiler errors. So I was pretty familiar with the kind of errors you would get from the compiler, but I had no idea what the application would do when it ran. And so sometimes people would say to me like, after we compile it, we're going to run it, and then something, and I sort of give them a blank stare, and I'm not sure what language they're speaking. Yeah. So we're gonna cross that one out. While we're at it, I don't know. All developers seems kind of grand. And in fact, I'm standing here now giving you a talk about imposter syndrome. I am not an expert on imposter syndrome. So it's sort of ridiculous. It seems like if you want to hear about imposter syndrome, you should find somebody who really knows about imposter syndrome. But I'm going to try to give the talk anyway. So yeah, I am in fact an imposter. Imposter syndrome is this idea that other people have an expectation that you know something, but you don't think you actually do know that thing. And it might be that they've told you that that's the expectation. That's kind of rare, I think. A lot of times you infer the expectation. You see that your coworkers seem amazingly adept at understanding some detail about a data structure, or the reason that memory is retained from the analysis phase into the execution phase, or exactly how depth sets work. And you feel like you probably should know that stuff as well as they do, but you don't think you do. It may be that you give yourself a really high bar, that like you've projected to other people, just like you do if you're standing on stage at a conference, that you're really competent and you're an expert on things. And then privately you feel like you've been marketing yourself a little bit beyond the point that you could really back it up with facts. And if you got into a conversation with an expert and you were trying to convince them that you knew all of the things that you said you know, you're not sure that you would really convince them. And maybe they would tell you, it doesn't really sound like you know what you're talking about. But even worse is that they pretend that they think that you do know what you're talking about, but really inside their heads, they're thinking this person is clearly an imposter. And so really my objective in giving this talk, at least the first half, is to reveal myself in this very personal way, that I really know much less than you might think, or less than I would expect of myself. And that's okay. And I think there's a lot of value in having someone try to make something feel normal, especially in this world of social media where we all have a really nice polished outlet on LinkedIn to present ourselves in the best possible light. It's really unusual for somebody to go on LinkedIn and post that their project actually didn't work out, they got moved off the team, and it was really actually their fault because the design that they came up with was much too ambitious for the amount of resources that they could reasonably get on the project. They didn't really understand how to pitch it to all the relevant stakeholders. They didn't want to have to talk to their skip level about why their project matters. That's not the sort of thing that you read. And so we all easily get this expectation from reading what others write about themselves that that's accurate, that that's sort of, but in fact, they're presenting the little thin veneer that they want to the world. Of course, we all do this. So maybe some of you feel like a fraud because you don't have the level of expertise others expect. And I considered having a sort of let's raise our hands at this moment. But of course, I'm the only one who's expected to be brave enough to raise my hand and say, yeah, that's me. But I would like for all of you to imagine raising your hands if you think you might be an imposter. And I'll pause for a moment while you're imagining. Okay, most of the room, okay. Okay, I have a question already. If you don't feel that you're an imposter, can you pretend to be an imposter? No, no, please don't. I mean, you could, but then you might make other people feel like there are many imposters in the room when there aren't. Maybe a couple of people are the only ones, so we don't want them to get the wrong impression. In fact, it probably is about, according to this survey at least, which is about all tech employees, and we are one slice of that, but very common, more common than not, that engineers feel to some degree that they are an imposter. And from the same site, they give some tips about how to deal with imposter syndrome, and I want to try to step through these briefly. Because I feel like in good faith, if I feel like I'm able to be effective as an imposter, maybe I can help those of you who imagined that you were raising your hands. So, of course, number one is acceptance. And I mean, all of these sound really obvious, and I had to dig through this a little bit at 2 a.m. this morning when I was walking around the park here wishing I was asleep. So acceptance is really confessing this thing to yourself. Because the first person that you're trying to fool and maybe the most critical person for you to convince is yourself. So this step one is to stop trying to convince yourself that you're not the thing. And I think this has a lot of danger with it because for a lot of us, our own self-esteem and ability to present ourselves at work is perhaps based on having convinced ourselves that we couldn't possibly be an imposter. We know all the things that we said we know. They're on the resume. Like, I'm sure I can show up to work and prove this to my coworkers today. But from what I read on this website, the longer you sort of try to fool yourself, the harder it can be to work your way back out of this problem. Learning to be comfortable with the uncomfortable. This is sort of like how to see without seeing or something. It sounds metaphysical and impossible. I think this is an attitude of showing up to situations, being bold and brave, and thinking that no matter what happens, you'll be okay. It's an adventure. Stepping into a position at work that you don't know much about is the great unknown. It's what makes life exciting. Step three, I have my best friend says, comparison is the thief of joy, which is a nice little concise way to express that it's really hard to feel fulfilled if you're always looking at what other people have. And in fact, I think there's a broader lesson from this, which is that we all tend to assume that other people know most of the same stuff we know, plus some more. So I assume most of you know the things I know about Bazel, but also you probably know like how a depth set really works under the covers or something. I listen to talks from someone like Fabian, and clearly he understands a lot more about Bazel than I do. I assume he also knows all the same things that I do, plus some delta, right? But part of this idea of comparing yourself is that there are things that you know that the other person doesn't, and because they're trying not to be an imposter, they're not going to really tell you that a bunch of the things you know are not things that they're experts at. Number four, give yourself credit you deserve. I like to think of this one of the smartest engineers on the Angular team would sometimes, I think, fall into this mental trap of thinking that failures were earned. So every time something screwed up, I could have done something better about that. This was probably my fault. While successes were luck. Oh, this went well. It seems like probably somebody else contributed a lot, or I just didn't have the sort of obstacles that I might have had with this project. And attributing things to luck or skill is, of course, a judgment call, and so you're free to make the opposite judgment, which I think is much more beneficial in your career and in dealing with being an imposter, at least in my experience, which is to just go ahead and assume that successes were earned and failures were bad luck. Who's to tell you otherwise? Number five, reach out to your seniors. other people on your team have things to teach you aside from technology. This does require opening up to them a little bit, but they may have been an imposter. I mean, 58% of tech employees thought that they were. They might still be an imposter like me, and so they might tell you things that you're surprised about. Maybe that helps you feel like it's more normal. And of course, develop a never give up attitude. I mean, this is sort of, what is this, like an inspirational talk about anything in life? I don't even know, how did they give me this slot? This is really a day 2 tech note, keynote. It doesn't feel like it to me. So anyway, I'm not going to give up. Okay, we're going to keep going through this talk because I'm just going to be brave. And I think there's something about never give up where if you look at the trajectory of the rest of your career, starting from this moment, sitting in a chair or on the floor, sorry, and up till you're finished and you've had like whatever successes you'll have and retire. Right now is the moment that you are the least knowledgeable and experienced of all of the time from now on, right? So like, I think never give up is also a little bit of, over time things change, and if you wait, waiting has a lot of power, right? The same way that water carves a river through a mountain, time has a lot of leverage, and so if you just keep trying, like you probably will be improving over time, and you'll get out of this moment that you're in right now. I hope I will. Okay, so now I'm going to try and pivot a little bit and give a talk that's relevant to BazelCon and developer infrastructure. So I'm going to zoom into number 2. We'll go back up that list for a moment, and this is what they wrote. Maybe you have a colleague who is an expert in a language you know nothing about. Maybe the situation might make you uncomfortable. It might make you think you know nothing. It might make you a little bit afraid to go up to this person and just start giving them details about this language, and clearly, like, it takes a long time to learn a new language, right? And to be proficient in it. And so I think this is the key to why developer infrastructure engineers, in my experience, are often feel like imposters, which is that the more languages we have to deal with, the better the chances that you can't possibly know all of those languages. And yet you have to interact with colleagues who do know those languages. And so you're forced into that same uncomfortable position, and if you can learn to be comfortable with the uncomfortable, I think that helps a lot with being able to go to your colleagues who work in all the languages in your repo, and probably they're always trying to add new ones, and you're like, oh my God, I have to learn Rust, and then you look at the syntax, and it doesn't really parse in your brain, and like you don't even know how to start. That's how I feel about Rust. But I better pretend that I know it, because I think we're going to try to contribute to Rules Rust or something. I'm sure it'll be fine. Yeah, it'll be fine. So here's my framing of why it's okay for you to not know all the languages. Okay, so let's take an analogy with product engineers. And in a lot of cases, the product engineers on your team are the language experts. So these are the people that you're a little bit afraid to be outed to. You don't want them to discover that you're a fraud. Do they understand the user data that's stored in the system that they've built? And I think the answer is pretty clearly no. The users of their application are probably in some domain that they're not an expert in. They're an engineer. Like in some companies, engineers have a background in the domain that they're working in. If you work in robotics, maybe you have a background in linear algebra or something. But across a wide system, especially a generalized software that is used by lots of different people, you'll never understand the data that they're putting in there. It's a total mystery. You couldn't learn all these domains that they work in at any depth. And so what are the things that you do care about as a product engineer? Well, you have a data schema. So there's some layout of how the data is stored at rest. There are invariants about how that data has relations with each other. There are logical constraints in any application code that processes the data. And then sometimes you have to do data migrations. And so you know enough about that so that whatever data somebody stores in your system, oh, well, they violated the schema, so they can't store that data in the system. I don't understand what that data is. So I think this analogy carries over pretty neatly to developer infrastructure. Except in our case, our users are the product engineers. And so they're also widely varied. You have ML researchers who are doing something that only in the last couple of years anybody really cares about. Working alongside embedded real-time systems engineers who they care about kilobytes of memory for some reason. People working on user interfaces like that Angular app I talked about. JavaScript happens in there. And so all that code is a mystery, and you can't possibly be expected to learn all the languages and frameworks in any depth that your users are using, right? And what you do care about is the data schema, the invariants about how the schema relates to each other, how to migrate the data, how applications should process the data, right? And in our case, applications are things like build tools, static analyzers, the data schema, I think is kind of key. And I'm going to get into that in a minute, but first I have one more aside, which is that even if we've accepted, we take step one of the list of 6 things, and we accept that, oh, I'm kind of an imposter. Yeah, this image was generated by, what's the chat GPT thing that was before text? Open DALL-E, yeah, thank you, DALL-E 2. Because I asked it for an engineer going to the well to get water with their laptop, and it did. It's very good at that. Okay, so what on earth is this person doing? So this is my extended metaphor for developer infrastructure in general, which is that product engineers, if they come from, let's say they come from a single language, they're used to using the build system that comes with that language, or whatever the framework recommends. And they end up having to learn a little bit about build systems. They end up having to dive into essentially a lot of details. They're the build cop. They have to understand the optimizations that take place before they ship artifacts. Maybe they have to be the release engineer. So it's kind of like they live in a village and they go to get water from the well, which is not to say that people who live in villages are doing something wrong. Clearly, like, that's where you get water at that scale. But if you're using Bazel, you're probably in a monorepo. You're probably trying to approach something at scale. And so what you're doing is providing municipal water supply. And you're telling engineers, hey, don't go to the well. You can just turn on the faucet and water will come out of it. And at first, like, they're not used to doing that. So you're trying to get them to change their behavior, right? And you're trying to provide a service that you think is really useful to them. And sometimes it's baffling why they, number one, don't want to use the faucet, but then number two, once they start using the faucet, they just think water magically comes out of the faucet. And it's a very thankless job, I think, to be developer infrastructure engineers, because our users take these things for granted. Outages are horrible, but they don't notice when things work, right? And so as developer infrastructure engineers, we're trying to encourage them to change their habits, and we're in fact sometimes making rules. We're the governance body in many cases about what practices are allowed in our monorepo. And so if we don't understand their code, but we're telling them how to do their job, then that's an obvious recipe for feeling like an imposter. And so my recommendation is, yeah, go ahead. We have like those 6 steps of how to deal with it, use those, and go to product engineers and pretend to be the expert. So I only have a few minutes left, but I want to try to tie this even more specifically to Bazel. I think the specific practice that I like to employ, and I'm a little embarrassed to be in Germany saying this because, I mean, in California, that's fine, is let's just be non-rigorous and think that all languages are basically the same. I mean, how different could they really be, right? I mean, there's interpreters and compilers, but other than that, they're pretty much the same, I think, mostly. And from the point of view of the developer infrastructure engineer, that schema that I talked about is the thing that all of our user data has to conform to. And so if we can make all languages pretty similar in terms of the schema of how the constructs that we store on disk in Git are related to each other. Sorry, not everybody uses Git. I know there's still a lot of Perforce users here. So the schema is roughly the following. And I'm not going to try to, I have a few more slides, but I'll try to illustrate partway. But I think I'm just hoping to paint the picture here. So you have third-party dependencies. Developers choose what packages they're going to use. They express those somewhere in a file. Our job is then to resolve those dependencies transitively, ideally pin them for supply chain security, have integrity hashes. Then we need something to download and verify those. It might be our CTX download, like the Bazel downloader, but it might be other tools. Those dependencies all have to be installed on the disk. Okay, that's every language. We have to do that. In some cases, the dependencies also have to be compiled. In some cases, they're static. Then we have to build a program. So now we start from the import statements. We construct a dependency graph. Bazel does the loading and analysis phase. Then it needs to fetch all of the tools and runtimes involved. Run those tools, ideally with just the run binary rule. I recommend highly. And then they either have to statically or dynamically link things. And when I say link, it sounds like a C++ term, but really all languages have some concept of symbols that are foreign to the application that you've shipped and therefore need to be resolved when the program is running, right? So that's the third step, is when the program runs, it has to have some way of resolving dynamic links, which is to say, in JavaScript, going and fetching more bundles from the server. Or it could be, it could be the run files library involved over here, because that's the way you expect your program to resolve these things. And so just to illustrate, I mean, the beginning of that, I said developers express their dependencies. They write this. Probably at least one of these languages, somebody in the room does not feel like an expert in. But this is basically the code that's checked into your monorepo, right? So you're supposed to kind of roughly squint and pretend it's pretty similar. And yeah, I mean, other than the first line, I even have them syntax highlighted the same, which makes them look really similar. So then there's just all these different mechanisms. And as you context switch between languages, if you can find the commonalities here, so, you know, for third-party package constraints, there's some sort of semver range. And so in C++, how do we do this? I guess it's the module.bazel file because there isn't currently a packaging format, although I hear one's being discussed in the C++ community. For Java, you can use pom.xml, although that's kind of specific to Maven. And I think build.gradle has maybe a different way. Very much hand-waving. Swift has a package.swift file. JavaScript has a package.json file. Python has requirements.in if you're going to lock things. So that's not a common, that's not what everybody does. Some people just call it requirements.txt. Go is nice because you can just run go mod tidy and it figures this file out for you in basically all cases. I'm just going to take this forward partway through the steps, like I said. We want to resolve the dependencies. You'll see stuff, something like this. Either it will become an equals equals. Ideally, there will be hashes. This is Python over here, but they all kind of similar. And this is a different lock file in all cases. And here I have even more parentheses because they're not really the same, but they're pretty similar. So you run pip compile to get a requirements lock file. The Maven install file, Simon explained to me why there is no lock file in the Java world that actually works. And so rules JVM external had to invent one. For Go, the go.sum file, once you switch to Bazel mod, the go.sum file is read by Bazel. And so it's directly used as the input that pins and provides the integrity hashes for all of your dependencies. Then at some point, you want Bazel to understand the dependencies. And so ideally, Bazel's the one doing downloads, but in some cases like Python, it's pip that does the downloads. Some small differences, but at some point you want to have a dependency graph, right, in the external folder. So you're going to be able to write deps that point to third-party packages. The package manager is going to install the things on disk. And so, sometimes you rely on sort of class loader or runtime shimming tricks. Rules Python depends on tricks like this. But Matt will talk later today about rules Py, where we instead just create a virtual env so that all the standard tools work. So there are different ways of doing this. Every language has to do something like this, right? And then just imagine that I had enough time to continue, or imagine that you were interested in hearing me talk anymore. And I would tell you more things that are kind of similar about languages. There are really too many of them to get into, and I'm just hoping that this framework gives you a little bit of bravery to go into your product engineers and pretend that you know more than you really do. Okay, so thank you. With that, I think I have a few minutes left for questions, and I'm happy to take questions that are not about being an imposter. Be brave.
Alex, thanks for the talk. For context, I consider myself a C++ developer who happens to transition to Bazel because the previous build systems have been stupid and slow, of course. I'm wondering with how you approach it, the difference between developers and build system dev infra engineers. How do you hold developers accountable for improving what they did? So historically, the build systems allowed a lot of dependencies which might be useless. And like include what you use would help there a lot. Who is responsible for cleaning that up in your point of view?
Yes, so this is a good question. It's a sort of a specific thing that developers should stop going to the well, essentially, and follow practices in the environment around them. I mean, there's always sort of the carrot and the stick for this, right? So one is to sort of show them a nicer way of doing things, give them optional tooling to understand things like cyclomatic complexity. You could present somewhere, you can run static analyzers. For third-party dependencies, you can run some tooling that helps them understand which of their third-party dependencies are very out of date. There's an education component to that where they need to understand why they care about third-party dependencies, and I think code review is a great opportunity to give people career growth kind of feedback in that sense. So if your code review system, if you can present things there that show, maybe what you're doing here doesn't make as much sense. And then there's the stick where you simply say, we're going to outlaw something, which is also valid. I think that has to be applied very carefully. Number one, I would say in the context of Bazel, don't try to change their practices at the same time that you're adopting Bazel, because migrations that do more than one thing are more likely to stall, and are also, it's difficult to attribute problems that come up, to which part of the migration caused them. And code is easier than people. So when we're trying to change people and we change more than one thing, it can be very difficult to ascertain what change it is that caused the developer satisfaction survey to plummet. And I think setting up a developer satisfaction survey is important, because any of the ways that we try to force developers to improve what they're doing, we always have to do it with a mind that they appreciate that and are coming along willingly, because it's like telling developers they have to use a different editor. You can take it from their cold dead hands.
One more question? Be brave. All right. Well, thanks for a great talk, Alex.
Yeah.
Andreas. So next up is Andreas. Please take it away.
Thank you. Good morning, everyone. So yeah, now we're changing things up a bit with a very technical talk after Alex's talk just now. Yeah, my name is Andreas. I work at Tweak, where I lead the Scalable Builds group. And today I'm going to talk about our experience in migrating dependency management to BZL-mod and our rule sets. And in the spirit of being an imposter, BZL-mod is still very new. So, take the things I'm presenting with a grain of salt, but this is what we've arrived at so far. So to give a little bit of orientation, I'm talking about dependencies. And more specifically, I'm talking about external dependencies. So any kinds of dependencies that are not part of your source tree. And why would we care about these things? Well, because as engineers, we don't like to reinvent the wheel, right? We want to use the things that others have written already. So pull those into our project. So how can we get our hands on these external dependencies in Bazel? The old way that many of you will be familiar with, of course, is the workspace file, which is one single file at the root of your project. And in that file, you declare any kinds of external dependencies, like other rule sets that you might depend on, or package manager dependencies, or tool chains, or the like. So let me give you an example. So let's say we are the root module indicated by that little circle there. And let's say we are a Haskell project and we depend on rules Haskell. And so to get rules Haskell into our Bazel project, which is like rules Haskell is a Bazel extension to build Haskell code, we would write into our workspace an HTTP archive invocation like this that downloads rules Haskell and places it into this repo called rules Haskell. Okay, fine, but there is a problem. We depend on rules Haskell, but rules Haskell itself also has dependencies. For example, it might depend on Skylib. So how do we get Skylib? With this workspace mechanism, this is not actually captured automatically. So transitive dependencies are not taken care of here. The solution that people came up with, of course, are dependency macros. So rules Haskell exposes a macro that you can import and then invoke, and then that is going to import Skylib. But it's not really a pretty solution, because what if Skylib itself also has dependencies? Then the whole thing just gets a bit messy. And there is another problem. So to talk about that, let's shorten this import a little bit so we have a bit more space on the slides. So let's consider this duplicate import. We're importing rules Haskell twice, once at version 15 and once at 16. Which one wins? Raise your hand if you think it's the first one. Okay, that's a small number of hands. Yeah, in this case, it's going to be the last one. So the majority is right here. Okay, let's change it up a little bit. Let's put those load statements in between here. What happens now? Which one wins? Do you raise your hand if you think it's the last? Okay, most people here are right, yeah. So now it's going to be the first, because Bazel has to realize this thing to make the load work. But the problem I'm trying to illustrate with this is that workspace semantics are imperative, sequential, and subtle. So subtle is always great in software. And this gets worse. So let's consider an example in the abstract. Let's say we're the root module again as this dot. And we depend on rules Haskell. And rules Haskell depends on Skylib at version 1.1.1. But we also depend on rules Nix packages, Bazel extension to import Nix packages. And that depends on Skylib version 1.03. Which version of Skylib are we going to get in our project? It really depends. It depends which dependency macro do you invoke first. Does it do override checks or not? So this causes what you could call spooky action at a distance from time to time. So if you make an update to one of your dependencies or you reorder your imports, you might get very surprising consequences on some seemingly completely unrelated dependency. So to summarize the problems with the workspace approach, it does not resolve transitive dependencies for us. We need dependency macros to handle those. It is imperative, sequential, with subtle semantics, and the ordering matters. And it's also somewhat opaque. It's quite difficult to actually figure out where a particular external repo came from. And we get this spooky action at a distance problem. All right. So the Bazel team recognized the problem and introduced a new dependency management system called BZL-mod. And this is a new dependency manager for Bazel. And you can take a look at the BazelCon 21 talk by Shudong and Yoon to learn more about it. And the way this looks in your code base is you're going to have a module.bazel file. And in this module.bazel file, you're going to list your direct dependencies. It's declarative. There are no macros or anything that go crazy, at least so far. Let's see where we'll go with this. And then if rules Haskell itself has dependencies, then it only declares its direct dependencies in its module.bazel file, and BZL-mod is going to resolve the thing transitively for us. And there's also tooling to inspect it, like with Bazel-mod graph, for example, so the whole thing is transparent and there are no more surprises. All right, so we're talking about external dependencies, but more specifically, I want to talk about package managed dependencies. So what do I mean by those? So far, we've been talking about Bazel modules like rules Haskell, Skylib, and so on. Anything that's a Bazel project itself has a module.bazel file. But with package manager dependencies, I mean things like packages you import from Maven or packages you import from NPM, anything really that relies on an external package ecosystem. And why do we care about those? Well, again, we don't want to reinvent the wheel. Those package managers already exist and those ecosystems are established. Why rewrite them in BZL-mod or Bazel all over again? Okay, so I'm going to start to tell about how we work with this in the Haskell ecosystem with rules Haskell. And at first, I'll give a very brief and simplified overview over the Haskell package ecosystem. Those familiar with it, please bear with me. It's going to be greatly simplified. So in Haskell, we have things that we would call packages, like file path, for example, to deal with file paths, or JSON to serialize, deserialize JSON, or tasty to do unit testing, and so on. And then we have a thing called stackage, and stackage is a curated set of are snapshots that are a curated set of versions of packages that are known to be compatible with each other. And then there is a package manager called stack that you use to resolve the dependencies within such a snapshot and then download those packages and manage them. And the workspace integration we had in rules Haskell so far looks like this, where in your workspace file, you would invoke the stack snapshot repository rule. You would give it a name that defines the name of the repo to be generated. You give it a list of packages that you directly depend on, and then it will use the stack package manager to potentially resolve transitive dependencies. These will be exposed under labels in the stackage repo. And then you have an attribute to define which particular stackage snapshot you want. Those are like long-term support versioned snapshots. So this is just some number. And if you want to learn more details, in 2019, I gave a talk about this at BazelCon. So what's the problem with this approach? Let's consider an example. And as an example project, I'm going to walk through a Gazelle extension of ours to generate build files for Haskell packages. And this project is called Bazel Cabal. And Bazel Cabal itself has a few Haskell dependencies. For example, it depends on the file path and the JSON packages. So it invokes stack snapshot like this to get those in. Now let's consider a case where we are the root project. We depend on the Haskell package tasty for unit testing, but we also depend on the Bazel module Bazel Cabal. But now we have a problem because Bazel Cabal depends on file path and JSON, but we didn't import those in our workspace file. So they're going to be missing for Gazelle. So what we have to do instead is that we have to pull those transitive dependencies actually into our workspace file and import them there as well so that they're available. So again, the problem here is that the workspace mechanism does not offer transitive dependency resolution. So how does this work in BZL-mod? Well, what we want is transitive dependency resolution, and we get that with BZL-mod. So in that case, the root module is just going to declare, I depend on tasty. Bazel Cabal is going to declare, I depend on file path and JSON. And then BZL-mod is going to resolve all those transitive dependencies for us. So how could it possibly do that? How can BZL-mod know about Haskell at all? So BZL-mod is extensible with module extensions. And the way you use those is that in your module file, you would first import this extension with a use extension stanza. Give it a name. For brevity, I just call it stack here. And then you invoke those members of it, which we call tags. So here we say that our module uses the stack package tag with the name attribute tasty. And this says my module depends on the Haskell package tasty. And then this module extension is going to do some stuff and generate some repos, and we need to expose those repos if we want to use them. So there is a use repo stanza we have to put into our module.bazel file to actually get access to those package labels again. And we did it so that the labels stay the same, so the migration should be easy in your build files. And then if you are a module author and you want to write a module extension, then the way you can do this is very similar to how you would write a rule or a repo rule. There is a module extension built-in that you invoke. You give it an implementation function and then the list of tags that you're going to support. These tags are also defined with a built-in tag class where you set the attributes, and those attributes are very similar to the kinds of attributes you get on rules and repo rules. And then the implementation function also takes a context object similar to rules and so on. And you can iterate through all the modules that invoked your module extension in breadth first search order, starting at the root. And then you can iterate through all the tags that that module requested from your module extension. So how can we actually import packages then, since this is the goal after all? Module extensions have a couple of capabilities. They can perform arbitrary actions like download and execute, and they can invoke other repository rules. Unfortunately, we already had a stack snapshot repo rule, so we can just invoke that in our module extension. Okay, so how do we migrate the repository rule API to the module extension API? Let's first consider the package list attribute. The way we translated this is that instead of having a list attribute, we have individual tags for each package that you depend on. And the idea here is that thanks to this, you're going to be able to declaratively describe your direct dependencies. And you can do this across the module dependency graph so that you get the transitive dependency resolution. So that's the idea behind moving this list into individual attributes. Then we have the snapshot attribute, which would define which snapshot release we want to use. And that we also just turn into a tag. But there is a bit of a problem here. There's something lurking that we need to be careful about. So let's consider the case where we had the root and the Bazel Cabal module. What if root wants snapshot 2114 and Bazel Cabal wants a different snapshot 2012, for example? Which version should win, right? So what we do here is we disregard the intermediate one and we use the root one. And again, this comes back to those spooky actions at a distance. We want to avoid that some intermediate dependency update mixes up our build in the end unexpectedly. So we only look at the root module or the core module, rules Haskell itself, and disregard things in between for these kinds of changes. Then there is a more complicated case, which was an attribute that is of dictionary type, to pass flags to packages. So Haskell packages can be configured with flags. And the way we translated this was that instead of keying on the package name and then giving a list of flags, we just fold this into the package tag directly because, you know, that's where it belongs. But again, there is this problem lurking. So let's say we want vanilla JSON, but Bazel Cabal wants JSON with the -pretty flag applied. Which version should win? To avoid the spooky action, again, we disallow this in the intermediate ones. In some cases, maybe you could consider to kind of resolve those globally. I think this depends on the package ecosystem, what makes sense. All right, this part concludes Haskell, and now I want to take a look at rules NIX packages. And to give a really brief overview over what NIX is, in NIX we have packages, think like Linux distribution type packages, like compiler tool chains, system libraries, system tools. And then we have a thing called NIX pkgs, which is a very large collection of packages. It's really just a Git repository. What it contains is pinned version, the dependencies between those packages and their build recipes in code in this repository. And it's available in multiple release channels. There are stable releases and there's an unstable channel you can follow. And NIX itself is also a flexible language that allows you to do ad hoc overrides of packages, or even come up with ad hoc completely new packages if you want to. And you can also learn more about this at last year's BazelCon talk. So what did the workspace integration look like so far? We had one set of repository rules to import Nix packages repositories, and then another repository rule to, or set of repository rules to import packages. So for example, if you want to import the Nix.pkgs repo at a stable version, then you would, for example, download it over HTTP like this, and if you give it the name Nix.pkgs, this is sort of the standard repo. And then if you want to have a package like GNU-awk, for example, then you could just say this, and this would look for a Nix.pkgs repo in your project and would then import from there. Or if you have a use case where you want to do a custom override, version override, or something like this, you could, for example, get an unstable Nix packages repo and then specify that with a repository attribute that you want to have the package from there. And you can also give it a different name if you want to do this. Or I mentioned Nix is a flexible language that allows you to do overrides or custom packages. So in this case, we're saying, I want the GNU-awk package, but I'm going to use the Nix language to actually include a couple awk extensions to support CSV and JSON support in the language. So you can also do these kinds of ad hoc overrides. So how can we manage to migrate these kinds of things to the BZL-mod module extension framework? So let's first consider this in the abstract. Let's say we have our root module, and that sets Nix.pkgs revision 2305 and imports awk. We have module A, which uses a different Nix packages revision and also imports awk. Which version should win? You're going to see a pattern here. We're going to cross out the one at module A and going to stick to the root module or core module definition. Similarly, if root is asked before, but mod B does an unstable override and wants to set awk as an unstable version, which version of awk should win globally? In this case, also, we avoid the spooky action and cross this out and say the root version wins. And what does this look like in code? You import the module extension Nix repo for repositories. You say, I just want sort of the globally resolved Nix.pkgs repo version. And you import the repo to get access to the label. And if you want to do an override, there are override tags. So you can say in your project, I actually want a different version like 2305. And then you use the HTTP tag, for example, to download that. But that is only allowed in the root or core module. And for a package, it's much the same story. It's called Nix.pkg. And you can say, I want the awk package as it is sort of globally resolved. And then import the repo to get access to the label for it. If you want to override it, you can use one of the override tags, like expression, for example, to pass in this custom Nix expression to override the CSV and JSON extensions. But this is also only allowed in the root and core module. But what if we have a case where module B really needs this unstable version, perhaps because it has a particular rule that depends on some particular bug fix or something like this. Or maybe module C really needs this custom override feature because it maybe has a gen rule that does the JSON CSV thing or something like this. How can we allow this in some specific cases, but still avoid the spooky action where root all of a sudden gets a different version of awk than it expected? Fortunately, Bazel just introduced a new feature for module extensions, which is isolated module extensions. And what this means is that module B and C can stick to their respective overrides, while the rest of the project gets the sort of globally resolved default behavior. And the way you can do this is when you import the module extension, you set the isolate parameter to true to mark it as isolated. And then if the module extension is implemented this way, it can allow you to do things in a non-root or core module that you would otherwise only be allowed to do in root or core. And finally, again, you import the generated repo to get access to the label. And this is available as of Bazel 6.3 with this flag experimental isolated extension usage. And then if you are an extension author, the way you implement this is that you check the isolated attribute. I'm doing this here with getAttr for backwards compatibility since it's experimental still. And then you can decide what logic you want to apply to decide whether overrides should be allowed in your module extension. All right. Finally, I want to do a brief note on use repo stanzas. So use repo stanzas in the module.bazel file. We've seen a bunch of them. They are necessary to get access to the repos that are generated by the module extensions. I won't go into the details of this, but it can be seen as a bit of a maintenance burden. You end up having to duplicate things in your module.bazel file. You have to invoke the package tags, for example, but you also have to invoke use repo in the module.bazel file to get those repos imported. And fortunately, there is bulldozer automation support. So for example, if we go ahead and comment out the awk import here, and then run a Bazel command, like Bazel mod graph, for example, then Bazel is going to print out a bulldozer command line, and if we execute it, it's going to fix up the module.bazel file for us. But to support this, your module extension has to do some work. In particular, it has to return the extension metadata object that you can create like this. And you can take a look at this proposal, automatic use repo fixups, if you're curious for more details. And for those of you who are familiar with hub repositories, I think with automatic use repo and isolated module extension instances, there's probably no more need for hub repos in most cases. I'd be curious to hear what your thoughts are on this. But yeah, if you haven't heard of hub repos before, then don't worry about it. All right, in conclusion, what we covered the tenets of BZL mod. It is declarative. You declare your direct dependencies. Transitive dependencies are resolved for you. We have no more surprises, and we avoid the spooky action at a distance. To migrate your repository rules to module extensions, you can map your repo rule attributes to tags. You can try to make it so that the labels that are generated are the same as under the repo rule, so that the migration is easier on the build file side. And then you can consider what kinds of things should be allowed globally, what should be restricted to the root or the core module, what should be allowed in isolated extensions. And then make use of the automation, return extension metadata from your module extensions, and make use of bulldozer automation to manage those imports. There's a whole lot more to module extensions that we didn't have time to cover. For example, we didn't talk about toolchains. We didn't talk about testing module extensions or Bazel modules. We didn't talk about how to release on the Bazel Central Registry, for example. If you're interested in these kinds of things, come talk to me or many of the other people familiar with this in the room. Or join our Bazel Hour on November 2nd, an online meetup where we talk about migrating to BZL mod. And finally, a few words about my employer. I work at Tweak, where I lead the Scalable Builds group. We contribute to open source build systems like Bazel, Bug2, and so on. And we help our clients with their build system migrations, optimization. So if you have build system issues, then come talk to us. Check out our page. And Tweak is also part of a larger platform called Modus Create that does platform modernization, DevOps, security, and other such things. All right, thank you very much. And yeah, maybe we have a bit of time for questions.
Hey, thanks. Great talk. So as a monorepo maintainer, something we get asked a lot is how can I get like some project want to use some dependency on some version while the rest are using the rest of the versions. So I was wondering if the isolating option could in a way be used for this, other than creating another repo?
Yeah, that's a good question. So the question is on the recording, but yeah, so in principle, potentially that could be done for this. Something to consider is if you're talking about third-party packages like Maven imports or the like, then if you use the isolated module extension, isolated module extensions are isolated, meaning they don't see anything of any of the other instances, including the global one. So you're not going to get any sharing between those. So if you do this, then you are going to duplicate a subset of your transitive package dependency graph from this. And this potentially exposes you to the diamond dependency problem, right? If you have some target that depends on this part, and then you have overlap, you might expect some bad things. So one of the reasons why we support this here in the Nix packages use case is that with Nix packages, something you very often import are tools, executables. You rarely link them together. You typically use them in a build action or something like this to generate some files. And of course, there are also like API constraints potentially, but it's much less risky in terms of diamond dependency problem. So yeah, I would wield that with very much care. Quick questions.
Yeah, I was wondering if you're aware of any plans, because I think the Bazel mod file might grow very large, but I think so far there's no way to import macros from other Bazel files.
Yeah, so I mean, I'm not one of the developers working on the modular Bazel support, but yeah, this has been discussed, how to split up the modular.bazel file, because it can become a bit of a choke point when it comes to code review and merges and so on. I mean, I think we should just be very careful, whatever we do there, to avoid making the same mistakes that ended up being the case in the workspace mechanism. And yeah, this is something that needs to be worked out. Yeah.
Yeah, so basically, currently we have two ideas. One is to support import statement, so you can basically add the content of another module.bazel file to the same file, and we just report error as if it's the same in the same file. The other one is to allow import Bazel file from the same repository, so you don't note from any other external repo, but that should help with the maintenance and avoid the spooky problem. Yeah. But please join the BOF session if you want to learn more.
Other questions?
So on the Haskell side, you said that you are going to resolve to the newer LTS, to the one in the root, but sometimes packages get dropped from LTS when you move to the next one because incompatibility with JC and so on. So what would happen if Bazel would depend on a dependency that is now dropped on the new LTS?
Yeah, that's also a good question. So in those cases, the root module would have to provide some kind of fix for this. So one thing could be is maybe could update to a different snapshot version. Something that's supported with a package management system is that you can have local custom snapshot where you sort of add additional packages. With the integration, you're also able to just import a particular package release directly from Hackage. You do this by just appending the version. Or you can also include sort of Bazel build vendored overrides. So yeah, that would be the answer. In the root module, then fix this up. Yep.
Any other questions? Oh, yes.
Your concern about disallowing the spooky action at a distance, that is your decision, or it is something that the Bazel mod extension mechanism itself encourages or requires?
So I'm not sure if I read it in the docs anywhere. It's just something that in the workspace mechanism we have experienced a number of times and wasted many cycles on trying to debug these kinds of surprising changes when we did a completely unrelated update or import order change, or clients that ran into those issues and then came to us with very confusing behavior and said, what's going on here? And so we just want to avoid putting the same kinds of traps into this new mechanism. And I think it would be a good thing to try to strive for with Bazel module extensions, but I don't know if there's sort of a general recommendation for this in the BZL mod world.
So we basically, the extension API is structured in such a way that it allows you to basically anything. It gives you all the access to the data across the dependency graph. So you could do something like rules Haskell / Nix PKGS, where you say only the root module is supposed to do something. Or for some other package managers, maybe it makes sense for you to say, I can actually smartly merge all your requirements. So it's not spooky action at a distance, it's just action at a distance. That is easily understandable or clearly described or whatever, depending on the ecosystem you're in.
Yeah, and I mean, some sort of transitive resolution also happens here with the transitive package dependencies. They're going to add new transitive dependencies into your build graph. So you are going to see some effects, like longer build times, for example. But we were just striving for not messing up the configuration of the build that the root module expects. Yep.
Maybe one more question. For great talk, Andreas.
Thank you.
Right. Next up is Ivo. Thank you.
So Thank you for a very nice presentation about Bazel mod. I love where the whole idea went and how the module.bazel syntax looks like. It's really amazing. Wonderful work from both of you, Yun, Shudong, and others in the community. My talk is about Bazel rules. Okay. So Bazel rules are probably one of the most extendable parts of Bazel, and actually even a very large part of our code base. They allow you to support arbitrary languages and also other things beyond languages. I will roughly split the presentation into 3 parts. Past, present, and future, or maybe almost past, as it always is. Stereotypification is the first part. Then our present is implementing the new APIs to extend and structure the rules. And last but not least, I would also like to present some of our future plans and ideas that we are discussing. So this is one of the slides from previous keynotes. The stereotypification project is about rewriting native rules that are part of Bazel that were written in Java into Starlark. And then at the end, we would also like to split those rules away from Bazel. Does anybody have any idea how many lines of code we are talking when we are talking about native rules in Java? So its implementation, it's around 250,000 lines of code. Together with tests, it's 380,000 lines of code. Now, next question. How large do you think the sub-team at Google is that is doing the rewrite? Actually, there's 1 person per language, roughly. At best times, we had 2 persons per 1 language. But that was an exception. So this is the progress that we are making, counting actually all the lines, not just the lines of code. On the left side, you see lines of Starlark code that we've written over the years. The order of magnitude here is 10,000 lines of code. On the right side, you can see the amount of native lines of Java code. The order of magnitude here is 100,000 lines of code. Where are we? So how are we doing the rewrite? We are moving from outer layers into inner layers. The most outside layer being the rule definition and some implementation that directly pertains to a single rule. Then we are moving into middle layer, which is a shared rule implementation. You will see common providers like Java Info here, Java Common Module, or CC Common. And then the last thing in our plan is to rewrite the actions that are special to languages. We already did the rewrite of languages that actions that can be rewritten in Starlark already. So starting with proto rules, the rewrite is complete. The number of lines of code here is not exactly correct because there's only proto library and proto common. Also, language proto libraries that were part of core are done, and the rewrite here is complete. So all the layers, outer, middle, and inner layer. Python rules, we had support from external person, another team member at Google. The rewrite is almost complete. All of the layers are covered. There is some use of private API, which would involve either cleanups or extending the API that Bazel provides. But the state is pretty good here. Similarly, it is with Java. Java rules are written up to the middle layer. There is a special Java compile action, which we are leaving for later. What you, for example, can see on the right side, there's still a lot of code in there. So the biggest chunks there are C++ rules, Java, and Android rules. Why we can't remove Java? Well, because we need to rewrite more of Android rules first. Android rules, they are handled by Alex, so he can probably answer your questions better, but the rewrite is you won't see it here on the built-in starter rules because the project took a different approach and wrote the rules directly in the repositories, in the depot. But also the large majority is done. I believe that Android binary is the most essential missing part there. During our rewrites to Starlark, so for example, Java info is nowadays and Proto info in Starlark. We also needed to improve Starlark providers. So we did several improvements. Those improvements also were okay for others that are already using Starlark providers, mostly about reducing memory footprint. The result is actually amazing. In one case, we actually have better memory consumption in Starlark than in native. What I'm leaving for the last here are C++ rules. You can actually see a large code of a large chunk of Starlark code already written. Also a large chunk of code in native still there. Those are probably the hardest rules to rewrite. We moved this year into rewriting the middle layer, but we haven't finished yet, and we'll probably spill this effort into next year. Also, one thing that you are not seeing on all these slides are we are also handling other internal-only rules. Now, if you, how good idea do you have about how big is the whole Bazel team? So looking at the front row, probably most of the team could sit there, maybe a bit in the second row also. So if you imagine that Bazel team is its own company, it's a very, very tiny company. Google is a very large client, and we don't really have good means to know about every language and to do support on every of the rule sets. You can even imagine how hard it is to answer all of the GitHub issues if there is one person per language that we currently have. We have an agreement that the best maintainer or owner for the rules are also the toolchain owners, because toolchain owners usually have also the expertise in the language. So this is internal restructuring, or I'm not sure if I'm able to call it this way, that we are trying to achieve. Externally, we are also going to move the rules eventually into separate repositories, and this was actually the ask from the first day. We will need to ask the community to do the maintenance, because I think our efforts in our teams are better used in improving the core functionality. We are the experts there. What we will continue to do is offer support and advice how to implement new features, either at Google or potentially also externally. So once those rules are moved into separate repos, there are going to be more people involved, and there is potentially some need for governance of those repositories. We prepared some procedural proposals about this, and also some proposals about how to best maintain rules repositories. I believe that community also has such ideas already, and I don't think that they are incompatible in any way. It's just another set of ideas how to structure the rules repositories better so that they are also easier to maintain. So one big problem that I'm talking about is maintenance of the rule sets. And there is also an idea that once those rules are in the repositories, you're able to fork them and implement your own features or remove the features that you don't need. I would say that this is a bad idea. We have an example internally. We have a couple of forks of Python rules. The maintenance, well, you would think that for Python rules, you need 3 persons to maintain them. At the moment, we have 1. Think about that before forking the rules, because when the maintenance is dropped, this becomes the user's problems, and they need to either maintain the rule sets or migrate to another rule set, which is never fun. To alleviate this problem, we are working on a proposal how to extend the rules. So basically, the idea is do not fork, but extend them. So what we imagine will be part of Bazel or part of the rules repositories that are maintained by Google are baseline rules. Those are actually the rules that you nowadays see in Bazel, the major ones, the Java, C++, Proto, and Python. And from those baseline rules, if you need additional features, we don't have time to implement or maintain them, you can extend the baseline rules to implement those. So it's possible to either do the extension internally for arbitrary company or to do extension for smaller Bazel users. To be true to this cause, we are also going to do the same internally. So all of our Google rules will be extensions of the baseline rules. This way we can meet different needs. And one thing also more important, once Google language expert take over the maintenance of the rules, if they have to solve a bug, fix a bug, they will most likely need to fix it in the baseline rules if it happens there. So you also get the same, you reduce the maintenance cost, and also Bazel Community gets the fixes. If internal team needs to implement a new feature, we'll consider if it's generally useful and either implement it in internal rules or in the baseline rules. So here I have an example how the extending rule works. Maybe one thing, what's the first thing that you notice about this code? Well, it doesn't compile. It's written upside down. You have the definition. So here is an example of Google Java library. Its parent rule is Java library. It has its own implementation function. And then the attributes are actually merged from public attributes from Java library. And you are able to overwrite an attribute to, for example, here, add an aspect to it. So the public contract is somewhat compatible to Java library rule. This somehow affects also the projects that Google open source. If we would like to move from Google, a project from Google tree into Bazel, we would like to keep the same interface for the rules, even if there are some features missing in the baseline rules. The rule has its own implementation function, and it can call it actually has to call exactly once the parent rule. So that's context super. It returns the providers. Then the rule is able to add some providers to it and return them. That's the very simple basic ideas. We are also adding some cookies on top of that, and we are pressure testing this idea against our internal rules. So most likely we will add additional API where we need them, but they will also be useful for others. Second API that we are working at present on is subrule. This one is more about structuring the rule. The origin of this idea is coming from previously proposed coding guidelines. There was a ton of user response on those coding guidelines that it's hard to just follow the guidelines, that we actually need an API that enforces these guidelines. So structuring the rules proposal implements a new construct that's called subrule. Subrule is intended to be reusable and also to be well encapsulated. So here you can see an example structure of a binary rule. It would need to compile and validate the sources, for example. It would reuse basic libraries. So those smaller circles are example of subrules. And then you could also have a linking subrule. Those parts could be also reusable, some of them in implementation of a library rule. How does the code look like? Also written upside down. So you have an Android lint call, which is a subrule. It has its own implementation function, and you are able to define implicit dependencies or private attributes. Those are the encapsulated parts. Only the subrule can access those private dependencies, and it can expect to work in different contexts. The implementation function is a bit special. It takes context as a parameter, but this context is very small. It doesn't have any attributes. Then source file is an example of an arbitrary parameter. Types are not fixed there. And the last parameter is the Android lint tool, which gets injected into the implementation function. So you access it over the parameter. What the implementation function can do, it can declare new actions. It can do anything. It can also call other subrules. It's able to work with providers, construct them. However, you see best splitting and structuring your code. How is such subrule used in a rule? So you import the Android lint call. You need to declare it on rule where it's being used. And then from the implementation function, you only pass in that 3 parameter source files, and the context and the implicit dependencies get passed in automatically. Where are we with this? So this is a partial roadmap just talking about the new API. At the moment, we are wrapping up experimental implementation. We would like to cherry pick that into Bazel 7. It's not completely finished yet. And we would also like to ask everybody, users, to test drive the implementation and report where the problems are. Along with that, we are also refactoring baseline Java, C++, Python rules so that they fit this model, that the rules can actually be extended. In Q4, we will mostly focus also on using this API on the internal rules. We are going to structure the Java rules using a subrule. Java rules are a good playground in this respect because they are complicated enough, but not too much. And the last goal is to also consolidate this API. Later on, we will reassess if this API should really be generally available. So at the moment, it's going to be available only under an experimental flag. Now, the last part, future plans. So Bazel has a motto that it's fast and correct and you can trust to. What nobody is telling you that you will also need some more RAM. So fast, correct, no memory consumption, choose to. But we do dream big. So here is a quote from Bazel team member. I'm not sure I heard 95% correctly, so I will keep this source anonymous for now. So I already mentioned consolidating the API. Our future vision is standard built library. What we would like to achieve is, after all the rules are in the depot, that we have also a standard library with which the rules are created. We would like to have this library as small as possible, as stable as possible. Why? Imagine if this interface is stable to Bazel, then rules repositories can have a completely separate timelines from Bazel releases. So you are able to get features faster or bug fixes. Next one is include scanning. This is another long-term plan. Once we are finished with middle layer of C++ rules, we would like to look into how to support this in a better way in C++ rules and potentially also expose the API for other rules. And I must say that I'm conflating include scanning with a lot of things that are happening in C++ rules. A bit of imposter here. So back to reducing memory consumption, and those are my last two slides. First-class macros are a current effort, which is looking also into reducing peak memory usage. Quick run through. So those are also called symbolic macros. The design is already online. We are bringing macros closer together with the rule, and we are enforcing the coding guidelines on the macro. So macro needs to have a name and needs to create targets that are following the prefixes. Last but not least, introducing type annotations and decorators for Starlark. This is far, far away in the future, I guess. But also notice one thing on this slide, it's the first one that's not upside down. Thank you.
Hi, Petrus. Lots of questions. Stand us over here.
I have a question regarding rules extension. So is the functionality only limited to adding additional providers, or can you also invoke like additional actions?
You can add actions. So we have a big discussions if you should return all of the providers in the same shape from parent rule, or is there another way to meet is a relationship? So we have some use cases internally where we slightly modify Java info provider, and this seems to still meet is a relationship. So we'll probably allow some modifications to providers as well.
Will it be also possible to, for instance, extend the list of outputs? Because it can be especially handy if you have like static code analysis, because usually those like you need to intercept the compiler call, and then you need to add an additional input output, which is basically some data file.
This is modifying the fault info provider.
Yeah.
Yeah, you can.
Okay, super. Thank you.
Good question. Let's go over all the way over there on the left. My left.
You mentioned that the best owner of the rule sets are the toolchain owner. Did you convince Android team and Go team to own rules Android and rules Go?
I asked before Alex about that.
Sorry, the extending the rules, does that require the rules to be implemented in Starlark? Like if we wanted to implement, like enhance the CC library rule, for example, does that require the work to be done for the Starlarkification or?
So outer layer of CC library, CC binary is already done. It's a built-in rule in Starlark, and you are also able to extend built-in rules.
Okay, cool, sweet, thank you.
About the new macros, how does this affect the querying capabilities? So am I going to be able to query macro targets? Am I going to be able to dig into the underlying rule targets? What sort of is the vision there?
We don't know yet, but we know that we need to support query there as well.
A quick question about the creation of or modification of dependencies of actions after they're run in the way that CC compilations do, where they're parsing MDMFs or the equivalent of any language. Does that mean that that's going to be accessible via Starlark? And will that be generally accessible? Meaning I could write it for whatever language I choose, where I can change what files influence invalidation? I know this is a long question.
We would like to do general support. Actually, on these projects, we don't even have design candidates yet.
Ideas welcome, though. Somebody has a microphone.
I have a microphone, yeah. So I have a question about the type annotations that you mentioned, because I think I heard from the back two people that they already have static typing in Starlark. So I wonder if it's going to be compatible, or you're talking to them.
Yeah, so actually we are starting from a different perspective. I was thinking about those types because I would like to reduce boilerplate that's around rule definition. And I would also like to bring macros and rules closer together. So a typical constraint is that it's very easy to write macros and very hard to write rules. Having more similar syntax, I would also like to see that users get more comfortable writing the rules. About the question, yeah, I think so. The back-to approach is a bit different. They're typing just Starlark functions, not rules, macros, or other things. But it makes a lot of sense to work on compatible type structure. And we have a lot of fear here. Types are hard. Even major languages made mistakes there.
Hi there. If you wouldn't mind just flipping back to the nice graph you had about the progress of the Starlarkification. It's really great that it's going down for all lines of Java code, but if you look really there, it looks like the lines of code in Java never have any comments on that?
Yeah, we are using private API. So sometimes we expose new API to the built-in Starlark rules because we know we need to follow up with a cleanup. And it's probably better that we schedule them separately, not together with Starlarkification.
So yesterday, Tobias got asked about C++ 20 module support, but he deferred the question to you. So here we are, and in particular, in relation to the lack of dynamic dependencies, how do you think this can be implemented performantly, and what can the community do to speed this up?
Okay. I need to explain my imposter syndrome here. One person per rule set, I'm doing Protos, and I've never written a .proto file in my life. C++, it's a bit the same. Our main focus next quarter are going to be C++ toolchains because they proven to be the biggest pain point for the users. We don't have module maps on the roadmap for now. Those might happen later when we learn more about them.
I think someone has a mic there. Yeah. Please.
Just one question about symbolic macros. One question about symbolic macros. Will there be a way to control like visibility of targets that are created in those macros? Like, can I have, let's say, private intermediate targets, or will everything be exposed in the build file?
Oh, that's an interesting question. I don't think the visibility is part of the proposal at the moment, but I also think that we should consider it. In general, what's within the macro, only the main target should be visible and not the auxiliary targets.
Because
in principle.
Because it says like make tests and everything, which kind of has or seems to be able to be accessed from outside. I don't know, but just by test runner or anything.
Tests can be private. You can run them directly.
Okay. All right. Thanks.
One last question. Evo will be around the rest of the day. And probably
There was a quick mention of module maps. I just want to say that's not C++ modules. That's something different.
Where can I hide? Maybe I also need to mention there's rules, birds of a feather coming after, so there's also time for more questions.
Exactly. So thanks very much, Ivo. And then, again, keep the questions coming. Come to the birds of a feather on the 6th floor. We have 15-minute break. Back either here for the talk or at the BOF on the 6th floor at 10:45.
Yeah.
Okay. Yeah, good. All right, everybody, let's get started. Please have a seat. Oh, sorry. Great. So next up is Mihai, and I guess Noah's going to join you. Right. Very good. Thanks.
Thank you. Hello, thank you. I am Mihai Marusak, or to paraphrase Taylor Swift, it's Mihai, and I'm the speaker. And Noah has been my intern over the summer, and he implemented most of this work. So what are you going to talk about is securing your Bazel artifacts using Salsa. And let's basically go first through the problem and then how to solve it. So let's say we have two people, Alice and Bob, like typically in cryptography, A and B. And Alice is developing software, Bob wants to use it. So the animation, it's already there. And by luck, the software that Alice develops is exactly what Bob wants to use. So Bob decides, instead of re-implementing the wheel and spending time and so on, he's just going to use whatever Alice develops. But there is also Mallory, exactly like in cryptography, that tries to own Bob. So let's see how this goes. In order for Bob to use the software that Alice develops, there is actually a pipeline. Alice writes the code. This code gets put into some source repository, let's say GitHub, but maybe somewhere else. From there, you get some dependencies, combine everything together into a build, so you create a final artifact. This artifact in general is deployed to somewhere, for example, on PyPI or on a GitHub release page or NPM and so on. And then this artifact gets downloaded by Bob and used as part of their build process, as part of their infrastructure in their production, and so on. So let's actually start with a very simple example. I selected C++, a very small source code that just prints hello from C++ and uses FMT as a dependency to print 42. And a very simple build rule. All of this is simple. So this is the code that Alice wrote, and it builds with Bazel. Bob wants to use this code. So Alice pushes this to a GitHub release. Let's just simplify everything and make it all GitHub release. Pushes it there, and just to simplify the life for Bob, it also pushes the binary directly into the assets. So now Bob comes to this page, sees that hello is here, and just downloads it and starts to execute it. What could go wrong, right? Well, Bob got bombed. So how does this happen? Bob panics, starts to look at the incident, tries to understand what happened. He looks at the release page, he sees the commit, he goes on the GitHub source code, he looks at the same commit, the code there looks right. So what could have happened? Actually, if you look closer, we see that the release has been done at some point in time, but the binary has been updated much later. So actually what happened here was Mallory had access to the GitHub organization, so he could modify the release page. So Mallory just created a malicious binary, uploaded it to the release page, and waited until Bob downloaded it and pawned Bob. So this is a typical scenario of an insider risk where somebody that has elevated access can exploit the access to then stage an attack later. Okay, so how do we solve this? One simple solution is to add a signature to your binary. But in the case where we have an insider risk, the insider can also push the signature there. So it's not really helpful, especially since most users would say, oh, I have this binary and it's already signed. It's all good. I can go with that. In order to solve this, the first thing is automate the release process. So instead of having a user start the release, then build the binary on their own laptop and then upload it, make everything automatic and then give access only to the automation to do the upload of the artifacts. This already reduces a lot of the insider risks because now in order to modify the binary, you would need to perform extra steps. What extra steps? Let's go back to the diagram. Instead of just compromising the build repository or tricking Bob to download the bad artifacts, now if I automate the entire release process, I will have to compromise the build process itself or the deployment stage. So I'll have two attacks way ahead in the scheme. Okay, so let's go back. Let's automate the release process with GitHub Actions because I'm just using GitHub. It's simple. I just do a workflow where I run Bazel build inside the workflow. And then I also have another step where I upload the artifact to the release page. And if I do a release like this, now there is 5 minutes ago, the binary got updated, is exactly when the release tag got created. All is good. So now Mallory is not able to modify this because he no longer has access. However, we are not done yet. As I was saying, there are still avenues of attack. Like you can see in this diagram, Alice could, by mistake, submit bad code, or a dependency might be vulnerable, or an attacker can actually compromise the build control, the build process, and alter the CI/CD and so on. And this is actually something that happens. And this is an example. Let's say somebody sends a helpful PR to your organization, to your repository, and in the thousands of lines of code, there is also this thing. In the CI, they just download something from somewhere on the internet and immediately pipe it into Bash. The CI passes, maybe you don't notice this line, or maybe you notice it, you look at the URL, and at the time it's a really useful dependencies, that's something useful. But this URL is owned by the third party. So at some point in time, they might just deploy malware. Malware is going to run on your CI, is going to change whatever artifact you are releasing. Then they can immediately replace the URL and make it serve regular stuff. So now you still get owned. And this is not theoretical. This actually happened. You might want to take screenshots to look at those QR codes for more information, but this actually happened for the SolarWinds attack. They basically got owned because the build system got compromised, and 18,000 of 300 customers got compromised. And in their postmortem, basically, they said two things. The first thing was that they needed reproducible builds. So once you have a binary, you could rebuild it somewhere else and check if the two binaries are bit by bit compatible. And this would detect compromise. The other one was you can use SALSA to protect the supply chain. So what is SALSA? SALSA stands for supply levels assurance for security. It's basically several levels that protect your supply chain. And it's going to protect all of these highlighted avenues of attack. So it's going to protect compromising source control, it's going to protect bypassing CI/CD, and so on. How does it do that? The general idea is that as you are building artifacts, you are also generating a provenance. Basically, you are saying this artifact has been built from these materials using this build process. So somebody said yesterday that Bazel is working towards generating SBOMs, mentioned also the executive order from the US 14028. So SBOM is more like a list of ingredients that the software contains, whereas SALSA is more like the recipe. It's how you combine those ingredients to get the final artifact. And as I was saying, there is at the L in SALSA stands for levels. That is because there are 4 levels. Level 0 is the default where you basically don't guarantee anything. Anyone can do a release, can do whatever they want. Level 1 is just you write somewhere, this is how I build a package. So it could be either just the release workflow that we just saw before, or it's actually the SALSA format that just says, I build this package and that's all. And now level 2 and level 3, those are the more important ones. Level 2 basically guarantees that once you build a binary, it cannot be tampered after the build. So as long as it conforms to the provenance, it hasn't been tampered after you build it. Whereas level 3 is you cannot tamper the binary even during the build itself. So the goal is to get SALSA level 3 for all of the builds. So how does this work? Instead of having just one single workflow for the entire CI/CD system, so instead of doing the entire build yourself, you are going to delegate to a reusable workflow. This reusable workflow is in a separate repository. The guarantee is that an attacker cannot control both repositories at the same time. So as long as you trust the external repository, the SALSA builder, the SALSA framework repository, you are guaranteed that the provenance that that repository is generating cannot be tampered by an insider or by somebody abusing your CI/CD. And the general idea is, in your workflow, in your GitHub Actions workflow, you are saying, I want to build these artifacts, and I'm cloning the code, I'm wanting to build this one. After you build them, you are saying to the reusable workflow, generate a provenance for that. GitHub calls the separate workflow and gives you back both the artifact and the provenance as a file. And then you can attach them to your release page. Okay, so now there are two ways in which you can generate provenance. One is to use a generic builder that already exists, or to use a builder that is specific to the build framework or to the language. In general, using the specific builder is easier because it's already implemented. You don't need to do anything. You just call that, and that's all. The problem is the generic builder, because it doesn't know what you are using to build, it can only prevent tampering after the build. It's still during the entire CI/CD that you are doing for the release, but your provenance is only after the binary has been built. Whereas if we use a specific builder for Bazel or a specific builder for C++ and so on, the builder itself has visibility into what you do for the build. So it knows all of the steps, all of the parameters, and it can record them in the provenance. So basically, this gives you a bigger guarantee that the final artifact has not been tampered with. In order to do the Bazel-specific builder, you need to implement this. So you need to send a PR to the Salsa team to implement the builder and so on. Or there is the possibility to have the Salsa team create this for you. And the solutions that Noah picked is something that combines the benefits of both a generic builder and the Bazel-specific one. Basically, we are using a bring your own builder approach, where instead of you delegating the build to the Salsa repository, and that repository will do all of the work for you, now there is a second level delegation that happens behind the scenes. So here on gray, on project workflow and tools and outputs and attestation, that is me as the repository owner. So let's say I create a tool and I want to use Salsa for that. And everything that is in the middle is what's happening behind the scenes on the Salsa side. So in my GitHub Actions, I'm saying, I want you to build this artifact. So I want you to build this target, Bazel build // ... for example. And then the Salsa Bazel builder behind the scenes would first connect to run a specific workflow to get a token, to get a signature and so on that we'll see immediately later. And then we'll use that token to run a reusable workflow that would run Bazel build with whatever targets I specified. During this time, it will record all of the dependencies, all of the arguments that you have used for the build, including optimization flags and so on. And then we'll give you back both the artifact and the provenance file. So how does this look? When I do the release page, I have the asset, the hello binary, and I also have this intoto.json file, which is basically a JSON file that is the provenance. So let's look a little on what this file contains by itself. It's a JSON, so I'm going to use JQ to print its content. And we see that it has a payload with a specific type and some signatures. It can have more than one signature, but in general, you'll see just one of them. So behind the scenes, there was a payload that got generated that basically contains information about the build. And then this got signed, and this signature is stored in a transparency log. If you want to find more, this transparency log is monitored by Sigstore. So you can check whatever has been signed by you. Other people can check whatever has been signed during this period of time, and so on. Okay, so the important part that we want to look at, that depends from build to build, is the payload. So now let's look a little bit more into the payload itself. The payload is a base64 encoded string, so I'm going to decode that and then look into that JSON using JQ again. So one of the fields there is the subject, which is basically the binary that I built. So you see it's Bazel bin source hello, it's the binary, and a checksum. So if somebody changes the checksum, gets access to the release page and changes the binary, that checksum won't match. So if they want to hide their tracks, they'll have to generate the entire provenance itself. But because the provenance is signed, they'll have to also sign it again. But the signature is stored in a transparency log. So now you will see somebody that monitors the log we'd see that there are two different signatures, signing events in the transparency log for the same binary. So this could then raise an alert, and then somebody can detect, okay, there was a malicious insider here. Let's act on that. The provenance actually does more than that. So beside the subject, it also records the builder. So in this case, it says it's a Salsa framework builder at that specific version. So even if you don't trust the Salsa builder, or maybe the builder itself has been malicious, you can look at the provenance and detect, okay, I need to rebuild my stuff because this builder has been malicious or the builder has been compromised. Now I can detect whichever of my binaries have been using that builder so that I know to either rebuild them or remove them from organization and so on. It also records in materials, it records all of the dependencies that you have used. In this case, because it was just a simple binary, it only records the repository. And by the repository, it also records like what commit have I used and what was the tag. And this one is the repository, more details into that. You can see the GitHub reference and the commit where I did the release. There are a few more fields into the provenance, but in general, you don't want a human to look at them. You want this to be automated. So basically, the idea is that the provenance is kind of useless if it's not verified. And in general, when you download something from the internet, if it has a signature or if it has a provenance, that's not enough. You also need to verify that. So like if you have a GitHub action that says install some dependency, immediately after that, you should verify the provenance, or at least the action itself should do it for you. Okay, so how do we verify Salsa? Fortunately, there is the Salsa verifier that can be also put in a GitHub action. It's just a single command that you would run and will tell you if the provenance matches the binary. And I will also have an example for that. It is like this. So I pass as argument the artifact .fib, for example, and I pass the provenance path, and it verifies it. It tells me it has been verified. This was the generator. This was the commit where it was built. The provenance passed. You can put this into a GitHub action. If the provenance fails, stop the build there and raise an alert and so on. Basically, integrate it everywhere in CI/CD and work for that. Okay, so now moving back to the Bazel builder, because Bazel supports multiple languages, if your project builds, let's say, C++ and Python together with Bazel, you can generate Salsa provenance for that without needing to have a custom Salsa builder that would work, that would know how to mix Python and C++. So basically, everything can be done just with the Bazel builder. And if you use this, you have the nice benefit that all of these attacks are prevented. So now a malicious insider, even if they can get into your build environment, somebody that verifies the Salsa provenance can detect this. So SolarWinds most likely would not happen again if you properly generate Salsa. But there is more. There is an alternative called Salsa Rebuilder. If you remember from the SolarWinds postmortem, they had two ideas. One was to use Salsa, the other one was to do reproducible builds. So what is the idea behind the Rebuilder? Let's assume that you don't have visibility into the workflow of one of your dependency, but that dependency is critical and you cannot replace it. And maybe you don't completely trust their developers, but you really need to use that dependency or spend years of work to re-implement it. So what you can do with the Rebuilder is have a separate build process that would try to infer the build system, and then taking the source code and the artifact would try to rebuild it. So now you have two artifacts, the artifact that was released by the external party and the artifact that your Rebuilder built. If these two are matching bit by bit, then you know for sure that you can trust the build. And actually you can generate a Salsa attestation that says this artifact has been rebuilt and it works. This is the work that in general the Salsa team is doing now for OSS rebuild, for trying to rebuild the entirety of the open source ecosystem. So for example, of the top 100 packages on PyPI, where you don't know how they have been built, and you cannot go back in history to find out where they have been built and insert Salsa for them, the OSS rebuild is going to rebuild them and then generate a side attestation that says, we have rebuilt this and it works. It's guaranteed that the build has not been compromised. So what Noah did was trying to do a Bazel Rebuilder that would take an artifact, would take the provenance, and would try to rebuild it. And then will tell us if the rebuild matches the binary. And after he did that, he tried to use the rebuilder on several Bazel projects and discovered that a lot of them were not exactly using Bazel in a way that benefited from hermeticity. For example, they were doing pip install and then Bazel build, or they were installing tool chains, they were installing a lot of dependencies using the operating system, so outside of the Bazel sandbox, and then they were using Bazel build. And this, of course, breaks reproducibility. So the next step is to actually motivate the developers to either use hermetic builds with Bazel, or to work more on the rebuilder to take into account the operating system and everything else that got installed as a side. And that is all that we can do for today. So now we can stop for Q&A.
Why don't we start with Julio? We'll fix the mic.
Yeah, hello. So you mentioned GitHub Actions to run this check, but I wonder when you use a GitHub action, there is no validation that what you downloaded was trusted or anything, right? You specify a version number and that's it. There's no check and validation that the thing you're downloading to actually verify later something else is trusted.
So the provenance itself contains both the tag and the commit hash where the GitHub action was run. So if I go back to this one, I have both the tag and the commit recorded in the provenance. So even if you change the tag later to a different commit, the provenance will no longer match.
No, but you showed a tool later to verify this, right? The tool that you run in the GitHub action, that binary is downloaded by the GitHub action itself. And you don't verify that this tool is the one you wanted.
You can verify because this one also has a provenance. So the salsa verifier itself has its own provenance. And for that one, you either check or it also has a signature. So you can check the signature for that. You can check the provenance, or you can just JQ into it and look at the specific fields. At some point, it's a reflection on trusting trust. At some point, you'll have to say, I trust this, and then from this, I build the rest.
I noticed that in version 0.1 of Salsa, source code review was included as a requirement, but in version 1, as released, it no longer is. I'm just wondering if you do have source code review, is it included in the provenance in version 1, or is it just for the future?
So I'm not exactly working on a Salsa team, so I don't know exactly the full decision for that. But the idea for Salsa 1.0 is that there is a build track that the provenance covers. So whatever we discussed so far is the build track for Salsa. And there is going to be a separate source track that would cover source review, repository maintenance, like you have branch protection and so on. That would come at a later time.
Other questions?
Just from the vocabulary, I was wondering, you mentioned this Bazel builder. Is that, I didn't really grasp, is that a different Bazel binary? Is that some kind of add-on to Bazel?
It is an add-on to Bazel. So if I go back to this diagram here, you in your workflow, instead of saying, actually, let's go to this Bazel build command. So here, instead of saying Bazel build and the target that you want to build, you are just going to replace this with use the reusable workflow from Salsa that gives me the Bazel builder. And as an argument, you pass // ... I want you to build all of the binaries in my process. Or if you have a big repository and you have a top target, you are going to pass that top target.
I've got a question. Does the initial framework, the Salsa provenance framework, distinguish committed source code from committed but not properly released binaries? So if you just drop a binary in there and
yes, it's in the materials. It should record this is the code that is committed from the repository, so it deals with that. And if you're in CI action, you say download this from somewhere. and the CI knows to record this into the provenance, that binary can also be listed in the materials.
Well, I actually meant a malicious just copying a binary into GitHub. Are you actually looking at the, the attributes and so forth to figure out whether it's what type of artifact it is?
We're not looking into the binary itself. It's just recording. This has been the binary that has been used. That is the hash of it.
Okay.
So it's more for observability and transparency. It's not detecting malicious dependency. So that's why the inject vulnerability for the dependency is not highlighted in red.
Other questions? All right. Well, thanks very much.
Thank you.
Okay, next up is Murali.
Hi, I'm Morley. I'm working the build health team in Google, and we are in charge of shaping the build graph for Google. And I created a tool about 10 years ago on automating build files, and it's widely used inside Google and supports 20 plus languages and gets about 250K requests a day. So I must have done something right. So the hope is that, but unfortunately, it relies on internal Google technologies. We can't open source it. So we thought, okay, the next best thing we can do is I can at least tell what learnings I have made so others can learn from my mistakes. Okay, so first, what is build automation, right? So automated build file management is basically a process or tool which manages build files by making edits only on build files, and the source of truth is something else. So in particular, editing, formatting BZL files, editing your Java CC files, removing unused imports in your Java code is out of scope because we touch only build files and nothing more. In scope, creating build files, deleting build files, formatting them, editing them. Of course, for formatting, we already have Bulldozer, so we just call out to Bulldozer and don't reinvent it. So where can it be used? So you can use it as a save hook in your IDE. So every time you save your CC file, transparently this tool runs and it takes care of your dependencies for you. Or if you're the VI Emacs person, you go VI Emacs, do your thing, and then you run the tool before you do a Bazel build, sorry. Or it can be part of your CI workflow. You make your code changes, send it to CI, and CI will say, hey, you forgot to add these dependencies. Or, no, this is a big dependency, please replace it with a small one. And lastly, and more importantly, it can also help code janitors with their build changes. So for example, think of a person like, okay, I want to replace package.1 class with package.2. So I can do my find, grep, sed, whatever, make the change in your code base. And then I want to say, hey tool, I just made a bunch of changes. Please do the necessary needful things. And I just focus your attention on these two classes. It's important to focus your attention on just these classes because you don't want to fix the world. You just want to fix one little thing to make things easier for the reviewer, for example. So what are the things which an build file automation can do? It can optimize the dependencies via static analysis. That's the easy part. It can add and remove rules as needed, because it can also recognize rules which are no longer needed. It can add new build files, which is a nice way of making sure that your packages don't grow very large. It can help refactor rules. It can help avoid common mistakes. For example, like how often do people write a foo test.cc and, hey, I've written my test all good, but oops, I forgot to add a CC test. So the test was never run. Right? And can also help enforce various best practices. Like, do you have too many sources in your rule? Or do you have too many roles for a given source? So these are all problems in their own way, and the tool can help you identify these things. So first question is, why do you want to optimize dependencies, right? So pick a Java library rule. Let's say we have a dependency which is used, one which is unused, and one which is missing. So what's wrong with this? Missing dependencies are bad. Why? In some languages, of course, they break the build, and nobody wants a broken build. But in other languages, if you know that there are no missing dependencies, you can make the builds more efficient. Like, for example, in Java, right? If you depend only on these 5 dependencies, then when you call the Java compiler, you only need to pass those 5 jars to the Java compiler and not the transitive closure of the jars. So that means the action executes faster and builds go faster. Unnecessary dependencies are also bad because they unnecessarily slow down builds. Because why wait for an action to compile something which I'm never going to use it? And it increases binary size because nobody wants to download 2 gig binaries. And of course, even in cases like, say, C++, where there is dead code stripping, the linker has to do a lot more work. Because if you know that you don't need it, don't give more work to the linker. Okay, so all this, so now we know why we need to optimize dependencies. So the first things you need to do, one of the crucial things you need is to resolve imports. So what is an import? Resolution is basically mapping an import to a build target which provides that. And when I say import, I mean it generally, like in Java, it's called import. It's in C++, it's include. For BZL, it is load, and so on. So each language has its own terminology. So import is in general, right? And the thing is that imports may or may not correspond to types in your language. Like in Java, you import classes and methods, which are symbols. In C++, you import headers, which are not classes, right? So imports may not correspond to types. So let's look at different ways to resolve imports. The easiest way is just toString manipulation, right? So I have a Java library which has foo.java, and I see an import for alt-bar BazCraft. So where is the target which provides it? Hey, it must be alt-bar BazCraft, right? It's very easy. The mapping is trivial. I just replace the dot with slashes, the last capital letter with a colon, lowercase it, and I'm done. Right? This works perfect. And there's no need to interact with Bazel. It just works. And it is so fast that it can be an on-save hook. So what's wrong with this? The problem is it requires your entire code base to satisfy this condition, right? So you need to guarantee that every alt-bar BazCraft.java is present in that particular location, which may not be possible if you have third-party dependencies. Because you don't control the code which you import, and you cannot rewrite things. And we know people like to use sources equal to glob. You glob everything together, then clearly these things won't help. The other problem is it couples your source code with your labels, because it adds friction to code janitors. Because now let's say I want to rename this class. That means in order to keep following the naming convention, I also need to change the build graph. So coupling these two makes refactoring hard. Okay, there are some other cases where this thing doesn't work. Like in this case, I have a package which spans multiple directories. So even though I have alt-bar BazCraft.java, but my build file is one level higher up. So which means in the previous slide, the position of the colon is in the wrong place. Another case is, well, I have the code all correct, but it is not in alt-bar BazCraft because all my Java code is inside some other directory, right? I imported from Maven. So it's there inside something /source/ whatever. So in this case, the Java package and the Bazel package don't align. So how do you fix this? Well, throw in some configuration, right? So add some configuration which says that, hey, this is a Bazel package. This directory does not have a Bazel package. You need to go up one level to find the Bazel package. Or you say that, oh, this is a new Java source root. Like for Java packages under this, please look there. Well, that allows you to handle violations for some conventions. But what if the rule is named something else? Like people can do whatever they want. And if you start having configurations for every one of these, then you're essentially building an index. And then you have the problem of, okay, how stale is the index? How fresh is the index? Is the index manually maintained? In which case, if you end up with a manually maintained index, you end up saying that, hey, instead of writing a build file, you're writing the index file. So you're back to the same problem all over again. But none of these will account for violations caused by local changes in my client. Like I've made some change in my client right now, and now I want to run the tool. Can the tool adapt to these changes? So these are some problems with this approach. So let's look at another approach, right? So we want to, let's say we're talking about Java. Who best knows about Java than the Java compiler itself? So let's rely on the compiler, right? So we just change the rule implementation or add an action, add an aspect somewhere, and use that to discover what imports are required and provided by each target, right? So for example, if you have a code like this, the action is going to generate some output like that. Okay, this thing provides these two classes, package.outer and package.outer.inner, and it requires these two classes. Note, in this case, by looking at the code, you do not know whether helper actually is an inner class of JSON reader or it is a package private class. There are two different interpretations for the same thing. The compiler knows, at least it can know if it has the right dependencies. So once you get the compiler to produce this output, then checking your dependencies is simple, right? You just reconcile all the required list of your target and compare it with the provides list of all the dependencies, right? So what is the pros and cons? So in this case, the compiler understands all the language nuances, so you don't have to worry about it. You don't have to worry about naming conventions because you don't care. And if you're missing dependencies, then if the right dependency happens to be in your transitive closure, then it's easy because you have done this, getting this list of requests and provides for your, like, let's say you run an aspect, right? So you have this information in your transitive dependency and you can say, hey, that particular target, this was there in its provides, therefore it should be here. For unused dependencies, again, it's easy, right? Almost. Because you can just say that, hey, this dependency provides this class, but my target never required that class, so I don't need it. Of course, there's a corner case where if you need one class which is provided by two dependencies, then which one do you remove? That's a problem. And it may be consistent, it may not even be consistent across fronts. Like, let's say if it's a Java compiler, then depends on which jar it happened to read first, that may affect the output. But the downside is you need to build. Builds can be expensive. And you need to know what flags. Like, am I building for this architecture, that platform? I need to know all those things. But I'm just looking at the imports from my Java code. Do I really need to know whether I'm going to compile for Android Nexus 1? The other thing is this works only if you have syntactically valid code. If you don't have, if it's not syntactically valid, your build fails very early and you have no information whatsoever. If your dependency you're missing is outside your current transitive closure, you have a problem again. So you need some logic outside Bazel anyway. And finally, it is not easy to do this for all languages. For example, for C++, like we include headers, but the compiler and the linker only care about C++ symbols. So the connection is not obvious. Like, do you instrument the preprocessor? Do you instrument the compiler? I don't know. So here's the third approach which we found useful. Just automate the user. What would a human being do? Right? Looks at the source code. Okay, I read the source. I see this import. I see that I'm importing this, so which means I care about this class. See that I drop the inner because it's an inner class, so these two classes are tied together. Therefore, I only need to resolve the outer class. Then I need to look at the Java roots. So this is where I still need some configuration. And I'll say, okay, I'm going to look inside workspace. Okay, so this is a possible source. This is what I want. Is it there? Find the rule which corresponds to that. We'll get how do we do that in a second. And then add the dependency. So just automate the user. So how do we find the rule? So let's say we are looking for cruft.java. And as part of looking, we realize that the build file is not there. It's one level up. So we discover this as part of resolving. So we don't need any configuration, nothing. And we see something like this. So we see, okay, I see two Java library rules with cruft. And a third one, which is a macro, which also has cruft. So all three are good candidates. But then I realized that, okay, I use Bazel query, look inside and see that, hey, actually checklib is nothing to do with Java. It just generates some sh test, which maybe greps the Java file to see whether some bad strings are there. So that is not really the right rule. So which means my choices narrowed down to 2, 1 and 2. But 2, the problem with 2 is that it includes an additional source, which means whoever is depending on this is picking up unnecessary stuff. So I shouldn't use 2. So which means I'm down to 1. But 1 has private visibility and says, as a deprecation, saying do not use. So what do? Then, because I know the entire package, I can look down further and see that, hey, the last rule API that exports 1 and that has a visibility to some package group. So which means if the rule I am analyzing is in this package group, then I'm good. I can use that. If not, I know that I need to change the visibility of this package group so that it is made visible. So all this is what a human being would do, and we can just automate just that. And how does this compare with the other approaches? So this understands the rule semantics. Right? You need to understand the relationship between the rules. What does the exports attribute mean? You understand that this macro generates an sh test. I'm looking at Java, so I don't care. You need to understand the language semantics. It adapts to all local refactoring which you have done on your client. It degrades gracefully if resolution fails. So for example, in the previous step, like if that for for the string manipulation, if the target doesn't exist, then the tool will succeed. You do a Blaze build and it will say just fail, no such target. Here, as part of the resolution, we are kind of verifying that the target exists. So if the target didn't exist, I would fail early and say that, hey, I was not able to resolve this. You human, please do it. And this does not need a build. Like all we need is Bazel query. We don't need to do an expensive build. The downside of this is that it depends on Bazel query. So interim versus string manipulation is fast, so this is not as fast. We still need some configuration. I need to know where the Java roots are, like Java code may be here, maybe there. It needs to understand some code generation. Like if I have a gen rule which produces a foo.java, that's good. I can immediately see that it produces foo.java and I'm done. But the problem is that foo.java hopefully is in the same the package. I don't know till I execute the gen rule, but I don't want to execute the gen rule because it slows things down. And one of the big cons is that there's limited support for preprocessor directives, right? So let's say we are talking C++ and you have a hash if def. So what do? I can assume, all I can do is assume that I need to satisfy both the hash includes, and I give you 2 dependencies. But in practice, you don't want both of them. You want exactly one of them. I don't know which. So we'll end up adding both, and the human has to say that, okay, I'm going to take those 2 out and put them inside a select and say, if POSIX, then do this, otherwise do that. Okay, so now we have finished the resolution. Now the next thing to do is to update the build file. So that should be easy, right? So there are 2 main ways to do it. So one is what I call syntactic edits. So what happens is the tool internally generates the rule which it expects to see in the build file. So Java library, foo, sources, whatever. Then it looks at the build file to see, is there a rule like that already? And it matches by the name of the rule or the type of the rule. And then it tries to reconcile the 2. So for example, if the build file currently has foo with some sources, some visibility, and depths as X and Y, and the tool internally says that, okay, I want to create a Java library for foo whose dependencies are A and X, then it matches this with this and says, okay, I'm only going to change depths to what I think it should be and leave everything else alone. So which means any comments, any visibility, whatever is there is still left alone. Because if you overwrite the whole thing, then of course that's bad. Okay, so the good thing about this is all comments and all attributes not managed by the tool are preserved. So that's good. There's no need for Bazel query. Therefore, it's fast. The cons is that it's sensitive to the matching logic. And when macros are in play, things may not work out well. Right? So Let's say you have a build file with, hey, this Java library has foo.java in its sources, but it's named something else, and it has an additional bar.java in its sources. And there is something with foo.java in its sources, but it is not a Java library, it is some magic library. Like, I don't know what it is. Maybe magic library is a macro which just says I'm Java library, right? Or maybe it is Java library together with some additional checks. So you don't know how to merge these things. So it's a problem here. The other way to do it is to what I call semantic edits. So you start with a source file and use Bazel query again, and look for rules in the package which has foo.java in its sources, right? So let's say this is your build file, right? You're loading mylib, which has a macro and has sources equals foo.java. It is not srcs, but some sources. And turns out that this Bazel thing, what it does is it just creates a Java library whose name is slightly different. And for fun, it renames sources sources to srcs. And it takes an additional argument called Java deps, which it maps to deps. Okay, but because we use Bazel query, I'll actually expand the macros, and I will see here that I have a Java library rule called foo_impl with sources equal to foo.java. And now that I understand the semantics of Java library, I can go do my analysis. And then the result of the analysis tells me that, okay, I need to set the deps for foo_impl to bar. Then I go back and look at the macro, figure things out. And then I will convert this and say that, okay, the semantic change of foo_impl.deps equal to bar should be converted to the syntactic change of foo.java_deps equals bar, right? In order to get the deps of the generated rule to be bar, I need to change the Java deps attribute of mylib. So that the semantics to syntactic mapping needs to be done. And then you apply your changes, and you're good. Right? So what are the advantages of this one? Right? So everything is driven by the build graph and rule semantics. So there's not much guessing going on here. Naming conventions don't matter, because I'm just going to look at the output of Bazel query. I don't care what it's called. All I care is it has foo.java in its sources. Macros can also be supported just fine. The only thing is I need to know the mapping for from foo_impl.deps to foo.java_deps. I need that mapping. Okay, and all we need is to associate some metadata with the macro and expect the macro to satisfy some best practices. Right? Of course, the downside here is I need this metadata. And we can make it easy. And the thing is, Bazel already makes it easy to get this metadata in some ways. Like, for example, if you look at the output of Bazel query, the line right here basically tells me that this, this should be Java library, but okay. So this Java library rule was actually generated by this macro defined in this Bazel file. So once I have this information, I can go look up that Bazel file, and basically we have a comment or some pragma you can add there, which gives you the metadata you want. So let's say you decide to implement this on your own team or company. So what do? So my suggestion is that if you can force your will on your entire code base and declare that, okay, everybody has to do this way, and you must name this way, etc. And any external code you have, of course, you can't enforce your will on the entire code base or your external dependencies, but what you could do is you could transform them when you import them, right? If you're willing to do that. And if you only care about dependency management, because so far we have been only talking about just the dependency part. Like, for example, you don't care about visibility. Like, if it's not visible, okay, the human being has to go do it. In these cases, then I think the best solution is to just use string manipulation for your resolution and just deal with syntactic edits, right? So this is going to be fast. There is no requirement for Bazel query. That's the main reason why it's fast. And I mean, your latency you could expect around in the hundreds of milliseconds. In the other case, I would suggest that you just go all in on Bazel query, automate the user, and use semantic edits, and your latency will now be 1 to 2 seconds, right? This is what we have got. So what do we do in Google? For Go, we actually use the string manipulation and syntactic edits because the language was created late enough that we could enforce our will. For all other languages, we automate the user and use the semantic edits. There's some small number of internal languages which my tool doesn't support. And for Java and Kotlin, in addition to automating the user, we also rely on build artifacts, primarily to remove dependencies. It's hard to add dependencies, but it's easier to see that something was not used. So that's especially useful because Java and Kotlin have a lot of generated code. So it makes sense there. Okay. The last section is how you can help make your build files more tool friendly, right? So why do you want to make them tool friendly? Because it's easier to make them easier for tools to edit. And more importantly, it's also easier for humans to reason about. Remember, build files should have no logic, pure data, declarative, and stateless. That's what you should aim for. BZL files, they have to be pure logic, no data, which users care about, and you care about the API, like how clean it is to use. For example, avoid variables, right? So yes, you can do this in build files, but it's not a good idea because this makes tooling hard, right? If I want to change the dependencies of this rule, what do? Do I add something here? Do I edit this variable? But maybe this variable is used somewhere else, like here. Then it'll affect that also. It's hard. Instead, what you should do is, like in this case, this is begging to be refactored, right? Because this is a mapping from sources to dependencies. So make it explicit. Let Bazel know about it by creating a rule with that name. And you have the same thing. And now things are a lot easier for tools to manage. Macros. Don't add convenience steps, right? You can have a my library with sources equal to foo, and your macro says, it's trying to be helpful and says, you know what? I know you don't want to keep typing these dependencies over and over again, so I'll add this whole list of things just in case you need them. The problem is that my tool can tell you that, okay, you don't need utils, but I go look at the build file, I don't see a utils to remove. So there's nothing I can do. Right? So this leads to more unnecessary dependencies, which, as we know, is bad. Third thing, avoid list comprehensions. So here's an example of a list comprehension, right? You're trying to be helpful. You're saying that, okay, I have a bunch of sources. For each source, create a library rule with that source and a bunch of dependencies. The problem now is that the sources are different. They have different imports. So shouldn't they have different dependencies? Why are you forcing them to have the same dependencies? So now this forces the dependencies to be the union of the dependencies of all of them, which means that when any of these dependencies change, right? So if any of these change, then your CI pipeline will have to treat all of these rules as dirty and rebuild them and retest them unnecessarily, right? And especially if you are paying for compute, it can add up. Okay, at this point, I'll stop. I have a bunch more slides, but for lack of time, we'll stop and time for Q&A.
So I have two questions. So first one is, how did you solve superfluous dependencies? And second I have is, how much gain you got by building this tool?
So right now, everybody in like half the developers in Google are using this. So the idea is that people don't care what dependencies you add as long as it builds. So you use that to your advantage and try to shape the build graph and say that, okay, I'm going to start moving people over. So, and they don't complain, their builds work. And that also means it helps the owners of other libraries and says, okay, somebody says, okay, I have a rule with 100 sources. So I use the tool, split it into 20 rules. And then that's the easy part. The tool can help. The hard part is now how do I go and find all the people who use my rule and fix them? Well, they don't have to do it because they can just walk away. And then when the other users use the tool on their code base, the tool will automatically figure out that, hey, you're currently depending on this rule, which has been refactored into 10 or 20 pieces. You need these 2 pieces, so I'm going to optimize this for you. So you start pushing everybody in the right direction. And I mean, one of the features we have is that you can automate this also. You can say that, okay, once you have sharded the rule, you can just run another variant, another flag to the tool, which will basically say, find all my users and just fix them for me as well.
Other questions?
So on the last slides, you presented like Bazel build cases that we shouldn't be using. Have you thought about automating fixing those?
Which one?
These ones and the ones before. So have you thought about having an automation that would fix these solutions, so like convert from before to after?
Yes, I actually did. I do have another tool which helps for things like this. And I did run it across Google Tree, and we removed all variables which are used for dependencies alone. The problem is in some cases like this, where you have a variable which is used for dependencies and which is paired with a variable which is used for sources. At least, okay, what I tried was just inlining these variables, right? But that is the wrong thing to do if these variables are paired with other variables. So the tool, I specifically recognize those situations and leave them alone, because there the right thing to do is to actually refactor it.
Hi, I just have a comment on this because this connects very well with a talk we had before that said something along the line of adding type annotation to Starlog. What I have been observing from users so far is having to learn how to edit build file and BZL file in general is a pain, right? Not having editor type completion is a pain. So I think the way Bug2 has been solving it is adding type annotation into it and then provide IDE support for it. But I think this could be an alternative direction, which is completely automating. I was just thinking, like, is there any direction that you guys are willing to lean toward in terms of supporting the open source community? Because right now the direction is kind of unclear, and it seems like both can use a little bit of help from the Google side.
Okay. So one thing is, you need to, even though build and BZL are tightly related, you should think of them completely different things. Like, think of BZL as your Java code or C++ code, and think of build as your CSV file, your JSON file. Like, it should be pure data, right? So which means the tools which work on these, like for BZL, it's unlikely that any tooling, automated tooling is going to help. You'll need more like help from JetBrains. Those kind of refactoring, like what you do for Java, the same kind of tools you need for BZL. For build, the hope is if you don't do things like these, if you don't stop treating build files like a programming language, then automation can come and help a lot.
Yes, hi. I'd be interested in for parsing and editing the build files. What are those Google internal tools, or do you use like Bulldozer for rewriting the file?
Yeah, so we just use Bazel query to generate the query output and see the generated code. And then we look at the call stack, which output by Bazel query that tells me which BZL file defined the macro. I just go to that BZL file, look for, we have, think of it as pragmas. We have pragmas, which the macro authors can basically add metadata saying that, hey, my macro looks like this. And then we use Bulldozer to make the edits.
Questions?
That's a problem because we are only using Bazel query, which means we only know the loading phase information. So which means we essentially flatten selects. So we are treating as if all the dependencies are needed. And when we generate the dependencies, we will add all of them together. And a human has to look at it and figure out what the select is. Because like, I don't know whether you want to select based on the CPU or the platform. There are multiple ways of doing the same thing.
Thanks, everyone. We're at time. We have a 5-minute break. Lightning talks at 10 before the hour. So be back then and take a short break. Thanks, Marley.
Welcome back, everyone. We have a block of lightning talks, starting out with Julian talking about Bazel observability and remote services in a multi-build tool organization.
Sorry. I don't know what I do.
Sorry, yeah.
Okay, can you guys hear me? Hello. So my name is, can I just click on slideshow maybe, or to make it a bit?
Yeah, you're in
I think that's it.
Then you don't see the speaker notes.
Oh, sorry.
Let me fix that for you. Then start talking.
Yeah. All right. So sorry for the hiccup. My name is Julian Dragos. Perhaps surprisingly, as you see on the slide, I work at Gradle. So by the end of this talk, I hope it's going to be a bit less surprising because I'm here to talk about the Velocity, which is our enterprise product and platform for build observability and remote services. And the interesting characteristic of this product is that it supports several build tools, not just Bazel and of course not just Gradle. One small detail is that until about a month ago, the product was called Gradle Enterprise. So you might still spot the old name in some of my screenshots, but it's really the same thing as the Velocity. So we support 4 build tools, Bazel, Gradle, Maven, and SBT. SBT, if you haven't done Scala, is the build tool that is, let's say, that's the Scala build tool. And this product started more than 7 years ago, and it evolved into a platform for observability and build acceleration, growing out of the pain and difficulty of Gradle users of understanding and optimizing their builds. It's already deployed at many customers, small and large, from teams of 20, 30 people to 1,000 people like Airbnb or Netflix. And it works well with monorepos, which I think are very common in the Bazel world, but also companies that use hundreds of repos, and it pulls all the data from all the repositories and all the build tools into one single central, let's say, data analytics platform. So you can see your build trends and dashboards across all the build tools, not just one. Of course, you can also filter them if you want. So what does it do? Let's look first at observability, and we have 2 screenshots. On the left, it's a build scan, which is task-level analytics of a single build execution. So this is the most detailed, fine granular view you can have. Data is organized in several sections to try to make it easier to discover what happened. It's really like an X-ray of your build. You can have sections about dependencies, perhaps tests, the console output, a timeline view, of course, and so on. Then, if you take a high-level view, we have dashboards, which are a little bit like build scans integrated over time. So you have data collected over thousands or tens of thousands of builds, and you can uncover trends, or you can do analytics such as see how the build times are going, how flaky are the tests, are they flaky 10% of the times, what are the flakiest tests I have across all my repositories, and so on. So now that we had a high-level look at observability, when I said it's a platform for observability and acceleration, we have a couple of things that make your build faster. The first one is the remote cache service, which it's table stakes for Bazel, so I won't say too much about it, except that our implementation can serve the other build tools as well. So there's just one cache service that you can deploy, and it would serve cached entries for Gradle, Maven, and Bazel. Next, we have a thing called test distribution, which you can think about as a simplified or a special case version of remote execution, where we just distribute or scale out test execution, not the build part. And because in our data, up to 80% of the execution time in a build is due to tests, this is a sweet spot and somewhat easier to implement than full remote execution. If we move one step further, another feature that we're offering is called predictive test selection. And the idea here is to use all the data that I showed across many, many runs to build a predictive model based on what changes caused what tests to fail, and then select a subset of all your tests that would normally be invalidated by your build tool and run only those, to speed up and shorten the feedback loop on, let's say, pull requests. Of course, it's probably not going to be 100% accurate, so we recommend that you run the full test suite hourly or daily, nightly, but it does speed up a lot the feedback cycle on a pull request. So this is another acceleration technique we're using. And then Bazel remote execution, we don't have it yet. I know it's a hot topic and they're working on it, but they're not there yet. So now let's look at the velocity for Bazel specifically. I think there are no surprises there. It uses the standard build event protocol. It's just a couple of options you would need to set up in your Bazel RC to be able to push the events to our server, and then you will be able to observe your build scans. This is one build scan. I think in this case, I was building the IntelliJ Bazel plugin. And then the first page is a summary. So I can't use the laser pointer, but at the top you see some user-defined tags, and then sort of highlights of your build. I think maybe interestingly, we see that we ran 788 tests, but 127 test classes failed. How long they took each one of those. We can see the longest running executions, actions, and then we can link from all of these. And almost everything you see on this page or on any other section it's a shareable link, so you can send it to your coworkers and say, look at this particular dependency, why is it in there, and so on. So if I were to click on one of the sections, for example, the timeline, I would see what you'd expect to see, a lot of build actions in different ways. And if I click on those, I'd get more details about it, but I don't have time. I mean, yeah, it's only 10 minutes. But if I went to the tests tab, I think this is actually the more interesting part. Besides the output and the stack trace, we notice one link there which says view test history. And if we click that, we would go to the test dashboard. And here I can cross-reference my test run with previous runs of the same test. So in this case, I see it failing for the past 2 days. Perhaps it's a new test that was just added and it's failing constantly. But then I can dig deeper, or I can actually use custom values and tags to filter my search. So if you see here, I'm restricting my search to a single feature branch. And then I see that it's only failing there. And if I look here, I could see probably all of those are local builds on macOS. I could have probably noticed that from the stack trace as well, but it seems to be a problem with macOS. The way these custom values and tags are added are as build metadata. So in this case, I added them as a workspace status command to be sort of a bit easier to run on every time I build. We use a naming convention to extract those. So if it starts with scan tag, it's a tag. If it's scan value, then it's a key value pair. In this case, it's a branch. And it just attaches those to the build and lets me further filter builds and test executions. All right, so what about the build cache? Our build cache is based on gRPC, and it's self-hosted. Actually, most of the things I showed are self-hosted. We offer sometimes managed installations, but usually clients or customers prefer to run themselves and operate the velocity. It's Kubernetes friendly, and maybe one interesting detail is that it's multi-tenant. So we offer project-level access control. If you have several teams or organizations that should not share cache artifacts, neither read nor write to those, this can be configured per build, and users can use access keys to read and write from the cache. And the same for the UI and so on. That's all I have. So if you want to find out more, you can find more on gradle.com/thevelocity. And we're also hiring. Come talk to me about either of the two. And I think we might have time for a question or two, if there are any. Well, thank you.
Our next talk is by Frederick, and it's about remote execution with Buildbarn.
Yeah, let's see. Yeah, I'm Frederick Medley, working for a company called Marathon. We are consulting, helping companies set up a build barn and convert to use Bazel. So build barn in brief, it's a remote caching, remote execution system that's optimized for very large clusters. Was created 2018 by Ed Schouten, and it's free open source, has been adopted by many multinational corporations. So I will try to show you how it looks like if you with the configuration if you set it up. So let's start easy with, we have one storage place. We put all the cache entries in that storage, right to local disk, and the Bazel client connects to that. Pretty simple, but the storage gets full, so we need to shard. Then we add the front end to put certain cache or certain blobs in the different disk storages there. That is based on the hash of the blob, so the front end knows exactly which shard to go to. After this, you can see also here to the left that all the configuration is written in JSON.NET, and all the documentation about these configurations are stored in the proto files in the repositories, and there are also default values. These are important to read because 0 is not a good value to use, which happens if you don't mention anything in your configuration. We also add redundancy. Mirroring is a good one, and you see the configuration grows a bit. Now, load balancing. If you have 3 storage nodes, maybe your front end can't cope with the load. So let's just add let's scale the stateless front end very easy in Kubernetes if you use that. Now, we have multiple offices, so it's good to have an office cache to reduce latency. So let's have the central cluster somewhere in the cloud, and then let's add an office cluster with the front end and the local storage there. And then you get a read caching with a fast office storage and a slow central cluster connection. That's not really good if the local storage goes down. So therefore we have a read caching, and then we have a read canarying to say that if the storage in your local office is broken, then just go to the central storage instead. It will add a bit of latency, but that's all right while the local storage is down. You can, of course, configure with mirroring in the office storage as well if you want, but depends on your needs. On top of this, when you look for action results, so checking for cache hit in Bazel, the get action results message, when you respond to that and say, I have a cache hit, then Bazel expects that all the blobs are actually located and you can read them from the storage. But we don't need to transfer all of the blobs when we do build without the bytes. So therefore, we add an existence caching part on the local disk so that we don't have to ask the central cluster if all these blobs exist all the time. And that will speed up all the cache hit checks a lot. If you want even more caching, you can add bbclient. There was a talk yesterday about remote output service, and there you can add bbclient on your own workstation. So when you build something from different workspaces on your own machine, then you can use that local cache instead. Then we have remote execution, of course. So let's add a scheduler and worker and runner process. The runner process is less privileged. It might not even have network access, which is good for some actions. The worker is the one that is responsible for populating the disk with all the input files. And then there's a single scheduler, and it is able to cope with very big clusters, even if it's a single process. If you get a failure, you probably want to know why. And in the Bazel CLI, you get a link, so you can click on that link, but then you need the browser, of course. And so add that as well to your deployment. You might also want to log what has been executed and log that to your database. So connect the action logger, or use a completed action logging API to collect that data, put it in a database so you can search for example, very slow builds or reoccurring builds and what is the most costly computations that you do. And in the office, you might also have your own hardware or something else, so you need to add workers there as well. Well, that's also possible to add and configure. And those can then talk to the office cluster frontend so to get the data delivery to those local workers a bit quicker. For the error handling, BuildBarn is just pushing all the errors back to the Bazel client. And there's a reason behind this. Say if a worker fails down at the bottom and a long-running test restarts, then you don't want to know that my test has been running for 20 minutes. Well, I expected it to finish after 12, and why is it now running for 20 minutes? Instead, the error is propagated back to Bazel saying, something failed. Well, you can decide if you want to retry or not. And well, as any of these links in the whole graph here can fail. It can be the first connection to the front end, so it doesn't really, if we do stuff again in the cluster, it doesn't help if the first link fails. So therefore, we ship all the errors back to the Bazel client so that you get informed of what is happening in the cluster, and Bazel can take the decision, should I retry or not? Then there are some extra interesting features, like I call it sticky scheduling. So if a worker has done some invocation, the output files are available on that worker. Then it's pretty smart if you can run the next action on that same worker, if there's a space available. So BuildBarn is trying to schedule all the actions in your invocation on the same worker. Well, if there's space, otherwise it uses more worker nodes. And thereby you get this locality of the storage, and it goes quicker. There's also a feature, sometimes some actions need extra memory or extra CPU. Well, if I want 8 gigabytes of RAM on 8 gigabytes of memory on my action, I will never reduce that again. I will never notice that I improved my action and I now only need 2 gigabytes of RAM. So you will always just increase the need of resources if you put that in your build Bazel file. But BuildBarn instead automatically can find out in the cluster saying, well, these actions seem to fail on a small node, so let's run them on a bigger node. And thereby it automatically, it recalls what size of node it needs and then puts out the action on that size the next time it runs. Then we have file system handling. So on the worker, if you use the Fuse or virtual file system, either Fuse on Linux or NFS on macOS, then BuildBarn will serve the files when you need them on demand. That means that your action starts running immediately, but you load the files when you actually read them. There's even a function where it logs what files you have accessed for a certain action. And then the next time you run a similar action, it will start to prefetch all those files. And there's kind of a race between, will your action need them before they have been collected, or will you have to wait when they are getting populated for you? Then we have monitoring, Prometheus, Grafana, boards, OpenTelemetry, Jaeger, and then the completed action log API, as I mentioned before, that you can hook into. Some frequent questions we get in the Slack community is, why is my storage slow? The usual answer is, you are layering your storage some way. So basically, if you have your remote cache on a network disk, that will be slow. Put it on your own, where you run the cache. Put it on a local disk there, then it gets faster. And use a raw block device and avoid layering VM on top of Docker or the other way around. Avoid as many layers as possible, and then it will get fast. Don't forget completeness checking on the action cache and existence caching on the content addressable storage. And for documentation, as I said in the beginning, look in the protofiles. There are default values. They are really good. So in summary, Buildbon is a free open source project available on GitHub. There's a Slack channel. Please use that. Professional services are available, not just by us. So look on in GitHub and see who are available to support you in setting it up. Well, it's a very flexible microservice architecture, and it's built to scale. There are clusters I know about using 100,000 vCPUs, and well, use the components that you like. Connect it to other things like Bazel Remote or some other caching system if that is what you use today. Patches are welcome. Thank you.
The final talk before lunch is Bazel Build Analytics with ThoughtSpot, and we have Shishir and Sahitya.
So, hi, I'm Shishir. This is Sahitya. We work at ThoughtSpot, and we'll talk about using ThoughtSpot for Bazel Build Analytics. So, having talked to some of you in the last couple of days, I've realized that getting actionable insights from our builds is a problem that a lot of us are trying to solve. And I don't have to sell you on the importance of build analytics, but I've prepared a few lines or written a few lines that I'll read anyway. So, in a world where we have where data-driven decision-making is paramount, Bazel build and test processes should certainly benefit from the transformative potential of data analytics. And this will allow us to dive deep into the data and derive insights that help you or help us identify bottlenecks and improve our build and test processes. So today, at our place, we had a large volume of complex build and test data, often fragmented across logs. And we did not want to use ready-made or predefined dashboards that are generic and non-customizable for our use case. So we decided to use our own tool, ThoughtSpot, for dogfooding our build and test data. And we'll share the results, and we'll show you how we did that. So before we move on to the demo, I'll take a look at the key metrics that we're trying to explore. And so primarily, we're looking at cache hit rate, which is the percentage of work avoided and rather pulled from remote cache from previously executed actions. So we reuse those artifacts. So we also look at critical path duration, which is the longest. The critical path is the longest sequence of actions that run in a sequence where the next action depends on the output and artifacts of the previous one. And it's and the duration, critical path duration, is the lower limit on your build duration. And we'll also talk about critical path ratio, which is nothing but critical path divided by the total critical path duration divided by the total duration, which is indicative of the degree of parallelism in your build. We'll also look at total build duration, test duration, cache hit rates for cache hits for tests, success, failure, and flaky percentage for tests. So here's Sahitya with demo.
Yeah, thanks, Shishir. Let me quickly share my screen. Entire screen. Yeah, so here we have used an open source repo called Bazel CPP for generating metrics for builds and tests. Sorry.
Yeah, got it.
Yeah, so here let's dive right into the metrics for getting the insights for cache hit rate trends. And here are the KPIs and line charts that we have derived for getting the monthly cache hit rate trend. If we look at this line chart, we can clearly observe that there's been a significant reduction in the cache hit rate since July. What does this mean? This means that there has been an increase in the build duration due to the fewer cache hits. And then if we go to average total actions, we see an upward trend since August. And as we can see here that it has increased by 20% since September. Now let's just run a change analysis to find out the attributes that are contributing to this change. Let's just select a test name. If we can see here that this particular test has, if this has not changed, then the increase would have been only 13% instead of 20.2. So this some change in this test has led to a increase in 7%. Similarly, we can just select any other attribute to figure out the factors that are contributing to these changes. Now, let's look at the metrics for critical path duration. In Bazel, aiming for a critical path duration rate close to 1 is a performance optimization strategy to efficiently utilize resources, reduce contention, and enable faster code iterations. If we look at this line chart here, we can observe that critical path duration rate has been the lowest in the month of May, and it has been increasing since then. To achieve this, we have added more resources and allocated pods for efficient builds. Then we have the metrics for getting the total number of builds and the pass-fail count. This bar diagram here shows that in case of automation, there has been a lot of commits that have gone in these months. And from this, we can clearly say that we may need additional resources to manage our workloads efficiently. This helps in identifying or making the smart decisions, resource allocation decisions to manage our costs efficiently. And then we have derived the final one, that is the build duration per each invoked target. This bar chart here shows the targets that are contributing to the slowest builds. So if you want to reduce the build time, then you know like which target should be looked at. And here is the monthly build time duration per each invoked target. You can just filter it out by selecting the invoked target that you want, and you can see the trend over here. Similarly, you can just filter it on the entire data to just get the answers for a specific targets. So yeah, so this data has been updated to get the data only for these targets. Yeah, so similar to, sorry, yeah. Similar to build data, we have derived metrics for getting the average test duration and the trends for each test. This chart here shows the tests that are contributing. It basically shows the slowest tests. And here is the monthly test duration trend. And we can just select a specific test and see the trend over time. And then we have the average cache hit rate for each test case. This bar chart here shows the test cases that are having a very fewer cache hits, leading to contributing to the overall build and test times. And then we have derived a metric to get the number of test cases for each component. This helps assess if there are sufficient tests in each component. And the finally, we have derived metrics to get the success, flaky, and failed percentage for each test. In the repo that we selected, we didn't find any flaky failed tests, but you might wonder like, why is the success rate not 100%? And this is because we have found a test case which was failing with timeout every time. And again, like I mentioned before, we can just select the test names that we want to view the data for specific tests, or we can just select any component, and your data will be updated to just view the trends for those tests. And yeah, that is how like ThoughtSpot empowers us with actionable insights for our data analytics in Bazel builds and tests. With this, I'll hand over the stage to Shishir.
Yeah, we'll try to wrap it up quickly. Yeah, because next we have lunch. And I can see I have a minute.
Implementation is next one.
Yeah. Okay, I wanted to talk a bit about the implementation, but I'll skip that. But if you want to discuss that, you can talk to us. And if you want to try it out, we can help you set up your own ThoughtSpot free instance that you can use to analyze your build data. And apart from the demo that Saitya shared, you can also do, use, if you have leaky tests or failing tests that have been failing consistently, you can map it against the SHA to find the culprit SHA, or if you want to analyze when did this test turn flaky, you can do all that. All these answers, dashboards, KPI monitors are all customizable, and you can modify them to query your build data, and that's rather easy. So yeah, I'll skip implementation, and if there are questions, you can ask. Okay. I think we are done. Thank you.
All right, thanks everyone. You can have lunch here. You can have lunch in Moonshot. You can have lunch in 10X. See you in about an hour.
Okay.
Bringing Bazel to Windows then and now.
Hello, everyone. Welcome. It's very nice to see so many of you. Thanks for coming to our talk. I know it's right after lunch and very interesting BOF sessions are going on, so we'll try to make this even more interesting. Forgot my clicker. So hello, everyone. My name is Laszlo. I'm a founding engineer at EnchFlow. We build a remote execution and remote caching service for Bazel and other build systems. Before joining EnchFlow, I used to work at Google in this office. Between 2010 and 20, I was a part of the Bazel team, as you can see from most of my clothing. And initially, I worked on internal JavaScript rules and tooling. I was a JavaScript imposter like Alex. I didn't write any JavaScript, just the tooling. But after we open sourced Bazel in 2015, my focus has shifted to Windows, to bringing Bazel to the Windows users. For a few years, I was the tech lead on this project. And today I want to tell you about some of the most interesting challenges that we've come across while porting this Linux-only software to Windows. Since you're at this conference, I assume most of you have used Bazel. And since you're at this talk, I guess some of you may have even used Bazel on Windows. But if you had to guess the percentage of people in this room among us who have used Bazel on Windows, what would be your guess? Now, please don't say anything, just think about a percentage. Okay, could you please put up your hand if you think at least 10% of us in this room or more have used Bazel on Windows? Okay, that's a lot, about a third of you. 25% or more? Okay, still see some hands. 50% or more? Okay, excellent. Now, please put up your hand if you have used Bazel on Windows. Okay, so most of you have, and most of you thought that you haven't. So I think that's very entertaining. But the other reason I asked you this, other than being cheeky, is the Bazel team faced a similar question back in 2015. We just open sourced Bazel. It was running on Linux. We all used Linux. Everyone at Google was using Linux for the most part. We knew Windows was important, but didn't really know how important. So we took a look around outside of Google and discovered that the most popular OS was actually Windows 7. So we had to support Windows if we were serious. Besides Bazel happening in 2015, another important thing happened, and that was TensorFlow. TensorFlow was massively popular. It built with Bazel and CMake. And we thought that a lot of developers will want to build this on their computers, from professionals to hobbyists to students. And a lot of them would be using Windows, preferably building with Bazel. A lot of them would be using Windows, and many of them would not be on their own computers. They would not have administrator rights. So we set two restrictions for ourselves. We wanted to support Windows 7, and we wanted to not require administrator rights, either to install Bazel or to run it. So yeah, no big deal. Can't be that hard. We don't need root access on Linux. Why would we need it on Windows? And as for other how hard can it be type of questions, we thought, yeah, we'll need to deal with Bash. Bazel depends on that. I'll get to that in a second. But Bazel itself is mostly Java, compile once, run everywhere, right? There's a bit of C++, but we'll figure. Let's start with Bash and C++. Bazel depends on Bash with about 1 million tentacles. Every gen rule is an arbitrary shell command. So we need Bash for that. PyBinary, Java binary, PyTest, Java test, a bunch of other binary and test rules have something called stub scripts. And these are things that find your interpreter or JVM, compile your class path, and set environment variables before it can run your actual program. Those are all written in shell scripts. Test wrappers. Every test rule has a shell script that sets up the environment for it before the test can be run. So those are all written in shell. We needed something for Bazel on Windows. And as for the POSIX API, the C++ part of Bazel is heavily dependent on some of the POSIX functions that Windows doesn't implement. So we needed, in order to even compile Bazel, we needed those functions. And the solution was something called MSys. MSys is a bash terminal, a bash build for Bazel. It can run bash scripts natively, so it solves that problem. It also gives us many of the GNU bin utils like sed and grep and awk that generals take for granted, and has a package manager so you can install more. But most importantly, it has a library that you can link your programs against, and it implements just enough of the POSIX API on top of the Windows API that we could build Bazel against it. So that was great. Now, back to the previous restriction. Not being able to use administrator rights meant one thing, but that was really painful, and that is we could not create symlinks. And not because the file system doesn't support them, because MTFS does. The problem is, under Windows 7, you can only create, a program can only create symbolic links if it's running as administrator. And we didn't want to do that. And if you don't know, a symlink is just a special file on disk which points to another file or directory or another path. Whatever is under that path points to that. And Bazel uses this heavily because if you have an action with lots of input files that you need to arrange in a certain way, you can either copy them to the right places or you can create pointers to them, which is a lot faster. And that's what Bazel does. So we wanted something like that on Windows, but couldn't use symlinks. So what else is there? Turns out there's a thing called junctions. These are like directory symlinks. They only exist on Windows, but they serve our purpose as well. You don't need administrator rights to create them, and they are super fast. But what about files? We can consider hard links. Hard links are also special files. I'm going to hand wave about this, so I'm sorry if you know how file systems work. This is going to be imprecise. But hard links are special files that also just point to other files. The two key differences with symlinks is they point to a concrete file object on disk, which is going to be important in a second. And the other thing is they can only point to files, not directories. But they are also fast to create. They don't need administrator rights, so they can be used for our purposes. But not so fast, because they are named this way for a reason. If you modify a hard link, if you modify a file that a hard link points to, you see the modifications through the link. But if you delete the file and recreate it, then the link still points to the old content. And that's important because if you stage your input tree with hard links and Bazel rebuilds one of your input files, then it also needs to recreate the link, which is a problem if you have thousands of actions and thousands of input files, because it slows you down. So they can become stale in this regard. And the other problem is their target needs to be writable in order to create a hard link. I believe this is true on Linux as well, but on Linux we are using symlinks. And what this means is if your actions have input files, they are staged with hard links that point into your source tree, and those are writable, and your action modifies them. Well, that's bad news for your downstream actions. So what did we do? We used hard links anyway. Moving on to more differences between Linux and Windows that we had to solve. File system is notably, I think, well known that it's very different. The path separators are different. There's no single root to your file system. There are multiple roots. These are the drives that you're familiar with, C:, D:. The paths are case insensitive. So the two paths you see on the screen, left-hand side, right-hand side, they are equal on Windows. On Linux, they would be different. And imagine these have build files. Are these packages then equal? And the answer is yes. On Windows they are. Actually on macOS they are as well. And this is still a bug today. Path length limitations are different. On Linux it's about 4,000 characters. On Windows traditionally only 260. Microsoft back in, I believe, Windows 98 or so, started adding new API functions to support longer paths up to about 32,000 characters. But those are new API functions. So it's a compile time decision which one you use. And if Bazel is trying to run actions that were built with the shorter limit, you're screwed. And finally, paths can take many different forms. All the paths you see here are basically the same path. Now there's nuance here. I'm not going to get into what are the numbers after the tilde and all of that. But if you have worked with Windows, you will recognize some of these. And the final difference I want to discuss is in process management. On Linux, if you want to start a sub-process, you're calling the execve function and you're passing an argument vector to your child process. And if your arguments contain spaces or special characters, you know the child process is going to receive them as you have intended. But on Windows, when you create a sub-process, you're passing the entire command line. And it's up to the child process to tokenize that into an argument vector. And if Bazel uses one quoting mechanism and the child process uses another one, bad luck. And finally, there is no shebang mechanism on Windows. So if you can imagine on Linux, you have a starlark rule whose executable is a Python script. The Python script has the X bit and has a shebang line saying, where's my interpreter? But on Windows, you cannot have this. I believe the Node.js rules are where I have seen this, that they needed to be ported to Windows so that they run an exe file rather than a script. Okay, so these were the high-level problems that we have come across. In 2015, with open source Bazel, it had Linux support. And just a year later, March 2016, we were able to announce experimental Windows support, which means we've solved most of these problems to some extent, and we were able to make it experimental. Half a year later, we had support for the major languages. And the year later after that, in 2017, we were able to cut some of the ties to MSys. This I forgot to mention earlier, but from the start, from the get-go, we wanted to reduce Bazel's bash dependency as much as we could, because bash isn't really native on Windows. But for the reasons I explained earlier, we could not. In 2017, we could finally not link Bazel itself to MSys. So you still needed MSys if you had general or other bash requiring things, but not for Bazel itself. We now had a native wrapper for the C++ toolchain. Previously, we had wrapper scripts that translated the GCC arguments to MSVC. This meant C++ compilation was faster. We created half as many processes. We were able to build Android apps, and we had native stub script, not stub scripts, but stubs for the binary rules. In 2018, 3 important things happened. Remote execution was really taking off for TensorFlow. We had the Google Summer of Code. Google Summer of Code is a summer program by Google for students and open source projects, where students can contribute to open source projects, and Google pays them a stipend for doing so. Bazel was part of this. We had an excellent contributor named Lu Rongji, who implemented sandboxing for Windows. I think this is a little known fact, but Bazel still supports sandboxing on Windows today. You can still find his commits on GitHub. And even though last time I tried, the code was slightly broken, but it could be revived. Everything is still on GitHub. And finally, we finally implemented run files tree support using symlinks. Starting with Windows 10, you could opt in to creating symlinks without administrator rights. And for those people who did, we wanted to have support for that. And if you have watched Fabian's talk last year, you will know that on Windows, we were not creating symlinks for run files tree. We created manifest files that just describe the tree. And that gets me to Bazel 1.0 in 2019, when we have got even more ties to bash. Even the test wrapper was now native. We had native support for batch scripts and PowerShell scripts in general. We had all the rainbows and unicorns you wanted. And this ends my section of the talk. So this is the history. So now I want to hand it over to Jay, who will tell you about the future. Thank you.
Hello, everyone. Welcome to part 2 of our talk. I'll be telling the story of how we made remote execution work at EngFlow on Windows workers. So this is really new. We're just starting to get off the ground with this. But I hope it's going to be more widely used soon. Remote execution adds a ton of value for Bazel users. And there are a lot of Windows developers out there, some of whom are using Bazel already, many of whom actually we just learned, many not yet. So I also hope that this unlocks a lot of Bazel adoption too in the future. Let's see. Here we go. So a little about me before we go on. Like Laszlo, I'm a software engineer at EngFlow. I joined a little over a year ago. Previously, I worked at Google on the Go team, where I led development of Rules Go and Gazelle. I also worked on the Go tool, that's Go's build system. Did a bunch of things there. A fair amount of Windows low-level cross-platform development, so that led me to doing Windows stuff at EngFlow. I do consider myself a Windows imposter. I think we're all imposters in something, and this is an area that I'm not super familiar with. I stopped using Windows personally in the early 2000s. C++, it was easier to get started on Linux. So a lot of things have changed while I wasn't paying attention, and I don't know, maybe being a beginner, like beginner's mindset, this talk will be more approachable. So I had a slide about how remote execution works. I think you've seen similar slides in like 3 or 4 other talks. So we can kind of skip on here. This is EngFlow's flavor of it. The thing that I wanted to point out here is that we can have different pools of workers and different configurations. They can run different operating systems. So the new thing that we're doing here is Windows workers, just that box at the bottom. So fortunately, we didn't have to start from scratch for that. Our worker service, that is the big bit of code that receives execute requests and runs commands on Windows. So the worker service is written in Java. That largely lives up to its promise of write once, run anywhere. We have a fair amount of Java and C++ code that's inherited from Bazel itself for running actions on the worker, running commands, file system operations. And so thanks to the hard work of the Bazel team and the open source community for that. We do have a long list of problems to solve with our service though, and of course there are going to be bugs to fix. So let's start with V0. It's our first iteration of Windows support. In this version, the workers can run commands just directly on the host machine. And at this stage, we're mostly just figuring out how to operate a scalable Windows service, with observability. Like running a Windows cloud service is kind of different than what most of us do, right? So I'm briefly going to cover some of the tools that we use. First up is NSSM. We use this to run our services. It's a little bit analogous to systemd, although not quite. Windows does have its own built-in service management, but it's not as fully featured as systemd. So if you want to integrate with Windows' service management, you need to speak this low-level Windows messaging protocol that tells your program like, hey, it's time to pause, hey, it's time to restart. And if you're writing code in Java, then it's very difficult to integrate with that. You generally need a wrapper process, and NSSM can act as that wrapper. So it's great for that. It also has a nice configuration tool, so you don't have to edit the Windows registry directly. It handles log redirection, rotation, automatic restarts, graceful shutdown, that kind of thing. So we like it for that. We use FluentBit for our log processing, log filtering, log upload. We use that multi-platform. It was a bit of a challenge to get it to compile for Windows, but once we got it running, it's been great. We use Windows Exporter for our Prometheus metrics, and we use HashiCorp Packer to build our machine images. So that's our toolkit for Windows. So V0 worked for simple things. It does have some pretty serious disadvantages though. So we didn't end up shipping this to customers quite yet. First up, there's no action isolation. So because actions are running directly in the host environment, an errant action can scribble over the cache accidentally. And there's also no way to limit CPU or RAM usage. So a very busy action can cause your other tests to time out. Things like that can interfere with concurrent actions on the same worker. The bigger problem, though, is a lack of Visual Studio build tools. So this is the Microsoft C++ toolchain. And basically, every customer wants to use this. So there's not much point in shipping something that can't have it. The reason we couldn't ship it, this is a proprietary toolchain. So the Microsoft license is that you can install this, but we don't have permission to bake it into a machine image and redistribute it. Theoretically, at least, you can install the toolchain in your Bazel workspace and configure it as a hermetic toolchain where all of the toolchain files are inputs to every action. That has a lot of overhead. There are a lot of files. So we didn't really think that was practical. So on Linux, we solve these problems with containers. Nearly all of our actions run in containers. And it's a little bit like a virtual machine. It's an environment separate from the host. It has its own file system, its own network. You can set limits for CPU and RAM usage. So that's just perfect for remote execution. And most of our customers prepare container images that have all their tools baked in. Some of them are quite elaborate, so they don't need to be passed in as Bazel input. So that solves the Visual Studio problem too. So it turns out while I wasn't paying attention, Windows got containers. You can download Docker from docker.com. It actually works on Windows. So that's great. They've been there since Windows Server 2016. So new technology, we want to try it out, make sure it works. So I prepared a container image that contains all our CI stuff. And we put this up on our example repo as a template that our customers can use. So we started with one of the 4 base images that Microsoft provides. Nano Server is a very stripped down version of Windows. This is good for apps that are built specifically for that environment. And it's missing a lot of things that you would expect. For example, if you install something, you have a graphical installer, you put it in text-only mode to script the installation. It may not start because it is linked against a graphical DLL that is not in Nano Server. And so it will just give you a cryptic error code. So we switched to Windows Server Core, and that has everything we need. It's a bit bigger, it's 4 gigabytes, but that's been working great. So we picked an image, we installed our dependencies. So I'm going to get into a bit of a war story here. We tried to install MSys2, and I'm seeing like Docker build is just hanging, 100% CPU indefinitely. So what's going on? I tried my very scientific debugging mode, which is adding lots of print statements everywhere. And I find that the install script is succeeding, but Docker is not going on to the next step. So what's up with that? So it turns out every install step in Docker, it's firing up a new container, and those containers can write files into an overlay directory on the host. And those files eventually become part of your container image. But not all of the files. Docker does a bit of cleanup in between steps because you don't want to commit all of the garbage that happens to be in your temp directory. And someone, fortunately before me, investigated this and figured out that MSys2 was writing files with invalid Unicode characters in the name into like temp files. And this was tripping a bug inside the Go standard library's remove all function. And so it was hanging. So this like fun interaction between like MSys2 and Docker and Windows and Go, our favorite kind of bug to investigate. So fortunately, there's a workaround. This is fixed in Go 1.21, but we wait for a new build of Docker. In the meantime, we can remove all the files in the temporary directory in the install script, so Docker doesn't get tripped up by it. So that's enjoyable. With our container build, we're well on our way. The worker daemon already knows how to run Docker commands. We needed to set up a few other things in the virtual machine, so we installed Dockerd. We set up an NSSM service for it. We also installed credential helpers so that the machine automatically can log into Docker registries, like private registries that the worker is authorized to use. Beyond this, a lot of the work has just been squashing bugs, and I could get into the details here, but we'd need another day of conference, and I don't think you'd all stay around for that. Suffice to say, like all of the differences Laszlo talked about earlier are super relevant, and I was amazed to find this XKCD. There really is one for every situation, and this is explaining how it is incredibly difficult to delete files on Windows. Which a build worker needs to do kind of a lot. So this works now on the server side. There's a fair amount of configuration that needs to be done on the client if you're using a remote execution. This is not really Windows specific, so I'm going to kind of cruise through this. You need a platform target that has a list of constraints saying you're running on Windows x86. You can put your container image URL in here. Those are like in execution properties, there are a list of key value pairs passed to the server. Second, you need a C++ toolchain configuration, and this is the hard part. Bazel generates this for you automatically for a local build. However, if you're doing a remote build, you need to provide your own. One way to do that is to fire up a container locally, the same container image, install Bazel, run a trivial C++ build, and extract that local configuration back into your host environment. And hey, it works remotely too. So we have an example of that, and I wrote some documentation on our website. You can check out our example repo for that. Lastly, you just need to add some flags in your Bazel RC file telling Bazel that it needs to build remotely on the new platform. And yeah, that's about it. I think we have a few minutes left for questions. I do have one more story, but come find me afterward, and I'll tell it to you about C++ header validation. Bazel, do you want to come back up for questions?
If we have any questions.
Yeah.
Or we have time for questions.
Yeah. Microphone is coming around.
A little bit more why you cannot trigger remote executor on Windows from a Windows host?
Theoretically, there's no reason it shouldn't be possible. It's just bugs. What I've seen happen for C++ specifically is that Bazel thinks that a path beginning with like C:/ is a relative path. And so it will put like a Linux absolute path in front of that. Like that can probably be fixed. Bazel, you might know more. Okay.
Oh, okay.
Use them both.
Yeah. I'm wondering if you could say a bit about the differences between the level of isolation provided by Docker containers on Windows versus what we would expect from Linux.
The main thing that we want from the isolation there is the file system isolation. And so that's very similar. You can bind mount directories across. I've run into a few bugs with that, which require some workarounds, but it's still doable. In terms of like CPU and memory usage, like Docker on Windows gives you fewer controls, but you can still limit to like a specific number of cores and like specific memory. I haven't yet gotten into the network restrictions yet, so I can't say there. I think it's pretty similar though.
You mentioned that there is a sandbox for Windows available at some point. What is stopping that from making it to mainline? And the second question, is there any imposter here that already is confident enough to share his, let's say, run files implementation in batch?
I'm going to comment on the first one. What's stopping us from using it? I think multiple things. You need to understand the entire ecosystem. You need to understand what a sandbox does. You need to understand Bazel itself. You need to understand how it works on Windows. I think it is absolutely doable. If I have some free weekends, I might even take a crack at it. I don't see any fundamental blockers against it.
Partially answer to this one, take a look in the aspect Bazel lib. We have a Windows helpers, which includes both a run file utility for batch with a T, and also a handy wrapper so that you can create a batch file out of a bash file, and so then you can invoke it as an executable on Windows without having to build an exe, which we've used for some of our rule sets. So my question is, rule set authors and especially contributors often don't have a Windows computer and use that as their justification for why they can't make anything work on Windows, which is one of the things holding back Bazel from working better across Windows, as far as I can tell. I'm curious whether the things that you've done with the Dockerized Windows environment would potentially provide a solution for this, where developers could have a Windows environment on a non-Windows computer?
I think you still need to have a Windows virtual machine somewhere. There are a number of ways you can do that. Like you can run a virtual machine locally. You can run one in the cloud very easily. Like that's actually been great for development of this. Just like firing up an AWS instance or something. If you're doing like remote execution onto Windows, I think like from a rule set author perspective, like you still kind of need a Windows host for that, at least for now. Yeah. All right. Thank you all.
Please welcome the next speaker, Ma, on unlocking potential, Bazel potential with monorepo.
Okay, thank you for having me. And today I will talk about Bazel and monorepo. And who am I? I'm Quan-Yi Ma from Web3 Infrastructure Foundation, which foundation is established in Hong Kong in March of this year. The foundation is aims to helping the open source project to build a Web3 infrastructure, and I'm also a Rust developer, a software architect, and you can reach me through the ID. Today is BazelCon, so I want to dive into the Bazel, as most of you are already familiar with the Bazel. Let's just recap some key features. First is Bazel is have intelligent dependency management and ensure only the parts which need to build a process which can cut the build times and sequence times. And second is Bazel have incremental build and test, which means you don't need to rebuild and retest everything with each the code commit. Just 5 parts. 3 is parallel processing and is speed up the process. Is harmonious powers from the multiple core processors. Last is the remote caching and execution is ensures only if build is completed elsewhere is don't need to repeatedly. Is all the key feature, but while this is necessary, Bazel is engineered for the monumental build scalability, and if a small project such tools like GitHub Action or Jenkins are certified, when we talk about the large scale build, we usually refers to the extensive application and the microservice. So such vast system need to be built and test with each the code updates. So large vast code generally requires a large scale build. So if any team and organization utilize some technology like this, will be prepared to managing vast code base. So there is a two-way host our code base is a monorepo and polyrepo. So monorepo is like its name suggests, is a single repository containing all the codes or projects or multiple related projects. Imagine an entire company's code base in one place. So this approach is offer a simplest way code sharing and collaboration across the team, maintaining the collaboration and will be easily. So it's worth noting is the monorepo has a scalability issue. So on the other hand, we have polyrepos. Polyrepos is means each of the component or project has a separated repository, and this approach is managing a challenge when we have multiple projects and have the multiple dependency. When we complete it, we will be faced up to date to the projects, and across the repository will be the dependency will be complex. So let's see the big company how to handle his monorepo. Google has a repository it has a system named Pepper, and Pepper already as January 25 Pepper has 16 terabyte count and 1 million 35 million commits and 1 billion files. So Pepper is based on the Google infrastructure spanner across 10 data centers all over the world. And for now, Google Pepper is not open source. So let's see, Facebook. Facebook has a client is named Zeppelin. It's already open source, and he has a mono repo server is named Mononoke. It's familiar. It's interesting, and the Zeppelin and the Pepper always use the database as a backend. It's a different. Is Zeppelin use some file system is a hyper backend. So Microsoft has a client has an open source named Scalar. Scalar is helping the developer manage a monorepo in the client side. So you can use this feature, manage a large repo, but Scalar is based on the GVFS protocol, is a Git virtual file system protocol, but there's no open source server based on the GVS server. So you can use a client. Git is already the most version control system in the world. So when we use Git, we want to also use the monorepo. How we do is Git has two native filter. First is submodule. Submodule means looks like a one-way link. So we can't update the module, submodule in the mono repository is only can update in the separate. So Git provide another filter is means separate trees is a two-way link. So you can update in the mono repository and submodules. So whatever tools is already have a challenge of manage dependency. You can think is you have a nice structure, and repository A have a submodule B, and the submodule B has a submodule C. It will be lead to chaos. So how we do, and we inspired by the Google Pepper, so we decode the Git. We sort the Git into the database. So use the distributed database to support a monorepo structure. So we must to know what's the Git internal objects. Git is a addressable content file system, and also is a database. They have three objects. The first is a blob and a tree, and the blob is a content. It's just like a container. When you push when you commit a file into the Git, is into a blob. So when you the same file you modified and commit again will be two of blob. So Git is a snapshot version control system. Also, Git has another object is named tree. It has 4 tree types. As this is only shows the 2 types. Is one type 3 types pointed to the blob, and one time to the pointed to the another tree. So it's present a dictionary or all the repository. And so we design substructure with Rust. And another thing is single nature. Single nature is will be in the Git commit and the Git tag. Is show who and why and just the who and the email when make the change in your repository. Git commit is the core in the Git. They have 2 is must be point is the tree. So Git is the commit is has a tree ID and point to the tree object. So when you commit is a point the snapshot of the repository, and also Git has a parents tree ID. So means you have different paths from the fathers. In the usually we use the Git branch. So like the Git merge will be have the mutable parent. So this is a signature, and this message you can see why and how fixed in this commit. The last is Git has a annotated tag. Actually, Git has two tabs. One is an annotated tag, and the second is the lightweight tag. Lightweight tag has no the metadata. So, the annotated tag has a tab is point to the commit. So tag looks like a constant static variable in the language. It's usually we have the a branch like a dynamic is a label. So this is all the 4 objects in the Git. So we encode and decode so we can save it to the database. So like this, we save all the object to the 2 object is two database is named object and commit, and we will be analysis to the another table is node, so we can map all the repository. So we can use the distributed database host a very large repository. And when we do that, we design a very simply architect. We just had two levels, 2 layers. First, we rewrite the HTTP gateway and SSH gateway in Rust, and the second is into the database. When we do that, we notice the Git actually has 2 protocol. The old one is a dump protocol. Means you push and get the object one by one, and for now actually use the smart protocol. It means he pack all the objects into a file and push to the gateway. So we must decode and another file. So it looks like this. Okay, it's just my theory, but how it works. So let's see a demo. Yeah. So this create database is last night I'm testing for. I already inserted 22 million files in a database in a single repository. This is from the Rust created repository. I almost 20,000 repository. I imported this repository to a single Git. So let's see from the beginning how to use the system. So for now has 2 database. Is last database is I test. A single is another is a test. So let's drop it. Okay, it's a new database. So let's initial the database structure. Okay, and for now, I must create a new user for this. Drop create user. Okay, so I grant the privilege. So now I must initial the database. So there will be create a 3 folder in the database. So for now, run the HTTP service, and it's okay. So let's see git remote. So there's a local and already ready. So let's git push the local main to the mega. The project named the mega. So we can see we decoded all the objects into the database. So let's see. So already okay. So let's clone from the other way. So so let's close this one. This one. So it's already clone a new project, so we can go big. Yeah, so we copy the configure file. We run again. Yeah, it's okay. It's already start. So let's clone another repository. Okay. Let's see. The UI is the folder in the repository, so we can clone any folder in entire the repository. So let's try something like the gateway, the SRC. Yeah, so you can clone anything. So if you have a mono repo, you just clone any level folder into the local as the Git repository. So let's see the UI install. Let's see a very ugly UI. is still have many many bugs. So let's see is just a simple UI. You can see everything in the repository. And for now, let's see. There's only one committed history in the local repository. Let's see why. Okay. So we have limited So we have limited to the used mega is a monorepo. First, we have you only can use one branch is named main. Second is each you commit you only have the one commit in the pack. And three, we don't allow the developer use the tag. So we will be provide a REST API to get the tag. When you release the you must use the UI or API. We not allow the developer use the git command to do that. So the last is Mega and Bazel. So for now we have the simplest we trigger the Bazel. For now, if you push the code and we will clone into a temporary dictionary and call the Bazel, and with the remote executor, so parameter, so to build. Let's see the last demo. And same thing. It's okay. So let's see the master container. Start a build farmer. Yeah, it's okay. So let's see, make the change. So let's copy the cargo Bazel log file. And, oh, sorry. I must modify the. So, yeah. So we run the service again and so let's change some code. And allow Bazel come. Now let's see the build farmer worker temple dictionary. For now, is nothing in there. We commit. And for now, we'll be clone the project into a temporary in the temple, so will be called Bazel. Will be called the Bazel farmer. So it's a This is the output. Yeah. Yeah, it's a start to build the target. Yeah, just sorry. It's not working. It doesn't matter. Just call the build farm. So for now, we just completed the prototype phase, so we can encode and decode everything. So next phase we will be working on the UI and the user system. In the future, we will be want to the fuse system like the Microsoft scaler, and you can mount and connect to the remote repository. And we also have a joint project with Zhongnan University in China. We are working on the looking for a way to resolve the large language model version control. So if you're interested, you can try. So that's all. Thank you. Oh yeah. Any question? Yeah.
How is this different from partial clone?
Oh yeah. So if you did partial clone, means you must clone all. You must clone with all the Git structure. When you using it, will be get the from the repository. It's just I think it's how can I see it's a partial clone. If you must clone from the root repository. When we do that, we can clone any level folder in the repository.
Well, let's check out. For you can check out a specific directory. But partial clone just means that you can you please yeah, so partial clone part is to reduce the download, and the spell checkout part is to reduce the number of files that's visible to user. And I guess it looks like almost the same as.
It's not the same. If you partial clone, is you must have the entire Git database, the structure into local. When we use the mega clone any folder, we will be fake Git structure to you, so you can use any folder. It's a difference. So if you use the partial clone, you must clone from the top level, the root, the top of the level. And when you're using like some scalar or the sapling, when you're using it, will be have the file monitor system. You can they will be help you to clone from the repository, from the server. I think it's different. Yeah. Thank you.
Thank you for the talk. We have 15 minutes break, so please come back at 2:45 for another sections. Thank you. building self-driving cars with Bazel.
Hi, everyone. Nice to see so many of you. Welcome to our talk about building self-driving cars with Bazel, the second part, the scaling part. We're from BMW. We're working in the autonomous driving project, specifically in the build, automation, and continuous integration teams. My name's Alex. I'm a senior build and CI developer on this team.
So, hi, I'm Johannes. I'm lead SRE and product owner of the CI/CD system of multiple ECUs. And our talk will be slightly different than most of the talks which you already watched here at BazelCon, because we're mostly users of Bazel and also of the whole Bazel universe and the Bazel community. In this talk, we will be focusing on the build automation for our driver assistance and automated driving project at BMW Group. The reason for this is that this is one of our most complicated and advanced projects within BMW. What are we developing in this project? So it's from, in quotes, simple beep while you're parking your car, if there's an obstacle or something, up to automated driving in level 3, which means that the car is responsible for the actions it's doing and not the driver anymore. Some more complexity added to our project is the corporations. For the current software, we're having a cooperation with Stellantis, former FCA. It's another OEM. We're developing the software jointly, and it's for both of our cars. And since last year, we're having a cooperation with Qualcomm, and this will bring the whole software development to the next level, because we're not just developing software for one or two OEMs, which is BMW, but together with Qualcomm, we will be preparing our stack, our software stack up to level 3 to be available for other OEMs as well. So you might be seeing the software, what we're talking about today, in other OEMs' cars in the near future. Let me quickly recap what we were presenting 4 years ago. I see the two presenters here in the crowd, Axel and Patrick. Welcome back. So 4 years ago, or actually 4.5 years ago, we were facing quite a bad situation. We had roughly 200 individual repositories, a lot of developers only having access to 4 to 6 repositories, doing their component. Changing interfaces or anything was hell. Integrating code was really cumbersome. And finally, bringing your software, your changes to the car, yeah, it was really, really painful. Then we did two major changes. One change was that we took all the software from those 200 repositories and brought them together into one big virtual monorepository. We're using Git with Git submodule for this, and currently we're having roughly 40 submodules. The only reason why we're not having one specific repository is visibility rights, so legal rights, because we're cooperating with quite some partners and not everyone is allowed to see everything. That's the reason why we use Git submodules. The second and potentially most important change that we did is switch from CMake and Catkin environment to Bazel. And that's exactly what we presented here 4 years ago. So we were able to have incremental builds finishing after 10 to 15 minutes and not waiting till CMake and Catkin did all the iterations, all the loops for like 60 minutes if you just changed one line of code or maybe did just a change in a README or something like this. What happened in the meantime? So 4 years ago, we were presenting the results. We didn't have a car there yet, but now we have cars on the road. Let's call them Bazel cars. So the software for at least 2 of the ECUs in all of those cars is being built and tested with Bazel. Some of those cars even are having up to 4 ECUs with Bazel. Some of our flagship cars, especially the iX, the iNext, already presented in the last talk as a prototype. You saw it fully camouflaged. Now it's out. You can have a look. Also the i7 series with the really huge panoramic display in the back. And quite recently released the i5. If you go for the i5 M60, you have close to 600 electric horsepower, which is quite awesome in such a sedan car. This is not all the cars which are Bazel cars. So we have quite some others like Alpina or Rolls-Royce. It's just there are Bazel cars out there, quite some of them. So when you see them driving around, this is all thanks to this community that we were able to ship the software to those cars. But the success of our workspace also is a problem because since we were able to ship in time and also properly tested software, more and more ECUs, more and more developers, more code came up because people wanted to join our workspace. They wanted to join our infrastructure because it just worked. So the difference from then to now is that we are having more than 3 times the amount of code, more than 3 times the developers. And when we're talking about developer, that really means each of those persons has at least 1 commit in the history. That's how we extracted the data. We have a lot more developers who are doing requirements management and not touching the code, which is also super important. But really, each of those 6,500 developers has at least 1 commit. 8 ECUs in the meantime, plus 1 classic AutoSAR software development project, 4 times the number of builds, a lot more CI developers. And I think what you also see here down on the graph, the most impressive number is that our resource usage of the CI is 12 times as high. So at the time when we had to talk 4 years ago, we had roughly 3,000 vCPUs peak usage. Currently, it's 33,000 vCPUs peak usage. And this rapid growth, this rapid scaling brought a lot of challenges with it. And the most interesting ones, just some of them, will be presented to you by Alex now.
Thanks, Johannes. Grab the clicker. So let's talk details. Before we do that, let's talk about our CI setup to make sure everyone's on the same page. So we're using Zool, an open source CI system for our CI. With Zool, you have the concept of jobs, and you can all think of a job as a set of steps that run in quick succession, with one of those steps being Bazel test ... We also have the concept of pipelines, and pipelines are triggered on specific times across the lifecycle of the pull request. For example, the pre-merge pipeline, that pipeline's triggered when a pull request is initially opened. Post-merge on the right, that's triggered after a PR is merged. And the one in the middle, the merge queue pipeline, that's similar to pre-merge, but there's something special, which is when all of the changes that currently want to merge, they're all bundled together and tested with each other to make sure they're all compatible. And if one is not compatible, that change is ejected from that queue, and then everything else has to restart without it. So talking more about jobs. All of our jobs run on virtual machines that are spawned in our cloud regions from scratch. And after the job finishes, these virtual machines are destroyed. They're gone forever. So we call them dynamic CI nodes, as opposed to static CI nodes, which last for forever or for a longer period of time. A CI job can be broken down into a few phases. So pre at the beginning, which is where we clone the source code, set the git state, and so on. Post at the end, where we pass the Bazel output and upload all of our metrics. But the bulk of the job is always the main part in the middle, and that's where we run the expensive Bazel commands. Talking more about Bazel, so our monorepo is pretty big. You heard from Johannes. We have 300,000 targets, a lot of external repos, over 200 gigabytes. So you can already imagine fetching 200 gigabytes in every single build 80,000 times a day. It's going to be expensive, or it's going to bring down our network. How do we solve this? We use the concept of disk images, or with Zool it's called node images. What we do multiple times a day, we build a disk image, and we bake into this disk image the output of a Bazel command, so the output base with the external folder, everything already extracted, the exec root, all of that. We also bake into the disk image the operating system, so Ubuntu in most cases, also other certificates and configs and packages and so on. And then with this disk image, we upload it to our cloud regions, so on-premise and AWS, so that every job which starts up in these cloud regions can use this pre-built disk image, and everything is immediately present on the file system when those jobs start. Talking more about pipelines. So the pre-merge pipeline is the first pipeline that a pull request encounters. But before that pipeline even starts, we do have another layer of defense we call puts-a-fish. You can think of puts-a-fish as a microservice which runs in the cloud, and it listens to events from pull requests and can run super fast linters on the files changed in the pull request, like Builderfire, Python format, and so on. The downside is it operates on a per file basis, so it of course doesn't have the context of the rest of the Bazel workspace, so it's limited in some ways, but feedback is just a couple of seconds, so perfect for developers. Once that succeeds, the real pre-merge pipeline can start, which spawns the job, starts the virtual machines, and so on. In the pre-merge pipeline, fast feedback and developer velocity is really important. So we only run small and fast tests in this pipeline, or tests with a short or moderate timeout. We also have some other quality of life checks in this pipeline, such as checks to prevent the prevent Bazel query from being broken, prevent the analysis phase from being broken, and so on. We also have other checks which are configured via YAML. So some examples down here, which prevents bad attributes from being added to targets or bad features and so on. And most importantly, we do have a dependency checker to prevent the so-called spaghetti workspace from being from becoming a thing. This is also configured via YAML. And so for the prominent scopes, you can say exactly what the scope is allowed to depend on. And then if a user introduces a dependency which is not allowed, the check will fail. If it's valid, then the user can, of course, add it to the whitelist. But if it's not valid, then the user has to break that dependency. One key challenge that we've encountered over the years is flakiness. So infrastructure flakiness, namely, this is most common. This is most commonly downloading external repos from anywhere, really. There can be network hiccups that interrupt the download and cause failures. To sort of mitigate this, we developed a tool called Smart Retry, which you can think of as a wrapper that wraps around Bazel, and it detects the output of Bazel, and if there's a failure, it's able to classify the failure into either a compile failure or an infrastructure failure. If it is detected or classified as an infrastructure failure, then the exact same command is run again, keeping the Bazel server alive, the analysis cache hot, the cache on disk hot as well, which is much better than the job failing and the resources being wasted. It's also able to dynamically change the commands, or add or remove flags. For example, if a flag was the cause of a failure, it can be removed, or if a flag could be added to mitigate a failure, it will be added. The example in the top right is when Bazel goes out of memory, or the JVM goes out of memory. Smart Retry is able to dynamically reduce the jobs for the next attempt, so that less jobs running in parallel means less memory being used, with the hope of not going out of memory. So moving on to the execution phase, we have a big workspace. Compiling just the business logic from scratch on a 32-core machine takes at least 6 hours. So of course, caching is essential. We do have the local cache in the disk image, which I just mentioned, but this can become out of date very quickly. For example, the duration when you start building a disk image and when it becomes available later on, this can be many hours. So the content inside the disk image, it can be out of date quite quickly, depending on, of course, the changes that were merged in the meantime. One level up is remote caching. For us, we use BuildBarn, which we really like. What we worked out very early on is that cross-region traffic is never a good thing. And on-prem and AWS as well, we have many different cloud regions. So to mitigate cross-region traffic, what we did is we set up one BuildBarn instance per region, which was great because it avoided all of the cross-region traffic. But it did mean that for every cloud region or every remote cache, you had to build and upload the cache hits n times for each remote cache instance, which was not great, especially in pipelines where developer velocity was very important, like the pre-merge pipeline. To solve this, we developed a bit of logic called smart target picking, which was inspired by a prior BazelCon talk. The gist of smart target picking is look at what files have changed in the pull request, work out the targets affected, and only build and test those targets. A quick overview of how it works. There are 4 central steps. The first step is git diff, so pretty self-explanatory, work out which files have changed in the pull request. Second step is Bazel query our build files, so work out which build graph files directly depend on the modified files, so like build files or .bazel files. Third step is Bazel a query, so work out which targets have the modified files as inputs. And then finally, cquery reverse dependencies, so essentially work out the indirectly affected targets of the directly affected targets. In most cases, actually, where you don't invalidate the whole universe. So the example on the screen, if you just modify a README file, this is perfect because nothing's going to get built and tested. This is super fast. Or if you just modify like one test or something, only that test is going to be built and tested, irregardless of which region your build's running in or which remote cache you're using. That's really fast. But if your change validates the whole universe, yes, the whole universe has to be rebuilt, which is expensive. Talking more about the execution phase. So another pain point in the past was determinism and hermeticity. So you can think of non-deterministic actions as actions where you build it once, it outputs one thing, you stay on the same Git shard, and you build it again a second time, and the output is completely different. So this ruins caching, and it has to be recompiled over and over, and it's not great. In our experience, this is mainly due to generated files. So baking into files timestamps or IDs or paths, or the classic iterating over an unsorted data structure. This produces non-deterministic files. Also, non-hermetic actions, so actions or targets which depend on something on the host, or just in general, the dependencies or inputs aren't correctly modeled in Bazel. This means, or this for us anyway, resulted in very hard to debug remote cache poisoning issues. And of course, the big one, these actions can't be executed remotely because that dependency is not present in the remote worker. For non-hermetic actions, it's quite easy to work out what's hermetic and what's not. You can just try and run it remotely and see what fails. And for non-deterministic actions, there are some features in Bazel that can help you detect non-determinism, such as the execution log binary, which we use. Another pain point is test flakiness, so different to infrastructure flakiness. This is when a test fails sporadically from time to time and for no reason. For us, this is mainly due to tests which are multi-threaded and require more compute resources than one core can provide. And of course, if you run as many of those types of tests as you have cores, then those tests are going to exhibit undefined behavior. Also, we've had in the past general issues with test frameworks, which made them flaky, and so on. And of course, there's many other reasons. To detect this, there's quite a simple approach, is brute force it essentially. So overnight, we have a lot of idle on-prem CI resources, and what we did, we ran all of our tens of thousands of tests overnight on those idle resources to work out what's flaky and whatnot. We also track this kind of data in the normal, or the regular pipelines, like the pre-merge pipeline and the merge queue pipeline. And with this data, we can make certain assumptions. If it fails in the pre-merge pipeline, if a test fails in the pre-merge pipeline, it's actually okay, because that's the point of the pre-merge pipeline, to see if your change breaks a test. But if a test fails in the merge queue pipeline, it's either because there are two changes which touch the same part of the stack, and those two changes are incompatible with each other. That's also the point of that pipeline. But if it happens too often, we can maybe say this test is flaky, this test is broken, and we have to act. How do we act quickly? We developed a tool called the Auto-Sheriff, which was also inspired by BazelCon in the past. The Auto-Sheriff looks at all this data generated from the builds, and it automates a lot of actions to deactivate these tests. So it's rule-driven, like most of our other tools. On the right, you have an example of a rule called Marcus Flaky. A rule can be broken down into a condition and an action. So the condition in this example is if a test has failed more than once in the merge queue pipeline, and if that condition is true, the action is triggered. In this example, the action is use bulldozer to set the flaky attribute to true on the affected target. It's also able to automatically open up a pull request, which then a human can approve and merge. Some tests, however, they're just too long running or too flaky, so they can't be in these pre-merge pipelines because it would affect developer velocity too much, so we put them in the post-merge pipeline. But the challenge for us is, as these tests are not tested before a pull request is merged, how can we ensure when someone breaks a test and they only know about this many hours after their pull request is merged, how do we ensure that they fix it? For this, we developed a process and platform called Track and Fix. You can see an example of this on the right. And what it is, it sort of visualizes the tests that some of the feature teams own and provides the status of each test. So is this test broken? Is this test freshly broken? Is this test flaky? And so on. because we upload data in every single CI job and every single pipeline, it's also able to provide a best guess as to which change broke a test and contact the test owners to try and fix it. Finally, monitoring and profiling, extremely important for our team. So we pass all of the output from Bazel. We upload this data to Elasticsearch, our database. Also, any of the files outputted by Bazel, we upload this somewhere where feature team members can download this afterwards, like test logs and so on. We also do SAR logging. So with SAR, you can see exactly what's being done on the VM at every millisecond. And finally, Bazel profiling, extremely important for us. We also use the no-slim flags because we think that we get all of the data with that, and it's really important. We also do some post-processing of the Bazel profile to sort of filter in or filter out parts of the profile we don't necessarily care about. And then we upload it to Elasticsearch, where we can create aggregations and visualizations like what you can see here. Like, for example, on the right, we can have the sum of the duration of all actions in a profile broken down by mnemonic type, so you can see what Bazel's doing for the majority of the time, like in this case, 50% compiling, 20% test actions, or even break it down on a per target or a per file basis, like on the left. So we know if a particular file, if it's spent a lot of time compiling, that allows us to focus our efforts and maybe dive in and see what's wrong with that file. There were many other problems, but we don't have time, so I'm going to hand it back to Johannes to talk about the future.
Thanks, Alex. As Alex already mentioned, so this is just a very small number of challenges which we were facing, which we think we already have solved. Please let us know afterwards if you guys would be interested in one of the next BazelCons. We might go into some more challenges. We are still facing a lot of challenges, actually, and just to give you some idea about the major points we're currently working on. So one is remote execution. We're together with Engflow, we're currently evaluating their software as a service setup or solution. Regarding performance, as you can see on the bottom of the slide, it's really way faster than a 6428 core machine on AWS, which we used as a reference here. Currently, we're still in evaluation of the stability and the cost, because cost is a really major factor for us. One thing to remark here, if you still have a Bazel workspace and you're maybe starting small or you're starting setting it up, please ensure that right from the beginning you take care that it's hermetic, because for us it was a major pain point to make it hermetic. It took more than a year to work on it, and it's still ongoing. Another thing we're working on is smart resource and smart job picking. Smart resource picking, you can imagine that we're running some queries, because for every change, for every pull request a user is creating, we're running like 10 to 120 jobs, depending on which repository, which folder this pull request is in. And with smart resource picking, we're running a query to evaluate how many build and test targets are there to be built and tested. And depending on the number of targets or tests, we choose the size of the virtual machine. So if, for example, only a README or one test is touched, we could run on a 4 or 8 core machine. On the other hand side, if the whole universe needs to be built or tested, we are starting up a 6428 core machine to be faster. Next step would be smart job picking. Smart job picking goes even one step further. You can see an example at the bottom of a first implementation. So instead of starting up the VMs, also if it's just a 4 or 8 core machine and setting up the workspace and everything, we just don't run the jobs if it's not necessary. So we can save a lot of resources and have faster feedback. Machine learning is a big topic on our side. We're using it for faster developer feedback and to reduce CI costs. So one use case, for example, could be to identify if a change has a low likelihood of failure, so that it will succeed, and then we put it in a fast check or a fast gate pipeline. Or on the other hand side, if the likelihood is very high for failure, we can have a multi-stage check on it to save resources. And last but not least, CI cost is a major challenge for us, as you can imagine, with so many resources being used. We have a high 7-digit budget for only the cloud resources currently, and we're pretty happy that we didn't make it to 8-digit this year. It's a big challenge. We're practicing FinOps, just started on it, but we have to bring the cost down. last but not least, and one of the major things what we want to address here is, without the migration to Bazel and without you as a community, not just the people working on Bazel and bringing Bazel forward, but also the whole landscape around it, like Build Barn and whatever, we wouldn't have been able to be at that scale where we are. So big thank you to everyone of the Bazel community. We heard Build Barn was a major contributor here as well, but also a big thank you to everyone within and sadly sometimes outside of BMW now to contribute to our workspace and make this happen. And side note, we are hiring, so if you're interested to have some CI Bazel at big scale, please contact us. Thank you very much. We're open for questions.
Yeah, hello. I'm just wondering, was there a specific reason why you chose Zool as your CI/CD framework?
You want to answer? The main reason was Zool is very good at with using multiple repositories and gating those changes from multiple repos together. Other CI systems is mainly like one repo based, but with us we had so many, like 20, 30, 40 repos. We need to gate those changes together, and Zool, it calls itself the gatekeeper, so it's really excellent at multi-project support. Excuse me? Can you hear me?
Can you answer? We can't hear you, but if you speak up, we would repeat the question.
Yeah. Something tells me the deliberate decision not to use. So something tells me the deliberate decision not to use static CI.
If I may, so very good question. So we had definitely more than one POC on static CI workers. We actually do have static CI workers. So we're running some tests on hardware workers, for example, and some other tests on QEMU machines, which we were not able to put them on top of our open stack setup because twice virtualization was very bad. So we are running static workers in our environment. They're having their specific problems, and that is also the major problem why we decided against static workers, because you always have to watch out that static workers are in a proper condition, and that whatever a developer is doing, and our developers in our CI config repository can play around and test whatever they want, that they leave the static worker in a proper state, that the next job which is running on the static worker does not have any issues running on the static worker. In the POC, we did some cleanup and some major work in make that happen, but to be honest, we failed. So we stayed with our dynamic nodes because you can ensure that the dynamic node is always in a state that only the change of the developer is run against a ground truth and not what somebody in front of you has left.
Hi. Could you elaborate in one of your future plans? You mentioned you're looking to skip builds that are predicted to succeed. Could you elaborate what that means and how you're going to do that?
So what we're having in mind, it's not implemented yet, we're working on this. What we're having in mind is, Alex presented to you that we have pre-merge checks, like a check pipeline, a gate pipeline, and then we have post-merge checks. And the idea behind this is that for fast developer feedback and getting stuff integrated as fast as possible, if the likelihood is very small that a job or a test is failing, that we take it out of the pre-merge checks, but rather test it afterwards and use our processes like the track and fix to identify if something got broken. And worst case, it would be automatically reverted to change and the user would be informed. It's all about developer feedback and getting stuff integrated as fast as possible. Because currently we're having, I think on average, 500 pull requests being merged per day with a growing number. And at this scale, it's difficult to avoid concurrent changes and enable developers to do a fast integration.
Hi.
Hey, great talk, thank you. I'm curious if you looked into any tooling to inspect the dependency graph to see if there are any optimizations there that would prevent running unnecessary tests. I figure in a large code base this would be relevant. Many thanks.
Yes.
Would you be able to share any insights? Thank you.
I mean, dependency optimization, that's always a topic. And we try to protect it from getting worse with the dependency checker, but we haven't really found capacity yet to like break the existing dependencies and optimize them. But it's always on our radar. It's always something that needs to be addressed.
Thank you for the talk. I'd like to invite Ren to talk about RabbitMQ and the story of rules Erlang.
Thank you. Hi, so I work at VMware on messaging and streaming. And yeah, I'm looking forward to, oh, hold on, we need to talk, right?
Joe? Joe?
Where's the next talk, all right? That's still the old talk. There we go. All right, great. So yes, RabbitMQ and the story of rules Erlang. So first, I want to say, if you obey all the rules, you miss all the fun. And the first rule that I will probably break is I will probably say Bazel and not Bazel, because I learned about Bazel right in the heart of the pandemic, and there was no one to talk about it with. First, what is RabbitMQ? RabbitMQ is a multi-protocol message broker. So you post messages to exchanges, they get routed to queues, consumers consume message from the queues. And we also added more recently streams, so that's non-destructive consume. RabbitMQ is written in Erlang, and that's a general purpose, concurrent, functional, high-level programming language with a garbage collected runtime. And it uses a virtual machine and it has platform-independent bytecode. RabbitMQ was started in February of 2007, so it's been around a long time, and it's open source. What is rules Erlang? Well, everybody at BazelCon can probably guess, but there are Bazel rules for building Erlang applications, and they're also open source. So I promised you all a story. Once upon a time, RabbitMQ had a build problem. In the old times, and this is early 2020, which is around when I joined the team. So the RabbitMQ broker was built and shipped from around 30 different GitHub repositories. And we had an umbrella repo. You could use that umbrella repo to clone all the other repos and build stuff and run tests and so on. And if you ran make tests in the umbrella repo, it took several hours locally. I'm pretty sure I never got the whole suite to pass on my machine. We had our CI/CD in a dedicated Concourse CI cluster. And when we rendered out the pipeline YAML from our templates for a single release pipeline, it was almost 30,000 lines of YAML. So they were really big pipelines. They were so big that if you tried to render the whole pipeline in a single Concourse view, it would break Concourse, at least back then. So we had to split it up into multiple views, and that's why I have no screenshot of it, because it's not that impressive when split up. When you pushed a commit, it took 2 to 3 hours for that commit to run through the pipeline and be green. And that wasn't the entire pipeline, because the release pipeline had packaging and upgrade tests and building of release artifacts and all those things. So that was like, if you wanted to do one of those, you'd get the results the next day. But like the primary test, primary stuff took 2 to 3 hours. And there were test flakes, which means that often it would go red anyway. You have to rerun some stuff or something like that. Also, the way Concourse works, it has a notion of resources and jobs. So a resource could be like a branch of a Git repository, or it could be a Docker image. And a job is arbitrary stuff that you run once you fetch the resources, and a job might put to another resource to update the rest of the world. So because we had all of these repos, and because in Concourse a Git repository resource is a branch, you just had to do your release branches. So you could only run the tests after you had merged something to a release branch or the main branch as well, but you couldn't test a PR in any sort of reasonable way. There's some hacks around that if you've got a small project. There is a concourse resource that you can sort of meta program concourse with, but for something like this, it wouldn't work. Oh, and so the main thing was you couldn't wait for CI to be green before pushing a new commit, and that caused all the usual problems that sort of thing does. Is there's multiple commits, you have to revert something that's many commits behind, and it was not great. And while this was certainly not perfect, it was still okay. Like, we continued to ship new versions of Rabbit. There weren't too many regressions. Having slow tests is way better than having slow tests at all. And people that had been on the team for a while kind of knew the code base. They knew if they changed something here, these are the suites that I could run, keep things efficient, and feel pretty confident about what they pushed. Although that's not true if you're a new member of the team. And so we thought this could probably be so much better. At least we hoped it could. It actually got a little worse before it got better. So we're getting into mid-2020 here. So we had the code in those 30 repositories. And why did we have that? So Erlang programs Erlang code can be organized into applications. Most of those repos were an Erlang application. And the RabbitMQ message broker has sort of a core Erlang application. And there are lots of what we call the tier 1 plugins. So they ship with Rabbit, and they add core functionality like support for new protocols or authentication mechanisms or all sorts of stuff. So we always shipped it all at once, even though it would have been possible, say, to like upgrade the core broker, but not the management UI. But we never tested that. We already had the 30,000 lines of YAML. We didn't want more. So we decided to roll these into a single monorepo. And that was good. It became possible to like do a git bisect. You could just check out the branch and have everything. You didn't need the umbrella repo in the same way. But because Concourse was this graph of the repos and jobs, it had this inherent test caching to it. The plugins, the tier 1 plugins were downstream of the core broker. And so there was some inherent test caching there. And when we went to the monorepo, it broke it because everything just depended on the monorepo, and we got more and more flakes. So finding Bazel. 2 to 3 hours for one of your commits to run through the pipeline is a lot of time for research. So during that time, lots of ideas were generated. So we thought about different things. Like with Concourse, we could have filtered the paths of the monorepo to make it look like all the original different repos and restore that graph. But being able to go back to the same number of flakes, still 2 to 3 hours, wasn't that good. So that didn't seem great. We thought about building our own test result caching mechanism into the pipeline. So maybe we write test results and get SHAs into a database, fetch those, and short circuit parts of the pipeline. Another thing we could do is just have fewer integration tests and try and make the suite faster overall. But all those things seemed like an awful lot of work. And it usually felt like, especially with test result caching, we'd be reinventing the wheel. Like we could build Rabbit and we could ship Rabbit. So we already had somewhere in the build a notion of what plugins depended on what, because some plugins are interdependent, and the order of everything. And we just couldn't use it in CI. We were replicating all that. So we found Bazel, and we were tempted. It sounded great, fast and correct, very nice. The test result caching seemed like it would work very well for us. Remote build execution seemed great because maybe we could dump that Concourse cluster that would fall over sometimes, and we'd spend like half a day restoring it, and it was expensive. It ran on GCP. And we do ship Rabbit for Windows and Linux. We don't really, well, there might be a homebrew formula for Mac, but anyway, having that cross-platform support in the build did seem like it was important. But on the other hand, nobody on the team knew Bazel at all. We knew the current build very well. It was makefiles, and it used another, I guess you'd call it a make plugin or a makefile, Erlang MK, that knew how to build Erlang stuff. So we knew that pretty well. We knew the author of Erlang MK, and they actually joined the Rabbit team since then. This was a big one, is Bazel had no rules for Erlang or Elixir. And Elixir is another language that targets the same VM as Erlang. So that wasn't so good. And we read some blog posts, and they were kind of scary that said, like, unless you have a crazy build that needs something really powerful, this is not a good idea. Everything has to be hermetic. And we read some of the Bazel docs. We said, yeah, it probably should be hermetic, and we should probably build Erlang with Bazel. And we read the docs about platforms and tool chains. And we were like, let's not. And back away slowly. And that's kind of what we did for a little bit. But then we still had those long build times, and we still had time to research things. So we started to say, what if we broke some of the rules? The metric that we really care about is that 2 to 3 hours. And we want to get that down as low as possible. So what if we cheated? What if we just used Erlang from the host? What if we just worried about CI and said local development doesn't matter, we'll just keep using make and Erlang OK? And what if we use something like Build Buddy or something like that to make RBE really easy, and then we could get rid of the concourse cluster? And with that, we had an initial commit to Bazel Erlang on November 20th, 2020. So the question is, could Bazel help us slay the build dragon? And the answer, I think, is a resounding yes. So we were able to get to green commits in about 20 minutes. So this was the pull request that brought it live into RouterMQ server. It was number 2398. I don't remember what it was called. It was big. It was 221 commits. We merged on March 29th, 2021. It used Bazel Erlang master because we didn't want to tag it 1.0 yet. We weren't that confident. And when we did that, it deleted about 5,000 lines of GitHub Actions YAML and replaced it with just 54 because it basically became like set up Basilisk and Bazel test // ... And it used both remote cache and RB from Build Buddy right away. So we didn't add RB later. It was kind of there from the beginning for us. And everyone lived happily ever after. Well, that's kind of true, but not quite. We didn't stop. So what we had at this point was we had green builds many times a day. And this was absolutely amazing because honestly, we used to rarely have a fully green build on a day. So this was great. Now we had just a Bazel build setting for where the host Erlang was and what version it was. So this is how we invalidated the cache when we switched the Erlang version, because we would do that pretty often. Erlang applications, you can usually get away with compiling a single application like one call to ErlC, but sometimes you have to compile some files first, and we just wrote that into the build files. We had pretty basic external dependency support, so we always pinned all of the dependencies anyway, so we had all of the transitive dependencies already listed in our build for the most part. So we just listed them all. And it was pretty basic, but it worked. And that was the thing. Like, we felt like we had something that worked well for us, worked well for RabbitMQ, but probably didn't work all that well for anybody else. So what was missing? What would we like to have? Well, just enough confidence to call it a 1.0 would have been nice. A rule set that was useful to other teams, a better way to manage the Erlang versions, convenient external dependencies, at least better than what we had, and make the local development experience better, because we didn't really want to have two build systems forever. And there was more. I've kind of forgotten all of the things. So we kept working on it. And probably the best way to go through that is just like a brief history of the rules Erlang releases since then. So we got to June of 2021, and at that point, like it was stable enough that let's just tag it. In July, same year, we tagged Bazel Erlang 1.1, where we added support for the Bazel test sharding. That was nice for some of our bigger test suites, especially ones that would flake, because if you shard, it won't rerun the passing shards. So that was nice. Then we got to January of 2022. We learned, oh, this is how rule sets are named in Bazel, so let's rename it. We called it 2.0. And we started getting the Windows builds to work better. We got to version 2.5 in April of 2022. We finally handled the phase compilation automatically, and that was like the first time we built something in Erlang and had all the other Erlang rules depend on it. So that was a bit of like, what is a tool in Bazel? And we started to support Bazel mod. Then we get to June of 2022, rules Erlang 3.0. And here we started to be able to build Erlang inside of the Bazel build. So this was nice. So what we used to do is we would bake Erlang into the Docker image that we would use with Build Buddy RBE. So we had a different Docker image for each of the Erlang releases that we wanted. And it was a separate thing to manage and all of that. So like it worked like everything else, but it wasn't the best. So now we could build Erlang inside of Bazel. And if we wanted to change the Erlang version, that was just a new PR. How would it work? And that was another great thing about all this is we could finally run tests on PRs. So that original PR was like around number 3,000, where I think like 9,700. And that was 2 years ago. So there's been another 6,000 pull requests. September of 2022, we had rules Erlang 3.6. And here we kind of looked at rules Docker and we added an @Erlang config repository that detected your host Erlang and figured out what version it was. So that was nice. You could finally get rid of those build settings. Each person didn't have to have a line or a couple of lines in their Bazel RC file to tell Bazel where things were. When we get to rules Erlang 3.9, we added an experimental Gazelle language extension, so it could parse the Erlang, it could manage some of the dependencies or the internal dependencies automatically, do some nice things there. And then it was actually just last week. So 3.13 added some code coverage support tests. So it's been about 2 years, a little bit more, and looking back on this, how did it go? There are lots of good things. So it was about, and we go from that November commit to the end of, I think it was March. It was like 4 months, and we had basically one person's worth of effort, full time on this, and we got from like, say, an average of 2.5 hours to an average of 17 minutes. Now you can probably all go fact check me on, is it really 17 minutes? Because it is an open source repository, but I think it's still around there. Now, this definitely would not have been possible without something like Build Buddy. So we used to throw a lot of compute resources at these pipeline, like it was an expensive concourse cluster to run, but it just didn't apply that efficiently. And with RB, with Build Buddy, like all that compute is accessible. It schedules so cleanly. Without that, we couldn't get down to these build times that just kind of changed the way that a team can work, because the build is mostly green now. Using RB with local changes, you can run like 50 of a test in parallel and see if it flakes and diagnose flakes. So we're going to have to cut down some of the flakes. And it's nice just not to run all those tests that we already know that they're going to pass. There are things, though, that are not so good. So we still have both build systems. We still have the Erlang MK build, and it's not ideal to have these two. We have some nightly GitHub actions that run a build with both systems. They compare sort of some of the core release artifacts, make sure everything is basically the same. It catches some drift, like it definitely happens where someone will go and update a dependency in the module.bazel file and forget to do it in the make files, or the reverse, things like that. And it's really disruptive to change the way that developers work like day to day. And we only added code coverage last week, and Erlang MK had code coverage at the beginning, so 2 years ago. So it's taken us like a really long time to close some of those build system like feature gaps, I guess you would call them. So it's not great to have both builds, but I think it serves it kind of makes sense. This was not about having a cool build. This was always about just letting everybody develop faster, push code faster, and enjoy working on Rabbit. So if we had said like, okay, it's Bazel time, it's Bazel time. It's not Erlang MK time anymore. That would have been really, really rough, especially because it's like, well, you just can't do code coverage. So we've got both, and that's not the best thing, but we're probably going to work on continuing to close the gap. We also don't have full parity in the Windows build, so there's some things there. Also, the overall release pipeline, so they still have plenty of stuff in make files. You know, some of those things don't translate super well to Bazel, so we have like Debian source archives. So that's ships the source of Rabbit, and it builds on the installation machine. So, you know, there are rules for building Debian package in Bazel, but not source packages, and it kind of makes sense because, you know, it just doesn't really fit the Bazel model that well. And certain things are just like a bit clunky. So we have a module extension for loading other Erlang dependencies from hex.pm, which is the Erlang package manager. And I know with Bazel mod, the actual repo name goes through the repo mapping. So it's this unpredictable value. And if you specify the wrong one, you just get the normal version. So there's been lots of times where somebody wanted to, you know, pull something, patch it locally, try it out, and you're like, I don't see my changes working at all. Like, what's going on? So, you know, it can be rough. And it's more work when you have to author your own full set. So that's certainly true. And one other thing is that we also use the Elixir language for the RabbitMQ CLI. So we have like the basics of a rules Elixir that are embedded inside RabbitMQ server, but they're not sufficiently generic enough for us to extract them. So we'll work on that. You know, I don't know when we'll get to it. The normal tool for building Elixir sources is called Mix, and it really wants to do everything all at once by itself, accumulating on the file system and mutating stuff. So it's actually really a little hacky what we have for a solution for that. But yeah, overall, Bazel has just been like a huge win for RabbitMQ. So what's next? Well, the code coverage is one of the features, and I didn't think we'd get to it by now, but we did. So general usability things. Let's see. I mean, one of the things is maybe trying to speed up compilation. That's not a bottleneck in RabbitMQ, but maybe other people that would use rules Erlang would use it. And with the Gazelle extension, you can either generate basically like a ton of rules, like one rule per source file. So then there's a lot of compilation actions. Or you can generate fewer, which is what we use. And so we do have like persistent workers for that. It's not merged, but you know, that could serve some purpose as well. And I've been told the docs could use some improvement. So we'll work on that as well. So, you know, I think we thought that we were breaking a lot of the Bazel rules when we started with rules Erlang way back, but we are actually doing okay. The build was always correct as far as I can tell. We had maybe a few issues, but very, very few. The team has always felt like comfortable with cache hits, and we do get a good amount of cache hits in our build. So, you know, it's not perfect, but it doesn't have to be. Like, it can be imperfect and still give some really big wins for your project. So, I guess I'm a little bit fast, but time for Q&A. Sure.
Yeah, hi, and thanks for your talk. I'd be interested in the coverage. So I have no idea about Erlang, but did you manage to support the native Bazel coverage command?
Yeah, so you can just run Bazel coverage now. Erlang's interesting in how it does coverage. Like, I looked at Bazel's coverage documentation. It's like, okay, you can check if you know these compilations should be instrumented, or when your dependencies should be instrumented, and do different things. And that's kind of like a very C, or I guess C++ style of things. And it turns out with Erlang, you don't do that. If you want to do coverage, you start up the Erlang VM and you ask the cover application, because the Erlang's runtime libraries are themselves organized in the application. It's called the Open Telecom platform, because Erlang came from Ericsson, and they did use it for telecom originally. And so you start up the VM, you use the cover application to say instrument either these sources or this compiled bytecode, and then you execute it, and it'll write the cover data. And it writes it into its own format, but you can still use that same library to read it and analyze it and query it. So what we do is we just build another little tool in Erlang that, if coverage is enabled, beginning of the test, we sort of hijack into that Erlang VM and we instrument the files. We run the tests, it writes it out to disk, and then again, if coverage is enabled, we use our extra utility to convert it to LCOP. And then all of Bazel's regular machinery will merge those files, and then you can send it through GenHTML and get a report. So that's actually pretty nice. You know, I had sort of wondered before, like, Bazel seems to generate everything totally independently. So how does it merge? And it is a bit of a special case. So yeah, kind of a shout out to the Bazel Slack channel, because I was going to use some extra I realized undocumented stuff to do our own conversion, our own merging. And I was kind of like, maybe it's not that hard to just convert to LCOP, but that's what we did. It's like, you know, it's like a one screen. It's like 100 lines, 150 lines to do that conversion. So it's no big deal.
Okay, so the last point is interesting. So you do convert to LCOP?
Yep.
Yeah, okay. Thank you.
Thanks also for the talk. So you said it takes now 17 minutes or something. Where are most of the time savings? Is it cache tests, cache build?
Yeah, that's a great question. I've not really gone through and analyzed it. Like, so the way that this project is structured, there are a good set of tests that get invalidated almost all the time. So if you do change one of those plugins and only one of those plugins, that will run a pretty small subset and you'll get quite a lot of cache hits. But you know, if you change, there's lots of tests that basically build the whole broker, they start it up, and they usually like white box it. So they load some other code and they RPC into that node and they do some stuff and check some stuff. Those are all at least medium tests. We couldn't reliably get to run in a small size, so under a minute. So a lot of those get invalidated. But if I think about like the averages that I've seen, if we get, you know, in, like a good number of cache hits, like, you know, not 100%, but very high, it'll run in a couple of minutes. And actually the GitHub Actions portion of it, just getting a GitHub Actions worker ready to kick that off is the slow part. And then if you got more like a medium level, it's around that, you know, 15, 20 minutes time. And if you got a PR that like changes out the Erlang version, which essentially invalidates everything, that's maybe like 45 minutes. You know? So how does that work out to the ratio of like how important caching is versus RBE? RBE is very important, clearly. So we are really happy to have found BuildBuddy, and they've been very supportive of our project, and that's worked out really well. So it's, yeah, I'd like to know that question. I guess you could just turn off RBE and try and run with the cache to answer that a bit more directly. But the cache hits vary a lot, so you know, we see a lot of, like, we build other stuff with Bazel as well at this point, like some Docker image and things like that, and those can be really quick in certain cases because you've got, like, you know, building the base OS. Well, you've got the base OS, but like building Erlang, and that's a cache hit, and then you've just got like taking the Rabbit binaries and injecting them. So it's really quick. So there's, if you look at our BuildBuddy builds, it might say the average is like really small because it includes other stuff that are separate Bazel indications. One more? Okay.
Is there any relationship or comparison to rebar?
In what way?
I don't know if it used rebar under the hood or if just like a speed comparison.
Well, as far as I don't know if there was an attempt before my time at Rabbit to have Rabbit built with rebar. Possibly, but I don't know why it didn't work. I think it would have ultimately been like very, very slow for us because rebar is kind of meant for small stuff. I think like a lot of Erlang stuff, I think are relatively small projects. So I can say that the Gazelle extension will read rebar config to a limited degree, and we'll set up the Bazel build files accordingly. So that's one of our actually workarounds for Windows is we can do Gazelle update repos, and we've got some custom arguments for that to pick something up from say like XPM. It will pull it down. It will recursively run Gazelle extension on that, build up the build file, and then drop that into your main repo. So that means that we didn't have to replicate all of the live auto import logic that we had across all the platforms. So yeah, out of time. Thank you, everyone.
Thank you, Rin, for the talk. We have another 15 minutes break, so please come back at 4 p.m. for the last stretch of lightning talks. Thank you.
Okay, let's get started. Please find a seat. There's plenty of seats in the back there and also over there. Let's do the final round of lightning talks, starting with JDK21 and Bazel. Chair and Sheng Wei.
Hi, this is Xu Wang. And I'm Zheng Wei, and we're both from the Bazel team. So as Toby mentioned yesterday, one of the changes we have made in Bazel 7 is we have finally upgraded the embedded JVM to the 21 from 11. You might be wondering what it brings to us.
So we have been benchmarking the performance implications of upgrading our JVM, and we've seen some quite promising results. From our internal benchmarks, we've seen improvements of up to 20% for CPU and 14% for wall time. However, we noticed that this was only for high-core machines, and we didn't see improvements in low-core machines. And in some of our experiments in production, we've seen a 5 to 10% wall time improvement across builds above the 50th percentile. We've attributed the performance gains to the improvements in the garbage collector, which takes up a significant amount of time in builds. With the release of Bazel 7, we welcome you to share your benchmarks with us.
Besides the runtime performance improvement we gain immediately, the new language features that JDK21 introduced also open new opportunities for things that were hard or impossible to do in Bazel. More specifically, virtual threads allow us to rethink how we can implement async execution in Bazel. To understand what is async execution, let's start with how Bazel executes actions today. In Bazel, an action runs a program on input files and produces output files. For example, you can have a compile action that takes full.cc and runs G++ to produce full.o. A build is a collection of actions which can be represented by a graph. Bazel can execute actions concurrently if they don't depend on each other. The max number of concurrent actions is controlled by the flag jobs. Bazel uses a thread pool to drive the action execution. The size of the thread pool is equal to the value of jobs. For each action that is ready to be executed, Bazel puts it into a queue. One of the idle threads will take the action out of the queue, prepare the data structure, start the subprocess, and wait it to finish before it can collect the result. Since the thread had to wait for the subprocess to finish before it can execute other actions, we call this synchronous execution. Synchronous execution is fine for local execution because the number of cores we usually have on our own developer machine is limited. For example, if we have 64 cores, Bazel can just create 64 threads to utilize all the cores in most cases. The problem is it doesn't scale well with the remote execution. When we build remotely, there are usually more cores available in the remote cluster. For example, probably 1K. How can Bazel utilize all of them? We can increase the value of jobs. But remember, Bazel uses a thread pool whose size is equal to the value of jobs. With a large value of jobs, in this case, 1K, there will be too many threads that the entire build could be slowed down. Not to mention, in the case of 10K, 100K, it's impossible for Bazel to create that many threads. So the idea of async execution is to reuse the threads. While one action is being executed, instead of letting the thread waiting for it to finish, we schedule other actions to it.
And in order to do that, we need to be able to suspend the task and store all the related states while the thread is waiting for the action. After the action is finished, we need to resume the task and restore the state. This sounds like exactly what this thread provides. Instead of using platform threads, we can use virtuous threads to drive the action execution. When the virtuous thread is waiting for the subprocess to finish, it will be detached from the platform thread. Hence, the platform thread can be reused for other actions. By doing so, the number of platform threads doesn't need to match the value of jobs. For example, Bazel could just use 16 platform threads to drive thousands of concurrent actions. On top of that, we want to make Bazel to be able to dynamically adjust the number of concurrent actions. For example, Bazel could schedule less concurrent actions if it is under memory pressure to avoid Or Bazel could schedule more actions if it finds out that the remote cluster has more cores available. Hopefully, we can remove the need to manually tune the jobs flag. Bazel should be smart enough to utilize as many resources as possible.
So async execution is one good example of how virtual threads could improve build performance. But we believe that there are other opportunities elsewhere. Bazel does a lot of parallel I/O, making a lot of file system and network calls throughout the life of a build. Hence, we want to catalog the different use cases of concurrency in Bazel and figure out where we stand to benefit the most from using virtual threads. Taking a step back, we have a few goals to improve concurrency in Bazel. Firstly, we want to improve the overall utilization of available CPU resources and ensure that we are getting the most out of the machine. For example, in the analysis phase, we execute many concurrent tasks which are heterogeneous. That is to say, they do both CPU and I/O intensive work. While we have made some improvements by separating I/O and CPU bound tasks, it's not perfect. As such, we want to explore whether virtual threads would be a more generic solution to the problem. Our second goal is to reduce the need for fine-tuning in Bazel. Currently, we have many thread pools that execute different tasks. For some of these thread pools, users can control the pool size by setting flags, allowing users to choose the flags that give them the best performance for their builds. However, it's not always easy to do so for a variety of reasons. Firstly, builds are inherently different. A set of flags might be optimal for a particular target and its build graph shape, but not for another target. Secondly, builds are affected by their environments, and there are a host of factors such as the number of CPUs or the amount of RAM that affects build performance. Lastly, it can be difficult to even know which flags or what values to use without an understanding of how Bazel works and how each flag affects the build. We might end up in a situation where users go through trial and error without being able to find an optimal set of flags to be used across all targets and environments. Now let's take a step back and look at the more procedural side of things. Bazel has been using Java 11 since 2 years ago. Even so, that was 3 years after Java 11 was released. That's because a migration on the Google scale takes a long time. However, we are looking to change things. This time around, we have reviewed and are streamlining our internal processes to make sure that things progress more smoothly. With this, we hope to increase the cadence of our JDK upgrades in the future. This will allow us to reap the benefits of JVM improvements and start leveraging new language features earlier to improve Bazel for everyone. With that, thank you very much.
So next up is Patrick, who tells us how to make CI more efficient. Let's do this for them. No, thanks. Great. Oh, please start.
All right. I'll try to go without my notes done. Hello, everyone. My name is Patrick Balestra. I'm a staff engineer working on developer experience at Spotify. And today I'll be talking to you about improving CI efficiency with Bazel querying and Bazel diff. So first of all, let's talk a bit about Bazel at Spotify. We're currently trying to move all of our clients to build with Bazel. The first clients to be completed are all of our iOS applications that can now build with Bazel. Soon we should be able to also build all of our Android applications with Bazel. And we also have C++ and TypeScript code bases that are shared between some of these applications that we are soon also going to move to Bazel. Our goal is to move all of these repositories to a single client monorepo, which could host more than 10 million lines of code, 150,000 tests, run over 1.5 million CI builds every month, and receive 8,000 commits a month from various hundreds of engineers. So when we started thinking about this possible client monorepo, we foresaw some challenges. One of these challenges, of course, our continuous integration scale. So this is a simplified version of our dependency graph. We have Android applications, iOS applications, and a shared C++ code base, and then a desktop app building for multiple platforms, and also a web component that ships in there. So if we focus on one of the parts of our monorepo, such as the iOS part, we realize that we could have, as I said, tens of apps, thousands of components, thousands of test targets. And so whenever a developer wants to write a new test, for example, for our full lib tests target, we don't want to rebuild the whole monorepo. We don't need to build our Android code. We don't build our shared C++ code, also because some of these parts of the monorepo build on multiple platforms. So we don't want to waste time checking out the repository on a build agent that doesn't really need to do anything. So effectively, our problem statement becomes finding which Bazel targets are affected by a specific diff. And this is a question that has come up more and more on the Bazel Slack as well over the last couple of months. You just don't need to do this kind of like finding which Bazel targets are affected by a specific diff only for improving your CI efficiency, but also to kind of find out, what do you need to redeploy from your monorepo, or many other answers that you could get. So there are various tools to solve this problem. One of them, of course, is Bazel querying that comes with Bazel. You could run a query, you could run a C query, and use functions such as RDEPs and our build files to find the set of affected targets. Benjamin in 2019 gave a very nice talk at BazelCon, and also someone from Pinterest, I believe, in 2020. So if you want to learn more about this approach, you can, of course, look at these talks. And then in 2020, Bazel diff was open sourced by Tinder. It kind of abstracts away a lot of these issues that you would have to figure out yourself. And it supports query, C-query, and also the stream proto output format, which is a very efficient way to parse even gigabytes of proto messages coming from Bazel. And then in 2022, Target Determinator was also released. It currently only supports C-query, I believe, but it's a very similar idea to Bazel diff. So you can go ahead and experiment with these tools and kind of find out what works for your use case. I'll be focusing a bit more on Bazel diff in this talk because this is what we use at Spotify, but it's also what. But I also believe that a lot of the things that I'll be talking about are tool agnostic. So some of the ideas should be reusable for all the other tools. So let's talk about Bazel diff a bit. Bazel diff supports two commands. The first one is a generate hashes command. What this does is that it generates a hash map representation for the entire Bazel graph and writes it to a JSON file. In this case, starting hashes.json. So you can see the list of targets on your as a key, and the value is a SHA-256 that represents all the attributes that go into that specific target, including all the inputs. So what we then do is that we change revisions. So we check out our different commit, for example. We run the same exact command and output the hash map to a final hashes.json now. And we can start to see that the hash is different for the same target. And so we then run the last command available in Bazel diff, which is going to get our impacted targets. And so here we have, again, our target full lib tests that change between the two commits. The BazelLeaf repo contains a great example script that you can just use and try to experiment in your repositories. So it should be really fast to see some example outputs. So now that we understand how we can find the impacted targets between two revisions, we can put this information to use to improve the efficiency of our continuous integration builds. So in this image, we can see that we have a simple continuous integration pipeline. So we could have, a task that builds our iOS applications, another task that builds our Android applications in Linux, and then even more tasks that build and run our tests on different platforms. In our client monorepo, if we were to merge all of our repositories today, the list of tasks could be over 100. So we, of course, want to reduce this number to a minimum. So first of all, what we do whenever a developer pushes a change to our repository, we run a diff task. And this runs exactly the same logic that we just specified. So we can then find the impacted target in the change submitted by our engineer. So what we then try to do is that we try to introduce a simple YAML file that defines the conditions in which subsets of our pipeline should run. What I mean by that is that, as you can see, releasable apps is running a query, right? So we want to run a query to find all the releasable targets in our monorepo. So in this situation, we see that we have an iOS application and an Android binary. So if in the intersection between the query that we have specified in our YAML file and the list of impacted targets that we got back from BazelDiff is empty, it means that effectively it's safe to skip these tasks and we can just ignore them on CI. We continue to run the second query. In this query, we're trying to look for all the iOS unit test rules that are in our repository. In this case, of course, we just have one target as an example, and we see that there is a valid intersection between the two lists. And so it means that we actually need to build our tests and run them on iPhone and iPad to validate the change submitted by our engineer. So as you can see, we simplified quite a bit the initial pipeline to only run the subset of tasks that are strictly necessary to validate this specific change. Also, in order to better understand and communicate to our engineers what's going on in our CI, we do display this information in a GitHub check. And we also are pretty explicit on what kind of CI tasks we can skip as a result of this system. So we call this system build avoidance, and we have seen at least a 30% reduction in our build agent usage. This is mostly because we can reduce our cloud costs, but also provide a faster experience to engineers who are contributed to maybe just a smaller part of our monorepo, and we don't need to rerun everything else that is maybe more expensive. Here are some tips after using such a system for a couple of years. Of course, this is a Bazel query, so you can trust it for changes that happen outside your Bazel dependency graph, such as bumping your Bazel version or changing Bazel RC flags. So BazelLeaf comes with a really nice feature, which is called seed file paths, which accepts a list of files that, if changed, will invalidate a hash for your whole repo, so effectively causing everything to rerun again. BazelLeaf also has a couple of flags to customize the behavior of your query, so you can kind of like improve the accuracy and performance of the query if you need to do so. And if you're interested about this kind of stuff, last week we published a blog post on our engineering blog where we talk about how we moved our iOS application to Bazel. So if that interests you, I encourage you to take a look at the blog post. And yeah, please find me later for questions, and thank you.
Thank you. I see a lot of people sitting and standing there. There's empty seats over there if you want to get a normal seat. Next up is Niels, who will take us on an adventure.
Hi, my name is Nils. I come from the Swedish professional services company, Marathon, and I'll talk about a memory adventure called Dude, Where's the ROM? As we all know, the ROM is gone. I tried to find it, and it was harder than I expected. So the first image is just a stack trace that you've all seen. And this is extra good because it doesn't even have the Starlark stack trace. It's just a Java heap space error. But even if it did have the Starlark stack trace to identify the culprit, with memory, whatever fails may not even be the culprit. So I have a diagram there with a green allocation that fails. But the big problem is the larger red box below.
which would not be identified by a stack trace. So we start with some synthetic data to figure the problems and see what tools can help identify it. So we have a basic CodeGen repository with Python and C++ code. And then I added two aspects. One is very memory intensive, that encodes a string of the dependency tree for all targets and allocates more and more and more. And then there is a CPU intensive task to model the water, which actually allocates a lot in the build phase, but not in the analysis phase. So we have a catalog of tools. Many of them are post hoc, and these are what the guide for memory analysis talks most about. We have Bazel info, Bazel dump, and we have the A query for Skyframe state. Then there are the Java tools to understand what the Java process does, with the Eclipse memory analyzer being very good. And you can also dump a histogram with JMap. And we also did some work with the Bazel profile, which is customarily used for CPU profiling, and it has the well-known Chrome tracing format, and it can easily be parsed. And to restate it, our problem is that the analysis phase is on the critical path for all builds, especially when you use remote execution and remote cache, and you don't want to execute any actions. And in our specific example, we have very large action objects. So Bazel dump rules doesn't work. Here is the result. It's hard to see, but it's not at all close. So we have up to 17 megabyte large strings in the memory intensive aspect, but the profiler says that it's about 14K or 4K each, which is not correct. The Eclipse memory analyzer is much better. It even finds our big string that's 17 megabytes, and it comes from a configured aspect in a Skyframe executor. But we don't know which Skyframe executor. We don't know which starlark, which function. But a heap dump can tell us the problem, just not where the problem is. And we did plot the memory or the execution time against the memory limit. So when you vary the memory limit, it starts to fail with low memory, and then the time increases until it reaches a transition period where it sometimes fails and sometimes does not fail. So there are some crosses and a success, and then more crosses, whereas at least one run failed at a given memory. And then it flatlines with constant performance. But if we enable SkyMud, it looks very funny in the low memory region because it tries even harder and does more, manages to do so before it fails. But at some point, it starts to succeed, and then it requires much less memory because the resident set of actions to execute can be worked off, or you start to work on action as soon as they're analyzed, and then you can free the memory much sooner. You don't need as much at any one point. And we also notice a plateau, which is thankfully highlighted by the screen limit here, that it goes above, up to the third screen with medium memory, and then it falls down to a flat line, which is actually less memory or less execution time. So we find that there is both a region where it crashes, but also a pessimized plateau with barely enough memory, where more memory will make it faster, but enough memory still works. And this is also very hard to diagnose without just trying with more memory. Yeah, these are the points. And we also have some speculative ideas about looking at the profile for the active threads at the time of the crash. That the problem should be statistically overrepresented very close to the crash if we parse the profile. And we can also parse all the events and functions and compare them against the number of garbage collection events. The more garbage collection events concurrent to any function evaluation,
the higher the risk that it's at fault. And you can also notice in this, I don't have good slides for it, but that we see restarts of the start-like functions. So the less memory, the more often any given function is called, presumably because it's restarted. And then you can also look for the cause in the statistical patterns. So our takeaways is that we don't have a solution. We don't know how to find the memory thief, but we think. And we tried to create a big, hairy code base, which was, well, that we can do, but it's not representative of large corporate code bases. And the analysis tools each have their pros and cons. But we think that if you can profile a lot and save them within CI and go back and analyze what's different in the patterns between successful builds and crashes, that may be very useful. And we have our example repository with aspects to do stupid stuff on GitHub, Marathon, and Memory Adventure. And we'll write blog posts with deeper analysis as we perform them. Thank you.
Thank you. Next up is Tony, who will give an update on SBOM.
Yes. Good afternoon, everyone. Tony Ayudo. Though I manage a team that deals with knobs to let you build for multiple platforms, my IC work is about SBOMs. And I'm going to give an overview of the roadmap of the changes from last year, what we've done, and where we are today. Great. So at the end of 2022, I gave a similar talk, and we had a vision. And the vision was that rules license had abilities to annotate packages with the license they were under and their versions and things about them. And that would just get widely deployed, and people would put it in their rule sets, and we'd upstream it to other places. Repository rules, as they were downloading and creating build files or looking at your build files, would splice in information when it was possible. We had existing tools to gather this information, and SBOMs would easily flow out of it. And then we hit the reality. And the reality was it's a lot of effort to upstream this stuff everywhere. We didn't have staff to do it because we were focused on compliance with the US government DO 14028. Modifying build files robustly that other people had written and inserting license rules. It was a pipe dream, smoking the ganja. And it's difficult to separate. It's right. One of the difficulties we encountered a lot was tools aren't always marked, and you don't necessarily want them in an SBOM that's saying this is included in my code. The tools aren't. So we learned a lot about separating the tools from the included dependencies in your artifacts. And we learned that low quality SBOMs are easy. You can say, well, I include all this stuff, but there's more that should happen. You want to be able to see things like, I built with this tool, or I used a vendored in jar file that came with its own SBOM. And one of the things we've learned over the last year is that there is no answer to any of those questions. The answers depend on what your lawyers think at your company. I mean, if you're a small open source project, yeah, you can use a generic thing. If you're Google or VMware or Spotify or ASML, your lawyers care about the answers to these in ways that may be different than other people's lawyers. And the specs from SPDX and Cyclone don't necessarily help. They leave a lot of things vague. I mean, if you follow the mailing lists, there's still debate about what these fields mean. They've got definitions, but how we use them is up for grabs. So in spite of these difficulties, we made some progress in 2023. Around June, we started producing an SBOM with Bazel as part of its regular CI. It's a path through. It can be better. Bazel itself has the advantage of only being vendored in third-party code and things from Maven, mostly. So we were able to use the lock file from Maven to get a lot of things in spite of not having rules, license, annotations on stuff. With inside Google, as part of our compliance effort, we improve the tools to gather licenses. We can export that quickly. And as I said, we learned a lot of new things about interpreting the various specs. We'll come back to that later. So our current vision at the end of 2023 is be pragmatic. While we'd like to upstream package annotations from rules license into everything we include, that's going to be difficult. So the fallback position is use what we can from the upstream and our code bases, and use lock files from package managers to fill in the other information about packages. So they're increasingly adding things like the actual license code is under included SPM, included SBOM files. We'd like to forward that from the package managers out. And the big realization is we will not be providing solutions totally. We'll be doing reference implementations because your company will have different processes around it than my company. So we'll have things that work out of the box for most people, but for the larger corporations, you're going to want to take the stuff and write your own. Short-term work. We're going to take the things we've done over the last year, bring them into rules license, produce some guidelines for rule authors who want to add their own package declarations to their repositories, and build some reference SBOM generators. And by short term, I mean we may accomplish a lot of this weekend at a workshop at Packaging Con, so like immediate term. After that, we're going to do the obvious things, do more lock files, start reading the Bazel mod lock file, which was interesting. We're going to have a mechanism to let you override what package authors say about their packages, because many of them get them wrong. And they say, this is under Apache 2. And when you look at their code, you go, no, it's not. It's GPL'd. So someone in your organization, in the compliance team, needs the ability to say, no, 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 that package at that version is really this license, in spite of what they say. And I know that's unclean, but yeah, it's the world. We have to deal with it that way. After that, of course, the obvious improvements. We want to make the runtime better, runtime performance better, because we're doing an aspect that takes a top-level target, goes all the way down the tree, and essentially gathers the build graph. We've got some proposals that have started. I've got to make them public to the GitHub world. We've talked about them internally to ruin an aspect on the way down, so you can look, oh, those dependencies of this rule are tools. I don't care about them in this graph. Don't even run the aspect down to them. That'll save them some memory. The other thing we'd like to do is annotate the graph in, annotate rules in a way to say, this attribute is a particular kind of dependency. It may be included in my binary, but it's not code. It's a data file, like a message catalog, because that matters in the SBOM world. We have some ideas for that. Like to talk about the trust chain. You know, what machine built this thing? That matters to other people. I had some other thoughts on this. We can come back to it. A lot of people would like to see Cyclone DX in addition to SPDX. They're two standards, so we just have to do both. And in the long run, you're not going to be able to pick one because your customers are going to pick what they want from you sometimes. So we'll end up supporting that. I'm going to end with a thought that a fellow Bazel community member said. I don't know if they're here today, but their feeling was Cyclone DX is the right thing, should do that. But the US government wants SPDX right now, so we've done that first. How much time do we have? We've got actual time for questions, but I have to leave right after the show, so I'm going to go outside for questions if people want to find me but didn't have office hours before, and I will cede the time back to the next person. There you go.
Thanks, Tony. Next speaker is Marcin. Where are you? Ah, there. Talking about aspects.
Hi, I'm Marcin, your favorite bouncer from the Thursday game night, and in spare time, I also develop Bazel plugin. And today I will tell you a love story about Bazel and your favorite IDE. Right? Happy ending love story. Our goal is to just create a plugin which allows you to open Bazel projects. Everything is green. No errors, highlighting works, you're happy, we are happy, everyone is happy. But yeah, it's not that easy. Bazel provides us very useful tool aspects, and we obviously use them to do our magic. One of our main goals is to actually support wide range of languages/rules. It applies both to bundled in rules like rules Java, rules Python, and similar, but also to external rules created by community, by you, like rules Kotlin, rules Scala, and others. We actually support all of them. But let's stop for a second. Just a quick reminder for everyone what aspects are. So an aspect is a function applied on nodes of a subgraph of the build graph, where you define edges in the subgraph. So you just traverse the subgraph and you can do things. And there's one important side note. Normally, if you develop aspects in your workspace, you can make assumptions about the structure of the project, available rules, all the other things you can imagine in Bazel. And then you write aspects, and worst case scenario, if something fails, you just update your workspace file or aspects, and you are happy. Our case is different because we, with our plugin, open your workspace. So our aspects are not aware of your workspace, of available rules and the configuration there. We just inject our aspects, we execute them on your workspace, but unfortunately brings some issues. But let's talk about what we actually need to collect from your workspace. So there are like trivial things usually defined in build files, like name of the target, sources of the target, dependencies, maybe language version, things like that. But there are also a bit more advanced things, let's say, quite often defined by the rules themselves, which are important from the build tool point of view and from IDE point of view, like Java outputs or class path or things like that. And there is a useful mechanism in Bazel to obtain such things, providers. And there is the old API for obtaining providers. You just use the dot operator and you just use it as a normal field from the target. And there is the new one, the recommended one, I would say, where you actually have to load the provider and then use the square brackets syntax to obtain it from the target, and then you can use fields from it. Is it an issue? Unfortunately, yeah, because as I mentioned, we want to open your project with our aspects. And we support Kotlin rules, for example. And let's imagine a scenario that you just want to open empty project, nothing in the workspace, and we run our aspects with Kotlin support. I know what will happen. Error, yay. Well, Bazel doesn't know about the Kotlin rules, so it's not possible to load the provider, and aspects will fail, sync will fail, IntelliJ won't be happy, you won't be happy, and we won't be happy. So we have a solution, no worries. Well, that's one of the reasons why I'm here, I think. So our whole mechanism starts with rule detection. So we want to know what rules are available in your workspace. So in the workspace file-based projects, we just run Bazel query with some filtering after that. And we just started working on the Bazel mod support as well, where we probably will call something like Bazel mod graph. to obtain just available rules there and be ready for the next step. And the next step are actually the aspects themselves. So if you open your project with our plugin, you would probably notice a .bazel.psp directory with aspects directory. Because we support multiple rules, we decided to split the rule-specific support into separate files in the rules directory. Here you can see Java info and Kotlin info. And we have the core part, which is more or less rule agnostic. The idea is that it should just traverse the build graph and delegate things to the extensions. And extensions, it's also the name of the file, which is generated by our mechanism. Initially, this file is empty since, well, we have no idea what is there. We run the rule detection mechanism, and we get some info. Completely by accident, there's Kotlin. And yeah, now we know that Kotlin rules are available in the workspace. So we can load the Kotlin extension and add the extension to the extensions array. And next, in the core part, we can actually use this array. So core part just traverses the build graph. It collects all the generic info, let's say, and delegates the rule-specific tasks to the extensions. So it's more or less a simple iteration for the array, and we can collect some additional data used for language-specific support inside IntelliJ. So finally, we can move to one of the implementations, again, completely by accident, Kotlin, where we are sure that the provider can be loaded without any errors, because this file will be loaded into the aspects only if the Kotlin rules are available in the workspace. So we can safely import the provider, just do some work, even use the square brackets syntax, and be happy, collect Kotlin information, and pass it to the IntelliJ. So yeah, our general idea is to support as many rules as possible, because we are aware that you actually use a lot of rules. And we want to make your experience as best as possible with that. We actually yesterday kind of announced our beta experimental, not that public release of the plugin. So feel free to try it out. And yeah, I also want to thank Kasia a lot, because she actually implemented vast majority of the mechanism. And yeah, thank you.
Thank you. Next is Derek, who will tell us about Bazel Lib.
All right. Hi, I'm Derek. I'm an imposter, software engineer at Aspect. I'm the author of the Publish to BCR GitHub app, and I'm a maintainer on our open source rule sets. Today, I'd like to tell you about one of our rule sets, Bazel Lib, and how it can make your lives easier. So there are a lot of common problems that pretty much every Bazel user will run into at some point or another. And although these problems seem relatively simple, the solutions to them often aren't very straightforward, and Bazel only gets you part of the way to solving them. The goal of Bazel Lib is to bridge this gap by providing high-quality solutions to the most common problems so that you don't have to reinvent the wheel. So Bazel Lib is our general-purpose Starlark library. It's used by all of our other major rule sets, including Rules.js, Rules.ts, Rules.oci, and Rules.py, which my colleague Matt will be presenting on right after. It comprises 7 tool chains and 38 rules. It's very actively maintained, and of course, it's Bazel mod compatible. So in this talk, I'm going to go through several problems that build file authors and rule set authors run into, and tell you how Bazel Lib will help you to solve those problems. Let's start out with flags. What flag should you set? So there are a lot of them. I counted 581, but someone else said there was 1,000. So the answer is that it's probably somewhere in the middle. If you haven't seen it already, I highly recommend checking out Ulf Adams' analysis of every single flag and his recommendations. It's as fun as it sounds. The problem with flags is that the defaults aren't always what you want. There are some flags you need to enable to to address performance. There are other flags that just fix bugs. And there are certain flags you want set on your local machine that you don't want on CI and vice versa. So it can be really overwhelming trying to figure out what to set. Well, the good news is that you can just trust us at Aspect. We've worked with over 40 clients, and so we have a pretty good idea of what most people want to set most of the time. And so we've distilled this into a set of our own flag recommendations. So in order to use our recommendations, you can use this macro write Aspect Bazel presets. This creates a runnable target that will generate a bunch of preset files, Bazel RC files, into your source tree, which you can then just include in your own Bazel RC file. We also generate one that you should only add for CI. If you update BazelLib and if our recommendations have changed, you'll receive a failing test that prompts you to rerun the command. Speaking of writing things to the source tree, how do you do that in general? So there are many reasons why you might want to write to the source tree. You might want to vendor files like we just did with our presets. You might have tooling outside of Bazel that doesn't understand the output tree. Or you might just want to check in test snapshots or generated documentation. So we provide a macro, write source files, and that will take any target file or directory, and it will write it directly to the source tree. It creates a runnable target, and it also stamps out a diff test so that if what's in your generated output tree ever diverges from the source tree, you'll receive a failing test, and it will tell you which command you need to run again to re-update those files. Write source files works with directories, which is something you always have to double check, Bazel rules. And you can chain them hierarchically. So you can have one write source files to rule them all, and it can update all of the other ones. Okay, moving files around. So this is something that seems like it should be relatively simple, but it's not super trivial. Let's illustrate this with an example. Let's say you have a directory artifact and you want to include files from other targets and a directory from another target. How would you do this? Well, you could write a gen rule, but gen rules can't produce directories, so you'd have to archive it. You could maybe create a new Bazel package and then use copy file and copy directory from Skylib, and that would work for this case. But let's say you need to do something more complicated. You need to take some file from a folder, or you want to glob over a folder, remap some paths, reroute file trees, and that's when you start to get into custom rule territory. And we feel that this is common enough that we wrote this Swiss Army knife of a rule called copy to directory. And what that will do is it will take all of the targets and sources and copy them, but it will also perform a bunch of transformations. So you can glob which files to include or exclude. You can remap paths, you can reroute file trees, and you can actually do a lot more. So you should go and check out the documentation. Now, what's extra cool about this is that we've optimized it. So this actually uses a custom toolchain that we wrote in Go, and it uses hard links rather than copies by default for generated files. So that's a lot faster. It also runs copies in parallel, and we modify the default execution requirements. So for example, it doesn't need to run on RBE. We do similar optimizations for our other copy rules, so you should check those out as well. All right, let's talk about manipulating common types of files. So BazelLib provides a JQ toolchain, which you can use to generate and manipulate JSON files. You can see, for example, how easy it is to just remove deb dependencies from a packaged JSON file. We have a similar toolchain, YQ for YAML, that does pretty much the same thing. And we have this rule expand template. And what that allows you to do is take any generic template file and substitute variables into it. So these could be arbitrary variables, make variables, location expansions, or stamp variables. Speaking of stamping, so we've been through a number of cases about how BazelLib helps build file authors. Let's talk about rule set authors now. Starting with stamping. So stamping in Bazel is a little bit awkward. You enable it with --stamp, but only built-in rules are aware of this and can work with it. And any custom rules you write aren't aware of this flag. And so that means rule set authors need to implement their own magic to work with this flag. And if everyone's implementing it slightly differently, that can lead to bugs which break determinism, because rules always have access to the status files, even without declaring stamp. And so it can you can have bugs that break determinism. So rather than everyone reinventing the wheel here, Aspect BazelLib has provided a standard way to implement stamping in your rules. All you need to do is import the stamp attributes that we provide into your rule attributes. And then you just need to call maybe stamp in your implementation to check if you should stamp. This will check for the presence of the -- stamp flag, but it will also evaluate it against stamp attributes directly passed into the rule. But let's talk about variable expansion. So in your rules, you might have some attributes where you want to expand different variables. So Bazel provides context.makeExpand variables. However, this does not work with the very useful general style variables. And there are some other variables that we at Aspect think are useful to include, but they aren't included by default. So we provide this function expand variables, which works for predefined variables and toolchain variables, but it also supports the very useful general style variables and some others that we found useful. How do you efficiently copy files? So there are some rules that need to do a lot of copy file actions within them. We have a couple of these in rules.js, and we're dealing with NPM packages, so they might need to be copying thousands of files within the rule. So if you recall, we have that optimized toolchain for copying files. We actually expose the implementation of that rule so that you can directly use it within your own rules to use our toolchains to do all the copying for you. As a reference, we found that compared to our previous bash implementation, for rules that need to copy thousands of files, we found there was about a 7x speed up using our new toolchain. So in order to use this toolchain, all you need to do is import this action. You pass in the rule context and then whatever arguments the particular copy function needs. All right, so I would like to announce that BazelLib 2.0 is here, or it was supposed to be by the time of this presentation, but it's actually in a release candidate currently, but you can use it. It features a brand new tar toolchain, which uses BSD tar, and it exposes a public API for the manifests. We also have support for the brand new JQ 1.7, which has much wider platform support than previously. We also, of course, have some breaking API changes, which make it a bit nicer to use. Thank you very much for your time. If you'd like to try out BazelLib, I highly recommend starting out with our write aspect Bazel presets macro and go from there. Thanks.
Thank you. Next up is Matt, who will talk about rules pipe.
Hey, yeah, so my name's Matt Mackay. I'm also an imposter at Aspect Development. I've worked in various areas of developer experience and as a tech lead for building infrastructure teams and orchestrated large Bazel migrations and rollouts. As well as Aspect's Bazel rule sets, I've also helped to maintain some of the open source rule sets in the Bazel org, such as Rules Python and I guess the now less so Rules Node.js. So today I'm going to talk about Rules Py, a Python rule set for Bazel, and how it differs from Rules Python and why you might want to use it. Okay, so what is Rules Py? Well, before we dive into what Rules Py is, let's answer a slightly different question. What isn't Rules Py? So currently, Rules Py is not a full Rules Python replacement, and we'll go into the details a little later on, but I just wanted to make that clear here. All right, so what is Rules Py? So Rules Py is a layer on top of Rules Python and provides a more idiomatic approach to running Python under Bazel. We'll go into this later too, but if you've used Bazel and Python before, you know there are quite a few gotchas. Rules Py provides full Starlock implementations of the Python rules, like PyBinary, PyLibrary, and of course PyTest, as well as a few of our own rules that complement the rest of the rule set, such as PyVM. So yeah, as I mentioned, Rules Py is this layer on top of Rules Python. And currently makes use of the Python interpreter toolchains. So you can still use the Python Hermetic interpreter toolchains that are provided by Rules Python, or you can, of course, build and register your own, like whatever you do now. We also still use the existing pip pars and other external dependency management in the exact same way. Third-party dependencies are still fetched via those rules. Mostly, I should say here, RulesPy has first-class support for wheels, but you can still plumb the rules Python external dev rules into it. Currently, we still use the same Gazelle extension too. So if you generate and manage your build files with the Python Gazelle extension, you can still use that in RulesPy. However, again, I put a little asterisk here. We may fork that soon, just so we can better support some of RulesPy's own features and help to improve the performance that we've noticed in much larger code bases. So I keep mentioning this like idiomatic approach. What do I really mean by that? So RulesPy makes use of Python virtual environments. I've kind of hinted at that already, which are a more native Python construct. Our philosophy here is to try and meet the tooling where it is. So instead of trying to teach all the different ecosystems tools to work with Bazel, RulesPy integrates with the existing tooling. Among other things that we'll see in a moment, RulesPy removes the requirement of having a dependency on the system interpreter, as we currently use Bash launcher. But again, I guess that may change because we now depend on Bash. So as I mentioned, we make use of that Python virtual environment. Let's take a look at that. So if you aren't familiar, a Python virtual environment is a sandbox-like environment that contains the required Python interpreter, the one from the Bazel toolchain. And it also contains only the required dependencies that you requested from the target. So it's completely isolated from other Python projects in your repository or on the rest of your system. So it's kind of akin to Bazel sandboxes. They're considered disposable. They're quick-ish to create and destroy. So using this virtual environment allows RulesPy to not have to meddle with the Python path at all. The Python path is just a way that Python finds dependencies via import statements. And instead, we use that slightly more native approach that we create a site packages folder, and the normal resolution kind of takes over. The other thing it also removes is it allows us to run the interpreter in isolated mode. This one removes the current working directory from the first part of the sys path. So the moment you run like a Bazel test, the current rule implementations kind of break out of that sandbox. So as this other consequence of this meet the tooling where it is approach with RulesPy, RulesPy can add IDE support to existing Bazel Python projects. We can generate a virtual environment for different levels of granularity, such as a single Py binary or an entire project, and have the existing Python extensions for IDEs pick up those virtual environments. They already know how to configure the IDE with that virtual environment. Bazel's just generating it. It's the same Python interpreter that you declared on the toolchain, and it's the same dependencies that Bazel manage that end up in that virtual environment. So then features such as go to definition, autocomplete, and other existing tools that run inside the IDE can just kind of work natively. So yeah, as I mentioned, RulesPy is that layer on top of RulesPython, and includes Starlock implementations of PyLibrary, PyTest, PyBinary. These are also exported as structs, so like the rest of our rules. So if you need to extend them, it's slightly easier. Although I think we've seen now that there might be something else coming. I should also mention here that there is ongoing work to Starlockify the existing rules. But this is still the underlying implementation of how they work is still tightly coupled to how Google Free do Python. So you can consider this just another approach of how to do Python rules. So changing the existing rules may be trickier to change than just turn them into Starlock. So yeah, as an extra feature that I want to mention and call out up from RulesPy is this thing called virtual dependencies. This is where a Pi library can simply declare a dependency on a library, like an external third-party library, but not to any particular version or be tied to any kind of label. Then the consuming Pi binary or Pi test is then required to actually provide that dependency. This can be super useful for supporting multiple versions of the same dependency. Either that's how you do dependency management, or like during a migration of like one version of Django to another, for example. There's a huge amount of stuff to unpack around virtual dependencies, but a very quick example looks something like this. So you've got like a Pi library at the top that you're kind of familiar with. I don't know what it is, something to do with Django. It has the name and sources that we're all familiar with. But then there's this extra attribute at the bottom where we just declare this dependency of Django. Like we don't know what that is. But then at the Pi binary level, again, we've got the normal things. Like it's probably a very small Django app, but we have our sources and our depths on our Pi library. But then we've got this resolutions field. And here it's where we have to replace that Django string, that like opaque Django string, with something more concrete. And at this point, we're supplying version 424 of Django. So when I would run that Pi binary, I'd get version 424. You can imagine like another Pi binary next to it, like with a completely different version, just overriding that Django opaque token. So yeah, rules Pi is, again, other aspects, almost at version 1.0, where we're happy with the API. We've fixed a whole bunch of bugs and, well, mostly around virtual depths. We hope to publish the final 1.0 very shortly, so we do encourage you all to give it a try. Rules Pi does support a more incremental migration path. It should be just as simple as just replacing the load statements for your existing Pi under rules. We support, like, I don't want to call it a sandwich, but the like Python rules Python sandwich, where you go from like a rules Python Pi library to a rules Pi one and back again. There should be interoperability there. We also recommend, for even like better integration, we do recommend using a pure wheel setup where possible. Rules Pi will make, like I said, it's got first-class support for wheels. So yeah, yeah, that's everything. Thank you very much.
Thank you. Last up is Albert. Ironically, the last talk is called Kickoff.
Yeah. Hello, everyone. My name is Albert. I work at Canva, an Australian company that runs a software platform to empower the world to design. But today, I'm here to talk about Kickoff, which is a side project of mine that started basically as my attempt to solve a problem that we continuously see in Canva engineers struggle with, especially when trying to build applications with Python and Bazel. So if you allow me, let me use a little user story of what this problem is about. Let's imagine we have Adam that decides that his team has a very manual operation and he wants to automate it by creating a very small Python application. And he decides to use Bazel to build and package this application before he can ship it to the rest of his teammates for them to use. After a few iterations, he manages to get to the state where he can run Bazel run and gets the application running on his computer as he was expecting. Then, super happy about the results, he goes and packages his application by tearing up the output directory that Bazel has produced and uploads it to his personal server and runs to his colleague Alice to show her that now this manual operation is no longer a thing and she can actually use Adam's application to basically get that done more efficiently. Super happy Alice goes and downloads the package application from Adam's web server and runs a few commands that Adam helps her with to install this application on her laptop, which, by the way, is the same platform as Adam. So they basically share the same computer settings, like the same operating system and CPU architecture. But unfortunately, even with those similarities, when Alice tries to run the application on her computer, she's greeted with not so great error message that says, oh, Python 3, no such file or directory. And both Alice and Adam are pretty sad about this, because one of the reasons they use Bazel for is like all these hermeticity and reproducibility guarantees that just so happens not to be that visible in here. And the same way Alice and Adam were asking why, you might also be asking why this is happening. Well, turns out it's not that really Bazel's fault in this case, but if we look at the output directory, the Pi binary from rules Python output, you will quickly see where the problem is. So if we look at the run files tree here, you can see this suspicious app file that you would expect to be a binary that can be natively launched in the target platform, which effectively, out of your surprise, is not actually a binary. It's a Python script that contains a very offending shebang that turns out to be resolved in the target platform. So even though the run files tree contains a fully fledged Python interpreter, something in the target platform needs to do the work of actually finding this Python interpreter in the runs files directory, and then do all the heavy lifting of launching the application with this interpreter. Unfortunately, this creates kind of like a chicken egg problem of, well, if we have the Python interpreter within my run files, but I need a Python interpreter to find it, which Python interpreter can I use? And in this particular case, the easiest solution that the RuleSpy authors seem to have landed on is just assume that there will be some form of Python interpreter installed in the target platform, which in the case of the poor Alice didn't happen to be. In terms of specificity, there's a little bit more going on in this bootstrap script in here, but roughly can be summarized as like this pipeline of shell commands here in terms of what this logic does. The question I asked myself after figuring out how all this stuff worked and why our developers were facing this problem is like, can we do better? And thankfully, the answer is yes. But before we introduce everyone into like what can do to make this better, I wanted to take a step back and see like what would the ideal solution would look like in case that we can live in a perfect world. Well, in an ideal situation, we really want Bazel to be able to produce a binary executable for all the target platforms that we want our application to run in. And this binary application has the logic to actually perform this bootstrapping before the Python application is actually run. By having a native binary, what this effectively means is that the system interpreter no longer matters. And in fact, this can be run in a particular computer where there's no Python interpreter at all, and instead the interpreter comes as part of the bundled run files that we ship to our users. With that in mind, I started exploring with different alternatives because on the slide before, this kind of looks like a cross-compilation setup, and cross-compilation sounds like a very complicated thing to set up, and especially for rule set authors for interpreted languages to have to deal with. So is there anything else that we can do that may avoid the need for a cross-compiler? So as we've seen in the previous talk, some rule sets have decided to, instead of depend on the Python interpreter in a system, instead depend on Bash or a POSIX shell, which is usually like way more likely to be in there. But still in Canva, we found some problems with this approach when trying to run the same application within a Scratch container that might not even have a POSIX shell. That brings us to the next alternative, which is to use containers. With containers, we can use the container runtime as this native launcher that knows, hey, by the way, the Python interpreter is in this run files directory, and I want you to launch this container using this particular path, and therefore everything works. And this works very well for binaries that are meant to be run on the server side, because we can control the fact that the container runtime is installed, and we can also make sure that everything is set up for the application to work correctly. But it might be a little bit of a more problematic alternative if we plan to ship these applications to client side, because our users might not even have a container runtime installed, or if they do, sometimes if they run a CLI tool locally, they might expect that it can see some files in the file system or even reach through the network, and the process and network and file system isolation that come with containers might get in the way. So after evaluating all these possibilities, I kind of like going back to, well, it turns out that really the solution that works better here is a native launcher, but the cross-compilation aspect of making a native launcher is kind of like really the problem that I'm trying to solve here. So I started thinking, can I actually emulate the idea of having a cross-compiler without having a cross-compiler. That was a wild idea until I actually stumbled on the fact that executable binaries formats for all major operating systems, ELBS, macOS, and P32, turns out to not care about arbitrary data that can be appended at their end. So what I did is I built Kickoff, which is this particular launcher that is basically a collection of runtimes that are pre-built. They're pre-built using Rust, which can target multiple target platforms. And using this knowledge that I got that binaries for the major operating systems don't care about arbitrary data being appended at the end, it allows users to basically inject at the very end of each of these runtimes a JSON manifest in a trailer to tell the runtime how to actually read this manifest with like the starting point and the length. And therefore, when this runtime executes, all it does is it reads itself, reads the manifest contents, and therefore performs an execve call with whatever it finds in this manifest that has been previously specified by the user. So in reality, this is just like a pre-configured execve call that reuses the same runtime binary every time for whatever application we want to run. However, sandwiching bytes as this might be a bit complex, and especially if you're not familiar with like how this trailer should look like. So it might not quite cut it for rule set authors in Bazel. So I was like, can I do actually something that helps them produce those launchers and do the sandwiching of bytes? And that's why Kickoff also comes with a CLI that is a very simple like CLI logic that embeds all the possible runtimes for the target platforms that we currently support. And it allows a very easy interface to basically construct one of these sandwich of bytes that will eventually become your native launcher on the target platform for whatever system, for whatever application you're building. So from here, the real question is, well, this is ready to use, but like what are the next steps that I would like to take to make this a bit more production ready and perhaps even make it like something that rule set authors can use more easily? One of the things that I have to say is that currently the runtimes for Linux still depend on the target platform being a glibc-based platform, because I didn't manage to build the runtimes against Muscle, but that's something that I plan to actually fix. Maybe I can also provide some Starlark APIs, so rule set authors can use like toolchains to bring in all these runtimes and then call certain like Starlark functions to construct these launchers in a very user-friendly way. And of course, right now I don't support platforms such as FreeBSD, which if there's appetite, obviously they can be added in the future. The project is available in GitHub. It's totally open source, so contributions are welcome, feedback are welcome. Also, this is like my first project in Rust, so anything that you can contribute to make this like the code better, I would really appreciate. And yeah, that's all from me. Thank you very much.
Thank you. With that, it's time for a few closing thoughts. First of all, thanks everyone for coming here. I didn't ask this when opening, I planned to ask, so I do so now. Who didn't attend the BazelCon before this one in person? Wow, that's a big portion of this group. Great, thanks for coming. I hope you formed some new connections with people you have not interacted with before. I hope those connections are fruitful in the future, that you engage with people you got to know during these 2 days. If you didn't interact with anyone you didn't know before, there's still time this evening. So do so, please. Stay in touch, for example, on the Bazel Slack. I want to pick up what we said yesterday in the keynote. Hold us accountable, especially for transparency. When we're not transparent enough, let us know, and we will try to fix that. And the second, where we want to share ownership, step up, let us know, hey, I want to own this piece, and we probably can make it happen. So come to us, we want to actually do this step. And finally, I want to encourage you to do some work for us. in the sense of testing. This is one of the parts where we actually rely on you when we get out a major release. We need your feedback. We only have limited amount of view, what works, what does not. We can only test with the projects on Bazel CI. If that's green, that's a good signal, but it's not the whole world. Test Bazel 7 in your proprietary projects and give us feedback. Let us know what works, what doesn't work. With Bazel-esque bisect, for example, you can find out which commit is the culprit that broke you. And you can also help us with migrating to Bazel 7. I'm looking at all the rule owners. You need to do this first. Finally, it's time to say thank you. There's a couple of people who we should thank. Let me start with our friends from Isa Helden, who helped us to run this conference, and make some noise for them. Then I would like to thank the ESO team. You have not seen them, but they assisted us with the live stream. So I think they can also hear you. Of course, we got support from the food team. I think it was a challenge to serve 220 external guests on top of the regular food, especially during lunchtime. I enjoyed the food. I hope you did as well. Thanks for everyone who was speaking at the conference, who was hosting a BOF session, who was hosting office hours. And last but not least, it would not have been possible for me to organize this conference alone. I got a lot of help from all these people, selecting the talks, scouting the venue, talking with the event agency, talking with the live stream people, doing speaker interaction, thinking about budget, thinking about all the stuff we need to do. I think big round of applause to all of them.
And of course, it wasn't last, because I have the last word, and that is to thank Toby, who was the glue that put all of this together, in addition to an amazing job on his day job, which is running the Bazel team here in Munich. So please give a really loud.
With that, I think we're done for this year's BazelCon. Feel free to stay for the happy hour for GCP and BuildBuddy, and otherwise, safe travels. See you next year.